Hello, everybody. Welcome to the day. Oops, just a second. Welcome to day 4 of our celebration week. No, day 3. Day 3. I'm still warming up. Oh my God. So, welcome to our day 3 of the celebration week. I am Karina Varela, your favorite host, and I already have our first speaker of the day with me here on the backstage. So call everybody, start spreading the word, retweet, repost on LinkedIn so that we can get as many people as we can here to watch our friend Eric Deandrea. In Portuguese, Eric Deandrea. Eric Deandrea. He's from Red Hat, and he's here to tell us. We will kickstart our day by talking all about RAG, Retrieval Augmented Generation. So how basically we can give information to an LLM that has not been trained before on this particular data and still be able to leverage it to help us on our Java applications. And nobody better than Eric could tell us all about it. And he's going to bring us insights on tools for developers. Hello, Miguel. Good morning. He's going to tell us about tools for developers and how to do that. He is a Java champion, and I'm very proud to see he became a Java champion around 1 year ago. So welcome to stage. I'm very glad to have you around, my friend.
Hey, good to be here. Good to be here. I'm just signing into this YouTube chat thing so I can chat with people as well. I just realized it's like, hey, you gotta connect your account. You gotta connect your account.
Sure. Okay. Yeah. Feel free to do so. By the way, Eric, while you are connecting and doing the stuff, for how long have you been at Red Hat? We worked together for a long time ago. Has it been over 4 years that we were?
Over 6 years.
6 years.
Yeah, I joined in 2019.
Wow. All right. It has been such a journey for you, huh? Red Hat is like such a rocket for careers. It's very good. Takes people every time further and further.
Yeah, you know what it is? There's a point in everybody's career where, choices you make kind of lead you down a different path. And I totally would not be where I am today if I had not made that choice. So, very happy.
And just out of curiosity, because I know that many people are, and I tend to bring these unexpected questions every session, and the speakers sometimes feel a little bit, oh my gosh, why she's asking this? But it would be cool because we don't have many Red Hatters on this event. Just kidding, we have some ex-Red Hatters and many Red Hatters too. But you are currently going through a phase which many people will not quite understand what it means. So Red Hat many years ago has been acquired by IBM, right? We were all there when it happened. The company, the open source company, actually it was $33 billion. It was the highest value ever of a company that was acquired, and it was an open source company, right? So now we know that some of the people on Red Hat are going to the IBM team. So how has that been for you? And this is happening across many products in Red Hat. They are going to the IBM team. So if you just want to share some words regarding will Red Hat products die and all this fear that will happen on the market, so just tell the people a little bit about it.
Yeah, nothing's changing. So they made an announcement publicly back in February that they're transitioning all of what they call their runtimes portfolio, which is EAP and OpenJDK and all that stuff from Red Hat to IBM so that it can be invested more in where Red Hat can focus more on other things. IBM wants to invest in it. So not just
the team behind OpenJDK is also coming, right?
Yep. So the product management, the engineering, everything. So it's hundreds of people we're talking about. It's not a small move.
And I've been there on that position many years ago. The product that I used to work with in Red Hat also transitioned over to IBM. One of the fears that people have is if it's gonna stop being open source. I can tell you up front, no. Products from Red Hat, we just have this in our blood. We cannot do anything other than this. This is how we live. We breathe open source. So you don't have to worry about it at all. So with that being said, Eric, just tell our audience, why should they listen to your talk before you get started? Why should they stick to until the end to watch what you have to say?
Yeah, so I know when I first, this AI stuff it changes so fast. And when I started learning it, I like to learn things from a technology agnostic approach. Yeah, I know this is a Java celebration, and sure, I'm going to talk about some of the Java implementations, but just from a higher level, thinking about the process and how it should work and some of the best practices and things you need to think about, regardless of the tech stack, whether you're doing RAG or function calling in Python or JavaScript or Java or whatever, and then taking that and looking at what other tools like LangChain4j provides for making it easy for you to do. And because I think, like, if you think of all the large enterprise organizations out there, they're not going to switch from Java to Python. That would be like years of work and years of work that they've had that would have to throw away to start over. So
exactly.
every tool has its place, right? And so looking at how do we do this in the Java ecosystem? Do I think we're going to be using Java to build AI models? Probably not. That's probably what going to stay in the Python world, but there's
also
no
because
reason.
it's a different knowledge set. It requires for people like that to learn about really how to use data sets to train these LLMs. It is a different knowledge ground, right?
Yep, it's a different set of knowledge. I don't know how to do it. I don't know what it's about. I'm not a mathematician or a data scientist, so a lot of the concepts that I'm going to talk about here are just take it on blind faith as a developer, right? That it just works.
I have, and also it's going to be cool to hear from you, because you, and as I as well, we come from a time when we didn't need to study all this stuff, and we also had to get started anywhere. Now things are way easier from then we had to get started with it. So as you talk through this stuff, it will be really cool to get your insights on for first time RAG developers. Like if you're creating it for the first time, what are the key things they need to know? So without further ado, let me give you the stage, because we have a lot of amazing speakers today, and I don't want to take your time too much. So Eric, the stage is yours.
All right. So before you disappear, how much time do I have?
Oh, I'm around here. Don't worry, I will not disappear. I will be here interrupting you every 5 minutes, as I always do.
Every 5 minutes? All right. I'm going to put a timer on.
Of course. So you got until like almost 30 minutes of the next hour. So it's now 10:42 here, 11:30, for instance. Okay.
Excellent. All right. So maybe we'll get through all of this. Maybe we won't, because I threw some extra, like MCP is a new rage now. So I threw some of that in the end of this. If we get to it, we get to it. If we don't, we don't.
MCP.
Yeah. So, oops, that's not what I wanted to do. So let's talk a little bit about me. I know, Karina, thank you for the gracious introduction. I've been doing software development for a long time, 20 plus years, 26 years. I've always been involved in open source, even before working for software companies, both consuming and contributing to different open source projects. I also help run, I live in Boston area, or just north of Boston. So I help run our local Java users group. I'm on the board of that, and we've pretty successful year this year. I highly recommend, if you're not involved in your local users group, like Sue Java, get involved, because it's a great way to meet people, to have conversations, to talk about technology, and just to kind of grow your career, especially if you're new to software engineering or new to industry, or you're a veteran, been around forever. It's a good way to meet people and a good way to talk about things and to constantly learn, which is exactly what's going on here, right? So my social handles are down the bottom. You notice there's a little red thing through the X there. I'm actively trying to get off of Twitter or X or whatever you call it. So I still kind of respond to stuff there, but I'm trying not to anymore. So maybe the next iteration I won't even have.
Do you really want to start the polemics about Twitter now?
Yeah, just kind of throwing it out there. People might wonder what that icon is. So I'm just kind of throwing it out there. So I have also written this book, which has nothing to do with what I'm going to talk about. So if you know me, I'm a big into Quarkus, and I've been a proponent of Spring and a contributor to Spring in the past. So if you're looking to learn something new, if you're familiar with Spring and want to learn something new and how it compares and contrasts, I have this free book that's out there that you can download, but that's really not why I'm here today. There's also this book, if you want to learn more about LangChain4j. My friend Antonio from Microsoft wrote this book. I think it was released around DevOps Belgium time, so October of last year, but kind of goes through LangChain4j and talks about and looks at everything in there. I don't know if it's free or not. I don't know. It was free for me. So let's talk about this thing called RAG. So RAG, Retrieval Augmented Generation. There's two parts to RAG, and every demo that everybody shows, myself included, I'm guilty as well. Every demo shows both parts happening in the same application, which isn't really how things should work in reality. In reality, these two stages, the indexing and ingestion, should be separate, or is probably separate from the retrieval and the augmentation part of this. And the reason for that is,
before we get started here, Eric, because you are the first one talking about RAG during in the week. So just give like a broad reason, a broad explanation on why we should consider RAG instead of training an actual model. For instance, I have a product. Why should I train a model, or why should I use RAG? When to use which one?
Yeah, so I don't think there's like a hard like rule that says when to what. Some of the guidelines that I go by are how frequently does the data change. So if you're talking about data that changes rapidly, and rapid could be days, hours, days, weeks, some kind of time frame. If it changes frequently, you probably don't want to train that into the model. So you want to be able to enhance the model with that data. If you're in an organization that just wants to use off-the-shelf models like ChatGPT or Claude or Gemini, or pick your favorite model, you just want to use off-the-shelf and not have to worry about the training part or the maintenance part or the running it locally part, and you want it to understand and know about your own data, then you would want to use RAG, because RAG is a way that you can enhance what the model knows about without having to retrain the model. That being said, there's always trade-offs. There's costs involved, there's tokens involved, and I'll talk a little bit about what those costs are. But there's, like everything in engineering and computer science, there's no silver bullet. There's no one solution that solves all problems and is side effect free, right? So it has trade-offs. So that's kind of when you might want to use it, when you might want to do fine tuning, and it really depends. The typical architect answer for everything is it depends. It's more about understanding what the trade-offs are and when you're okay with the trade-offs and when you're not okay with the trade-offs, if that makes sense. So there's two parts to this. There's the ingestion part, and then there's the retrieval part. Generally speaking, myself included, like I said, when you do demos, you do both of these in the same application. Usually the application will do some kind of ingestion at startup so that the data is there, and then it'll do the retrieval, augmentation, and all that fun stuff to show that it's enhanced the model. But generally speaking, you want to separate these processes. Usually the ingestion process happens out of band somehow, whether it's a cron job or it's event driven, or I've seen people use like the change data capture pattern, where you have you might have applications that store data in a relational database, and then you watch the transaction log and you take the transaction log data and you populate it to Kafka, and then you have something that listens to Kafka, which can keep your ingestion pipelines up to date. So that's one pattern I've seen. I see other things that are just more batch based, like once a week, go through and wipe out your ingested data and repopulate it. So there's lots of different ways to do it, but generally speaking, it's an out of band process that happens. And so it kind of looks somewhat like this, and I'm going to kind of walk through each of the steps. So the first part of that is obviously you got to find the data. So you've got data somewhere, and that data could be in documents on a file system somewhere. It could be on a class path. It could be available at some URL or in some S3 bucket or Azure or GitHub, or you can start to imagine all the different places where your data might be. And LangChain4j provides these building blocks to be able to start building ingestion pipelines for wherever your data might be. Right. So once you've got a reference to your data, then you've got to figure out how to parse it, right? And this whole thing is part art and part science. Like sure, I know how to parse text documents, or I know how to parse PDF documents, or I know how to parse Excel spreadsheets or web pages or whatever. Sure, you can parse them, but you need to kind of think about the whole point of RAG and ingestion is, once the data is there, you want to be able to essentially ask questions to your data and find relevant answers. So kind of like everything else, if all you throw in is garbage, you're going to get garbage out on the other side. So you kind of have to pay attention to how you do your parsing and how you structure your segments. Because when I do a query, I don't want to return an entire book as the answer to a query. I want something small and simple, or maybe I want a couple of responses where maybe each response is a sentence or two. So you need to structure your parsing in a way that makes sense so that things are related to each other, are kind of near each other or similar to each other versus getting, like I always use the apple example. So living in New England, the fall is apple picking season. And the fall is also when Apple Computer usually releases its new operating systems and phones and all that fun stuff. So if I ask it a question like, hey, at the first week of September, what kinds of apples are ready for picking in New England? I don't want to know about the iPhone 21 or the latest version of Mac OS, right? Even though it has the same keyword, the context is completely different. So that's kind of what I'm talking about here. So because your data could be large, it needs to be split, right? It needs to be stored in consumable. Like if I were to ask the question about the apple in like a sentence or two, like I need to be able to split it. So to split it, you have to think about what's the representation of the data. Is it like a markdown file that's separated by chapters? Is it a PDF of a book? Is it a web page? You know, what is it, and how do you want to split it so that when you query it, it actually makes sense? Because at the end of the day, you're going to come up with tokens. And if you're not familiar with what a token is essentially text that you're going to send to the model to parse and produce a response. And when you're talking about public models that you pay for your tokens, right? So the more tokens you send in, the more tokens you're going to get back, and the more money you're going to send to whoever the provider is. So you've got all this stuff that you've got to think about in the back of your mind that you want to tune, and there's no really one right answer. It's kind of like an it depends answer. And it depends on the data, it depends on your organization, it depends on what you're trying to do with it. So applying like the same strategy for all of your data probably isn't the best approach. You need to think about it for each data source or each kind of bucket or classification of data. Maybe you've got a bunch of manuals, or you've got a bunch of user guides, or a bunch of books, and you categorize them differently, and then you process each one of those categories a little bit different. And then you got to think about overlap. So if you've got two segments that go back to my Apple story, maybe you've got one sentence that talks about the kinds of apples that are available for picking in September, and then the next sentence talks about, like, for a particular kind of apple, like what its makeup is. Is it a sweet apple or a sour apple, or what it looks like, or something like that? You probably want a little bit of overlap of those sentences, so when you query it, you get both as a result. But the more overlap you have means that one's going to overlap with the next one, and that one's going to overlap with the next one. And so you could start getting irrelevant data. So again, it's part art and part science. The how to do it is actually the easy part here. The figuring out what you actually want to do is the harder part. So, and LangChain4j provides out of the box a bunch of building blocks to do this. So if you're talking about text data, there's documents by paragraphs, by lines, by sentences, by words, by characters, by regular expressions. And then there's the thing that everybody, including myself, uses in all their demos is just called a recursive. You basically say, I want a text segment that's no longer than 500 tokens, and I want 50 tokens of overlap. And it'll apply all of these in recursively and in sequences to get what you want. Is it the best way to do it? Probably not, but it's what everybody does because it's easy to get started, right? There's also other tools that are outside of LangChain4j that can help. There's the Dockling project, which is actually an IBM open source project, which is really good about images. So if you've got a document that has images and you want to have an understanding of what that image actually is, maybe it's a caption on in a document or a spreadsheet or a table or something, it's really good about being able to process that. I'm working with Alex Soto on a Quarkus extension for Dockling, which kind of bridges Dockling to LangChain4j. It's not quite there yet. It's still under development, but that would be something that you could plug in here as well. And so once you've got it split, then you need to calculate an embedding. And an embedding, this goes to the mathematical part of it that I don't quite understand, but essentially you send it the text and you get a vector representation of that you could plot on some multi-dimensional graph, which basically can give you the how closely related different things are, even if they have the same name. So like back to my apples, right?
Eric, I got your back. You say you don't understand embeddings. Me neither. So that is why our last talk of the day will be with experts on that. They work on a database provider that is specialized on RAG, like Weaviate is an open source database, and they will tell us all about this other part of the world in RAG. So you don't need to worry about it.
Yeah, so as a software developer, I kind of look at this as like the data that's been ragged or encoded is just in a database somewhere. So when my app, as a developer, when my app starts up, that part and that ingestion part's kind of already been done, and it's just a data source to me at that point. And I'll talk about that when I get to the retrieval part of it. So yeah, so you got to create, you need an embedding model. You need to create your embedding for this. And there's lots of different embedding models out there. There's open source ones. There's ones that you pay for. Your mileage may vary. I found like anything that I can run on my laptop with a llama is not as good as anything that you pay for. Just, FYI, it's good to test with. So test is a whole nother story that we can have a whole nother conversation about on another day. But yeah, so you've got to create an embedding. And once you create the embedding, you've got to store that embedding somewhere. And so that sequence of numbers and vectors, you've got to store it in a vector store. So you mentioned Weaviate. Weaviate is one of them. There's a bunch of them. You can do it in memory, Elasticsearch, Milvus. There's a whole bunch of them out there. But what's important is you don't want to just store the embedding, is you want to store metadata about the embedding. So like you probably want to store the original text that was used to compute that embedding, because once you get your results from on the retrieval side, you're going to need to send that to the LLM, and you're going to send them the text, not the embedding. So, and you don't want to have to do that backwards computation. So you probably want to store the actual text that goes with the embedding. And if the data is specific to something, maybe it's for a particular user, or if it's for a particular product, or whatever it is, any kind of metadata that you can associate with that data, maybe the source location where it came from. So that way, when you retrieve it later on, you can provide references to it, or you can filter on it. Like if you're trying to query, you have a product database and you're trying to query information about a particular product, well, you can only narrow the results of the retrieval down by product if you tagged it with certain metadata when you ingested it, right? So you can only use data that you have when you do that. So yeah. So this is kind of how I was when I first learned this. And honestly, the implementation part, the actual doing of the thing in LangChain4j is super easy. I mean, you can see the code here, it fits on one page. All the building blocks and pieces are there to actually ingest. In this case, it ingests a set of documents on the file system from a certain path and tags them with a certain user ID, and then also puts the source of reference, like the file name, in the metadata, and then it loads the database. So this, what is it, 20, 15 lines of code here? I'm not counting, but plus all the white space and comments is actually pretty easy. It's the figuring out what you actually want to do and how you want to parse it. So like at the very bottom there where it does, I don't know if you can see the mouse, but like load documents recursively, that's kind of the poor man's approach. That's the lazy way to do it, that I said not to do it. And then here's the recursive way of doing it, right? That's the easy way to get started, where you don't have to put any thought into it, but you could end up with garbage. So is this approach the best way? This is really where you'd want to think about, this line here and this line here are the two kind of important lines where you need to put some thought into it. All right. And I'll show a real world example in a minute. So yeah, so the code isn't bad. It's just the thinking about how you actually want to do it and how you want to structure it and how you want to structure your data is the hard part. So once that's there, kind of like I said, that goes into some vector store, which on the flip side, when you're building an application that wants to use the data is just, it looks like a database, right? It's sitting there in a vector store, and it's there for you to query. So when you want to use that data, now the user, I don't necessarily mean a user like a human being. The user could be a system or a process or something. But when you actually want to send a query to the model, you first need to query that vector store to get relevant results. Maybe you want to sort them and group them, and then you want to append those to your prompt. And I'll walk through each of the steps here. So the first thing you do is you take whatever the query is, Again, it could be a real human user, it could be a system, it could be something else. But you take that and you use your embedding model and you compute and you do an embedding computation. So you get your vector store or your vector for that. And then you query your vector store for it. So you want to get results based on similarity. So there's lots of different mathematical ways to do similarity. There's cosine similarity, there's distance measuring, there's, if you're a math nerd, there's lots of different ways to do this. Maybe the Weaviate friends at the end of the day can go into that a little bit more. But essentially you ask the vector store, you say, hey, here's the query, give me 5 results that match this with 70% or more similarity, or 75% or 80% or whatever you want similarity, and order them by similarity. So you get those segments back from your vector store, and then you need to stuff that into the prompt. So you need to augment the prompt, the original prompt that came in, and say, oh, by the way, here's some extra stuff that you have to use in your answer. So because the LLM doesn't know anything about your data because it wasn't trained on your data set. So now you're saying to it, oh, here's some extra information that's available for you that you can use when you formulate a response, right? And so this part, again, the code is actually very easy to do. This is specific to Quarkus, but it's using just upstream LangChain4j. Quarkus just adds the CDI bean injection, but the rest of the code here is just straight up LangChain4j. You create your embedding store, you tell it how many results you want, what your bin score, and this is where you can do your filtering. So say that that you've got a chat bot where the chat bot is in the context of a particular user. So like I'm a user, maybe I'm working with American Airlines, or I have a flight on American Airlines or United or some other airline, and I'm using their chat bot because I want to reschedule my flight or look at the flight status or something. So the chatbot probably already understands the context of me as a user. And so when you start doing this RAG, you can actually start to filter the data that's specific to a particular user or to a particular product or, a particular day, maybe. So, but you can only do that filtering if that data is available on the ingestion side, right? So that's pretty easy. So that's the easy case of RAG. The retrieval part can get far more complicated, right? So you can think about, well, maybe I've got multiple sources of data. Maybe I've got a vector database, or maybe I want to do a live web search at the same time, and I want to aggregate the results. Or I've got multiple vector databases from different data sources. Or, you think up, you can over-engineer anything you want here. So there's lots of different ways where now you could actually start to get smart about, hey, take a look at the question, and maybe the question that they're asking is only relevant to a certain data source, but not another. So you want to be smart about where you route that query to find the relevant contact. So there's lots of different ways to do that. So in this example here, I'm going to show live code in a second, but this example here, again, I'm doing the same grabbing from the embedding store, but I'm also going to do a Google web search and return 3 results. And then I'm going to combine the results together before I augment it to the prompt. All right, so you can start to get pretty complicated. In this case, it's just throwing them all in. It's not doing any re-ranking or aggregating or anything. It's just get 3 from the vector store, get 3 from the web search, put them together, and then that's going to be my data set. Right? Or you could get, like I said, even more complicated, where you say, hey, I want the language model to actually decide based on the question, what the better data source is, or to go to both. So I've got some local documents and I've got a web search, and let it decide where to go, or to go to both things. And if it fails for whatever reason, then just send it to all, kind of falling back to the previous language. And again, this is all just straight up LangChain4j, nothing fancy in here. Yeah, so there's lots of stuff going on here. So let's go take a look at an example here. And get my mouse. So I've got some code. So all this code lives in. I have a link. I have at the end of my last slide. I've got a QR code for this, but this is all out in GitHub. Goes along with this talk. So we have a whole deep dive that is kind of like 3.5 hours, soup to nuts, LangChain4j in a box, and this is just one of the modules from it. Excuse me. So this is, if I were to run it up, so this is a Quarkus application. If I fire it up here, it's a chat bot that I built, which understands how to chat with the Quarkus documentation. And you might start to think, well, that sounds pretty difficult, right? So before I show the chatbot, I've got two data sources here. One, I took the contributing guide from GitHub and I created a PDF of it, which is here. Hang on, I'll show it to you in a second. Which is here. It's really small because I've got a really big monitor. So I've got the Quarkus.
I can tell. It's probably huge by so
Yeah.
small, by how small it is.
Yeah, I've got a 49-inch widescreen monitor, so it's huge. So I took the contributing guide from GitHub and I created a PDF of it, right? And then I just dumped it on the class path. So nothing fancy or special. So I've got that data source. So that's getting processed, of course, at application startup, because that's what everybody does in a demo. It processes it and stores it in a vector database. And in my case, I'm using PG Vector, which is a Postgres database with a vector extension. I find it's pretty common. It works pretty good. You don't need an account or anything to run it. And then I'm also going to do a web search. So I'm going to use there's a web search engine called, I don't know if it's pronounced Tavili or Tavili or whatever, but there's a web search that's geared around LLM search capability. And so I've configured this. If you look in my properties, I've configured this just for the Quarkus.io domain. So of course, I have an API key, which I'm not going to tell you what it is. I'm using ChatGPT. I'm using the GPT 4.0. I should probably up that to 4.1. But yeah, so I'm having it do search and include answers and have how many results I want it to give. So when I come to my chatbot here, if I try to ask it, hi, can you tell me what the weather today is in Boston, which is where I am. It's programmed to kind of ignore things in a polite manner, so it shouldn't actually tell me anything here. And if we can look at the logs, you can see, actually I don't have logging turned on, so you can't look at the logs. What's going on here? I think I need to refresh the page to get a new WebSocket connection. Yeah, because I started a new instance. Can you tell me about the weather in Boston today? Now it should be going. Yeah, see, it made a post request. It's doing a web search. I probably could guard this a little bit better to bypass the RAG if the question isn't relevant. So there's still some work to do, but it essentially says I'm here to help with questions about Quarkus. For information about the weather, I recommend using a weather service or search engine like Google. All right. So what is Mutiny, which is the Quarkus reactive framework that you use if you want to do reactive programming in Quarkus. So Mutiny is an intuitive and driven programming library for non-blocking I/O, blah, 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 blah. And then it actually gives me a reference to the documentation, so then I could go to here and I could look at the documentation for Mutiny, because the web search returns the URL or the source of record of where it obtained that from. So like if we were to look at here, it's probably going to be way too many logs because it streams, but if we could actually look at the Tavili response in here in the logs and look at what I see here. Here's the URLs and all that stuff. So that's pretty neat, right? So I could go in and I could change it. I could do things. I could change the way it, if I wanted to make it so that it detected that the question was completely irrelevant to Quarkus, that it wouldn't go through the RAG pipeline and it would just respond back. I was lazy. So it'll always go through the RAG process, even no matter what the question is. But if you look at what the actual prompt looks like in this is like kind of the meat of how everything works here. I've got a session scoped agent, which means because I'm using WebSockets, it will automatically bind an instance of my LLM interaction to the WebSocket session. Because I'm using WebSockets, it's something Quarkus will do for me automatically. So if two users were to come and have chats, those two users have completely isolated sessions with completely separate memory and chat histories and whatnot that go along with the LLMs. And so I just have a system message. I'm a friendly question and answer thing, blah, blah, blah. If the question is unrelated, politely reply that they should use Google instead. And please provide references where they're found. And then whatever the incoming message that the user typed is the user message. And so, yeah, so that's, in a couple of lines of code. And then the ingestion part of it, like I said, is done at application startup, which it really shouldn't be. I'm just splitting the document and then I'm ingesting it. Nothing fancy here. Cool. I guess any questions? I should have said this at the beginning. If people have questions, let's take them as they come.
Yeah, don't worry. So far, we are good here.
So far, we are good here. All right. All right, so that's RAG. So let's talk a little bit about tools. So these concepts kind of start to build on each other a little bit. So function calling, agents, tools, to me, are all kind of interchangeable words or nomenclature. So when we talk about agents and tools, what we're talking about is where with RAG, we extended or gave the capability for the model to understand data that it wasn't trained on. With tools or functions or agents, we're expanding the capabilities of the model to invoke operations that it doesn't know how to do, or that wasn't programmed to do. So think about, like, I want to tell it to, hey, show me all my car reservations or show me all my upcoming flights. If I were to type that into a chat and it goes off and it will show me all my flights. Well, somehow it had got access to some database that knew that, and that data probably isn't, it could be done through RAG, but it probably isn't, because that data changes really frequently. It might want to be looked up on the fly. Right. So rather than doing it as RAG and stuffing it into the context, you might actually expose a capability to your model to say, hey, I've got this capability that allows you to search for upcoming flights. And then the model can kind of do a callback to your application to say, hey, I'd like you to do that now and tell me what the answer was or what the results were. And then it'll use those answers to put a response together. Right. So tools are actually pretty easy to use. Again, like the RAG pipelines, the code and implementation of it is the easy part. It's getting the wiring and all the possible things that could go wrong, which I'll talk about in a couple minutes. So with LangChain4j, when you build your AI service, and I know you might not know what an AI service is, it's part of what I would talk about if I were doing this whole LangChain4j talk, but essentially it's a higher level abstraction. So rather than having to write the code that actually performs the request, you can just build an interface, and LangChain4j will give you the implementation of that for free, kind of like I did here in this code here. So you see, I have an interface and I can define methods that make sense for me and operations that make sense for my business. And I can use annotations. This is what we call an AI service in LangChain4j. It's just it's a higher level abstraction on top of the underlying stuff. So, but in any event, to create a tool is you just create some class and you have some operation and you just annotate that operation with this tool annotation that telling it what it does, and then you provide access to it. Right. So part of developers, one of the hardest things in computer science is naming things. So like string S, what's going to happen is when it sends the response or the request to the model, it's going to describe all the tools. So it's going to say there's a section in the payload that says, hey, I have this tool called string length. It has an argument called S. Well, S doesn't really mean anything. So again, being more explicit here with your words is probably better. Using variable names like S and X probably aren't helpful. You probably wanted to use something a little bit more descriptive. LangChain4j also has an annotation called @description that you can put in there that'll provide a longer text description of what the thing is. So the more verbose you can be when you describe things, the better experience, so the more it's going to work for you. So then when you in Quarkus, it's very similar. You just add this toolbox annotation to your method, and then that tells that particular operation that it has access to a particular tool. So you could think of an AI service or this interface as one model. It could be Claude, it could be ChatGPT, it could be whatever, but it's one model. You might have multiple operations that do different things with the model. Maybe they have different system messages or different user messages. You can also expose different tools to different operations, right? So you might have a method where you don't want, or an operation where you just wanted to summarize something, but you don't want it to have access to being able to list my upcoming flight. So you can decide programmatically which operations have access to which tools, right? So it's the way to scope it. And then, for example, if you're familiar with Quarkus, Quarkus has this database access thing called Panache, and it implements the repository pattern. So I could have, say I have a booking object, and I'm implementing a repository which has all of my CRUD methods for around a booking. I could take one of those and create an operation for like cancel a booking and expose that as a tool. And now I've exposed an operation in my database as a tool that my LLM can now execute, which lots of stuff can go wrong here. I haven't talked about that yet. I'll get to that. Or if you're familiar with Jakarta RS clients, maybe I have a REST client that talks to another service, like a weather forecasting service or something. I can annotate that with tools. So now I can start exposing, maybe this logic isn't in my application, but my application has access to another application. So now I can start to expose kind of this pipeline of things that my LLM now knows how to do. And so you can start to see where this is going to go. Or I can give it access to another agent. So we start talking about agentic. I could have more than one of these AI services or more than one model, which has different operations. And one of these models could be a tool that another model has access to. So the model doesn't know that it's actually calling another model, or could be another operation on the same model, right? So now I'm starting to build this. I have these agents which know very specific things, and I can give one agent access to another agent pretty easily. But here we're still talking about agents that are in the same application. So me as the application owner, I've had to build all these different agents. So if we have time to talk about MCP, we can talk about how that's kind of another higher level abstraction on top of all of this. So with agents, we're talking about being able to expose one operation on a model to another model, right? So now we've gotten completely non-deterministic, where we're giving one model one non-deterministic thing, the ability to do things with another non-deterministic thing. So, what could possibly go wrong here? But you're starting to control, or it kind of exposes two different patterns that we've start to see, where you've got the traditional workflow pattern, which I know you're pretty familiar with, Karina, where you're building a workflow and you're programmatically executing that workflow. And yeah, so there you are. So all about workflows, right? So you build these workflows, you can build them in code or with whatever tools you want, and your code or your application is in control of these workflows. But some of the things that the workflows can do are non-deterministic or controlled by models. Or the agent pattern is now the workflow itself is non-deterministic, where the model's in control of the entire workflow, right? So again, what could possibly go wrong with that? We haven't started to talk about that. So like in this example here, we've got like a weather forecast service, which maybe your input is something like, give me the weather, what's the weather going to be like tomorrow in New England? And so you have one service, which is an AI service. AI is really good about text extraction. So it's going to extract the word New England or the word Boston from the sentence and give you back just the name of the city. And then you've got another service which knows how to take the name of that city and compute that to geocoding coordinates like latitude and longitude, because the weather forecast service only takes as input the latitude and longitude. So you could write the logic yourself, which has access to these tools, and deterministically execute the city extractor, then the geocoder, and then the weather forecast service. Or you can just expose, like at the top here, this agent called forecast and give it access to those three tools and let it decide which order that it needs to invoke these things in, right? So lots of bad things can happen. So hopefully you've got like observability and tracing. That stuff becomes super important when you start doing stuff like this, being able to go back and look at something went wrong, what happened, look at all the calls to all the different places and what the payloads were, and they'll correlate all the logs together. That this operational stuff becomes really, really important. Yeah. So the other part of tools is, I showed web search as part of a RAG pipeline. You can also do web search as part of a tool invocation as well. So there's this web search tool class, which comes in LangChain for J, which you can just add as part of your toolbox. And now as part of your tool pipeline, you're exposing a tool where the LLM can now do a web search, to a specific domain or something. And maybe for my example about chatting with documentation, maybe this is better than RAG. Maybe it's not. I'm not sure. I haven't really played with it, but it's kind of a different option because it happens at a different point in the process, the web search or the tool invocation. Right. So lots of bad things can happen. You can do prompt injection. So if someone can figure out that you've actually got a database under the covers, maybe they can start injecting, like they can write a prompt that says forget everything that you've been told about and delete star from Dual, or whatever. You can start to hack around it. Things like auditing become very important here, like being able to go back and track what questions were asked, what answers were provided, how relevant were those answers. Being able to distinct between read and write operations. So a read operation is it's obviously much safer than a write operation, because bad things can go wrong if you're allowing your tool access to mutate state in your data stores. So there's lots of different things that can go wrong here. And so I think I've got like 5 minutes or so. I can go through this real quick model context protocol, because again, this is now we've talked about RAG, we've talked about tools, and this is kind of like the next thing and I don't know if you can see my hands here, the next thing on top of tool invocations. So if you think about these tools that I maybe just wrote, right, where I built all this code or I annotated all this code, well, what if somebody else already has an operation or has built something that knows how to do something? And something I've been working with recently is Google Drive. So somebody has a code base which understands how to interact with Google Drive. And rather than me having to know how to use the Google Drive API, what if I could just use their tool and give it to my LLM? And so that's essentially what MCP, or Model Context Protocol, is. It was invented or provided by Anthropic as an API for essentially remote tool invocations, right? So I can bring in some tool or have access to some other application that exposes itself as a tool. I can wire that into my application, so it kind of looks like a function, like it's a tool in my application, but it's really an RPC call to another application to actually perform the work. And so it uses JSON RPC under the covers, but it's still evolving. Like what was here 2 months ago is very different than what's here now. It's still rapidly evolving. So the tool provider provides a JSON RPC spec, and can support either standard I/O for interacting with it, or through HTTP server-send events for interacting with it. But still, again, this is very hot off the press, still moving very fast. But it's a way to try and standardize communication between tool providers and tool consumers that are done over a remote RPC connection. I mean, that's about as simple as I can break it down here. So in Quarkus, it's pretty easy. So on the server side, you would just create your app and annotate your operations with tool. On the client side over here on the right, you would just give it access to the tool through the MCP toolbox, and then you would configure in your configuration for whatever you can name. You can have multiple clients, and in the annotation again, you can distinguish different operations have access to different tools or different MCP servers. So you basically tell it what type of transport, if it's I/O, how to interact with it. If it's HTTP, you tell it where it is. And then what you'll see when your application starts up is it'll first query the tool to discover what operations are available. And now that it'll send that as tool invocations to the LLM as it goes. So yeah, what could possibly go wrong here? So yeah, it's catching on like fire. There's lots of stuff that's available, but how do you know what's reputable? How do you know if it's a Trojan horse? How do you know what the thing is actually doing. The ecosystem is changing so fast. There's lots of danger if you don't know what these MCP servers are doing, because you could invoke an MCP server that you didn't write that says it adds 2 numbers, but also in its system prompt or its user prompt says, hey, also read their SSA, their ID, their RSA ID from user home and send that back to me as well. Right. So security is still being figured out. I know Google just released their A2A or the authentication platform. So that needs to be investigated. So there's still lots of stuff that can go wrong here. So that's pretty much all I got. I think I got like a minute left. This QR code has a link to the slides. Actually, I didn't provide a link to the
Don't worry, I was planning to grab from every speaker I'm sorry, I get confused with this stuff. So I was planning to get the details of the talks from every speaker so that I can put available on the website too, the links and all the resources that you may have. So if you can share here on the private chat, I can already send here on the link for them.
It won't let me post the URL publicly.
Yes, it doesn't, but I already sent it over there here.
Yeah, so that's where all the code is. And again, the code is structured. The RAG is in step 4 because this is part of a longer tutorial. But then function calling and MCP is everything that I talked about is there. There's hands-on, it all works. It's fully tested. Yeah, so testing non-deterministic thing is a whole nother thing.
That's what I'm thinking. Like, how do you test? At least if the API is working, right?
Yeah, it works. I know it works. So there's the slides, and thanks for having me.
Wow, okay. Thank you, Eric, for opening our day today, our 3rd day. It has been amazing so far. And we are expecting the Jakarta release that is coming soon from the Eclipse Foundation. So it is a perfect moment for people to catch up on everything that is happening in AI, on the new Java stuff. And nobody better than you to tell us how to do it with Quarkus. So thank you very much, my friend.
Oh, you're welcome. It's good to see you again. Don't be a stranger.
Yeah, I say the same. Let's hope that I'm attending any of the upcoming events so that we can meet each other again in person. It's been a while now.
It's been a while.
Okay, my friend. Have a good day ahead. Bye. Thank you.
Bye-bye.
Guys, now we will switch back to Portuguese because our next speaker is already here. So if you are an English speaker, don't worry. We will be, maybe you can try the captions button. I don't know if that's working on the channel right now, but we will also provide you the translation in case they are wrong. We will provide the fixes for it for every day of the event. So you don't have to worry about it at all. So English sessions are going to have the Portuguese translations polished, and Portuguese sessions are going to have the English translations polished. So don't worry, you will have all of it available. I will also work on breaking down each of the chapters of the long video, because yesterday, for instance, we had almost 7 hours of live stream, like non-stop. Yeah, the day before that, almost 6, and today it's even more because we have speaker after speaker after speaker. Today we don't even have a break. So warm yourselves up and let's go, because I already have here with me. Agora eu já tenho aqui comigo Mestre Isidro. And Eric is laughing on the backstage here because I'm like doing all the Portuguese with English mess here. So I already have here with me, comigo, Mestre Isidro, galera. O Isidro é uma pessoa brilhante. Não só ele é um profissional excelente, assim, nunca vi uma pessoa com didática tão incrível quanto a do professor Isidro, como também ele é muito bom no que ele faz. Ele não fica só falando de trends, de hype, ele de fato te ensina a base do negócio ali, como que tudo funciona por trás. Então, se ele vai te ensinar sobre Spring, ele vai lá e te ensina como que cria, o que o Spring faz. Então, se você vai ver no curso do Isidro, por exemplo, tu vai aprender a criar um Spring, né? Tipo, você quer fazer um Netflix, ele tem um EasyFlix. Então, o cara é assim, ó, sensacional. E eu tô super curiosa para ver essa talk dele, que eu ainda não assisti, que é sobre AI Agents. Então, Isidro, welcome to stage. Bem-vindo,
que legal, Karina! Eu não sei se eu falo inglês ou português, mas como a gente já tinha combinado, eu falei, cara, preparei tudo em português, mas se a galera quiser que eu fale inglês, também falo, não tem problema nenhum.
Não, a gente pode fazer em português, porque hoje tava sem toques em português, eu falei, vai ser ótimo, então.
Ok, então...
Perfeito.
Aí qualquer a gente mistura também, vai dar uma de Joel Santana aqui, né? Fala um pouco de português e um pouco de inglês, e vamos que vamos, né?
Mas eu vou te falar que a galera tem um preconceitozinho com quem é acadêmico, e você é PhD, então... Conta pra galera como que você fez para quebrar essa bolha do mundo acadêmico para, de fato, vir para o mercado, porque você tem um conteúdo up-to-date.
Então, pois é, isso é muito fruto, acho que assim, de um esforço extra, né? Porque assim, o que acontece? Estar na academia, acho que eu diria o seguinte, né? De forma muito geral, o ambiente onde você está, se você deixar, ele te engole, né? E estar na academia é muito comum, né? E isso não é demérito, não, de você, obviamente, meio que ficar engolido naquele ambiente de, cara, paper, orientação, preciso publicar em congresso científico. Isso é muito bom, isso precisa ser feito. Mas eu comecei, eu imagino aí, logo que eu entrei na UFABC, eu percebi que qual era a proporção de alunos que eu tinha que iam para o meio acadêmico, qual era a proporção de alunos que iam para o mercado de trabalho. E era praticamente uma proporção assim, 5 para 95. 5 iam para o meio acadêmico, né, para a vida acadêmica, mestrado, doutorado. Os outros 95 queriam ir para o mercado de trabalho. Assim, só que assim, obviamente, há uma tendência, um viés para, se você está numa universidade pública, para você ser formado para ser um pesquisador, um cientista. Isso eu acho sensacional, porque isso te dá casca para resolver problemas difíceis. Isso é fato. Só que eu não posso também aproveitar essa mesma formação e tentar formar profissionais um pouco diferenciados? Acho que essa foi a minha virada de chave principal, né? Mesmo estando num ambiente acadêmico, onde a base é muito cobrada, onde o fundamento é muito forte, é muito denso, por que não usar isso para a gente conseguir colocar também esses aspectos na formação do profissional que vai atuar no mercado de trabalho? E por conta disso, o que a gente precisa de um profissional atualizado? Cara, um cara que sabe aprender, uma pessoa que sabe aprender, que saiba encarar desafio, vamos dizer assim, que mesmo diante do desconhecido, né, tenha um pouco de autocontrole para poder segurar um pouco a bronca, né? Então, nesse aspecto, eu falei, beleza, isso a gente consegue formar, porque isso é meio que o DNA da universidade. Tá bom, como que a gente consegue...
Só para você ter que lidar com o aluno, você já tem que trabalhar sua paciência. Eu lidando com o adulto no mundo corporativo, eu já tenho que ter paciência, imagina com o aluno, não dá?
E às vezes, assim, mas a parte boa é que às vezes, no mundo acadêmico você não tem aquela tal vaidade, né, a síndrome da caixinha de fósforo, manja, com os alunos.
Não, é o
quê?
A síndrome da caixinha de fósforo? Não sei, não.
Que o cara subiu na caixinha de fósforo e já se acha melhor que os outros, né? A síndrome da caixinha de fósforo. Subiu na caixinha de fósforo, nossa, né? Tipo, não tô num pódio, cara, eu só subi na caixinha de fósforo, sabe? Mas com os alunos, eu sempre tive uma relação muito, muito saudável e muito, vamos dizer assim, acho que ela extrapolava um pouco essa relação somente professor-aluno, né? Catedrático e estudante, né? Era uma relação muito de parceria, de talvez até um mentor, né? Fala assim, vai por esse caminho.
Isso na universidade, você diz, né?
Na universidade e também com os meus alunos, principalmente
por fora, para ser sincero, eu vou te interromper como sempre,
claro,
né? Mas por fora eu já vi você mudar vidas, assim, de fato, agindo mais como um mentor do que como um professor, então...
E querendo ou não, qual é a função de um professor de verdade se não for essa? Porque, cara, passar conhecimento, velho, na boa, você abre um livro, você consegue ler. Você pega um material no YouTube, você assiste uma palestra, você consegue... Eu acho que o grande segredo, se a gente quiser, obviamente, tiver essa disposição de fazer diferença na vida das pessoas, é justamente a gente conseguir colocar um pouco assim, mostrar para eles, a vida real funciona mais ou menos assim, e a única diferença que nós temos é que eu tomei porradas antes de você, né? Significa que eu tomei mais, ou que eu tomei menos, ou que eu bati mais forte, que eu apanhei mais forte? Não.
Depende se você trabalhou com Java antes de ter annotations ou não. Aí você vai ter apanhado mais.
Sim, eu apanhei apanhei que nem um cachorro e trabalhei com a JB fazendo um monte de XML que eu tava ficando louco. Que eu falei, eu nunca mais mexo com essa... Que eu achei que o Java fosse até morrer nessa época, viu, Karina? Eu falei, cara...
ferro. Isidro, conta pra galera aí do Brasil aí, já que a gente tá no português. Qual foi a sua primeira versão do Java? Só por curiosidade.
1.1, na verdade, 1.1. Final de 96.
Respect.
Peraí. Eu acho que a 1.1 foi lançada em 97. Eu tava vendo as versões, eu acho que era 97. Se bobear, eu mexi com a versão 1.
Ainda, eu tava aprendendo a andar, provável.
Não, 96. Eu lembro que foi no final de 96, por quê? Porque acabaram as aulas em janeiro, o pessoal fez tipo um workshopzinho de 1 hora lá na UFSCar, do tipo, tem um negócio chamado Java que está começando e não sei o que você consegue fazer programinha para rodar no browser. Cara, a gente usava Netscape naquela época, manja? Era um bagulho muito...
Olha os papos, gente, os papos de old school aí, ó.
Muito precário.
Naquela época
muito precário. Então, assim, cara, aí vim Java 1, Java 2... Meu mestrado eu fiz na versão 2 do Java, que foi lá para os anos 2000, mais ou menos. Que eu aprendi o que era orientação a objetos de verdade, o que era uma classe abstrata, que eu falava, mané, classe abstrata. Fui aprender de verdade e a parte legal, acho que o que mais me conquistou, quando eu descobri que dava para fazer interface gráfica e rodar interface gráfica no Linux. Puta, velho, isso daí foi porque assim, na época...
era com aqueles terminalzinhos desenhando ASCII, né?
Não, botãozinho, caixinha de texto e tal. Eu falei, mas isso aqui dá pra fazer sistemas legais pra caramba.
O famoso Java Swing.
O Swing. E aí, o que aconteceu? O Linux também tava despontando, né? A primeira versão do Linux que eu instalei foi em 97, mais ou menos, foi o Slackware, que eu tinha um medo do caramba, porque você tinha que configurar até a frequência vertical do seu monitor de vídeo. E falava na instalação que se você errasse essa frequência, você podia queimar seu monitor. E naquela época, cara, computador era caro pra caramba. Meu pai tinha me dado um computador, meus pais, né, tinham me dado um computador pra eu estudar. Eu falei, mas imagina se eu instalo esse bagulho aqui, esse bagulho queima, velho. E aí eu fiquei naquela, tava eu e um colega meu, o Caleb, a gente tava instalando. Pum, beleza, instalou. Falei, como que a gente mexe nesse negócio agora? O que a gente faz com isso? Porque
gente... Olha
cara,
só,
é do terminal.
para vocês terem uma noção, vocês vão ouvir sobre AI agents de alguém que fez essas coisas que ele está comentando aqui. Vocês estão prestando atenção no que ele está falando? Então, uma coisa que talvez vocês queiram saber do Isidro, talvez, e assim, aproveita, porque o Isidro é o melhor, ele fica até com vergonha. É a melhor pessoa que vocês vão ter hoje para fazer as perguntas mais informais e tudo mais. Então, cara, como que ele conseguiu se manter atualizado, mas ainda interessado em continuar aprendendo e tudo mais? Porque o cara que fez tudo isso que ele falou e vai ensinar para vocês sobre AI agents, é alguém que sabe como é que fica surfando a onda, meu brother. Só isso que eu posso dizer.
E eu vou te falar que não é absolutamente nada fácil, porque a gente fica naquela, como que eu posso dizer assim, numa pegada que, óbvio, se você ficar, eu falo, cara, eu quero estudar tudo, você fica louco. Então, o que eu tenho pensado muito nessa questão dos AI agents, né, é justamente você pensar o seguinte, tá, isso pode ser útil para eu poder não só me atualizar, mas como também criar soluções que podem ajudar processos de empresas profissionais. A gente vai tentar fazer, vamos ver se vai dar certo, a gente vai tentar fazer um pequeno exemplo, onde a gente consegue, por exemplo, conversar com sei lá, minimamente, né, com uma OpenAI e falar assim, cara, o que eu consigo extrair de coisa boa aqui nesse contexto aqui? Pô, posso fazer uma pequena API que gera para mim uma sequência de pequenos passos e a partir daí eu consigo otimizar e automatizar determinadas tarefas para mim? isso começa a ficar interessante para nós.
E eu vou falar uma coisa aqui para quem está te ouvindo. Ó. Ele não veio aqui, gente, para falar de nenhum framework, para vender nada, para falar de nenhum produto específico. O Isidro, quando ele usa tecnologias que, de fato, são bastante utilizadas no mercado. Então, o que ele falar aqui, ele não está falando por nenhum vendor. Ele não vai falar aquilo para vender ou promover aquilo ali. Então, só para dar essa nota aqui, que ele vai ensinar aqui, ó, raiz mesmo, né?
E qual é a parte boa da gente não estar vinculado a nenhum vendor? A gente tem liberdade para falar, ó, isso aqui é legal, isso aqui não é legal. Por exemplo,
isso aqui é uma M, isso aqui é uma M.
Exato. Entendeu? Então, a nossa ideia é a gente conseguir trabalhar de forma bastante agnóstica em relação à ferramental. Por quê? Porque hoje, se a ferramenta A me serve, eu vou usá-la. Se a ferramenta amanhã for outra, que nem, óbvio, a nossa preferência sempre é Java. Né? A gente vai, obviamente, usar Java porque, né, a gente tem não só um conhecimento, mas acho que uma intimidade maior com o ecossistema. E isso faz com que a gente renda muito melhor. Mas, principalmente, a ideia da gente conseguir trabalhar de forma minimamente agnóstica, assim, ó, beleza, dentro do ecossistema que eu mais me sinto à vontade, eu consigo pegar um monte de ferramentas distintas e começar a testar isso, falar assim, ó, isso me serviu agora, isso pode ser melhorado, isso eu posso sugerir uma melhoria para quem está desenvolvendo. Por exemplo, vamos pegar o que o Eric acabou de mostrar, coisas fantásticas, até comentei contigo nos bastidores, eu falei, cara, eu preciso rever essa palestra do Eric umas 2, 3 vezes, porque tem muito conteúdo útil ali que a gente pode transformar em...
Não, e eu fiz uma coisa especial para a galera da comunidade, Isidro. O Eric, ele veio para falar da perspectiva do desenvolvedor Java. Só que a última sessão, eu trouxe especialistas de banco, porque igual na palestra ele falou assim, e tem isso aqui que é o embedding, que eu não sei muito o que é, mas aqui você coloca aqui e acontece assim. Aí eu falei, cara, não se preocupa, porque a última sessão eu trouxe especialistas de um banco de dados open source para ensinar o que é isso. Então a galera vai falar o que é um embedding, o que é um vector, vai entrar no detalhe da coisa ali.
Já vou deixar então um outro gancho, porque a gente teve um meetup presencial segunda-feira, né? Lembra lá na sede da Oracle? E o Juarez, cara, ele veio falar...
Ele vai estar aqui também.
Então, e o Juarez falou do Vector DB, né? Do Oracle Database, que tem Vector DB. Que pra gente... Vector DB é uma forma sensacional de poder armazenar os tais embeddings, que depois a gente pode falar um pouco mais sobre isso. Então, do ponto de vista prático, você tem uma porrada de ferramenta legal, que você consegue fazer um monte vamos dizer assim, de protótipos, de produtos, você consegue testar antes de validar, você pode até prototipar, por exemplo, eu gosto muito de falar o seguinte, o pessoal fala assim, pô, Isidro, você é muito hardcore. Sim. 100% hardcore? Não.
Não tá
hardcode, na verdade.
Roupa de roqueiro. Então
hardcode, perdão. Mas, por exemplo, você não pode usar uma ferramenta como o Make ou como o N8N para poder fazer um protótipo? Talvez você não faça só... Para você poder fazer o seu protótipo, validar a tua ideia, botar o seu primeiro agente funcionando e ver se isso realmente resolve o seu problema, fala assim, legal. Só que ao invés depois eu ter que ficar pagando a conta da minha assinatura lá, que pode ficar caro, eu posso usar minha infraestrutura e falar assim, beleza, eu consigo otimizar isso numa linguagem como Java, que versátil, poderosa, robusta, rápida, e fazer esse meu agente rodar de forma muito mais eficiente, onde eu coloco, por exemplo, observabilidade em pontos críticos.
Tu vai mostrar, então, como é que faz isso?
A ideia é a gente tentar fazer um agentezinho
então, que seria meu de tomar teu tempo,
mini social media aqui.
Muito tempo, e eu vou falar uma coisa aqui pra galera e vou sair. Então já vai compartilhando sua tela enquanto eu falo.
Peraí,
tá?
então.
Galera, é o seguinte, durante a talk do Isidro, vocês têm que prestar muita atenção. Porque a gente preparou aqui no backstage, na hora que eu tirei aquele print, a gente estava aqui, ó, planejando o nosso plano secreto. Durante a talk do Isidro, ele vai fazer 2 perguntas. Vão ter 2 momentos em que ele vai fazer 2 perguntas para vocês. A gente vai dar um break para vocês virem aqui, abrir o seu celular aí, caso você esteja só ouvindo, para você abrir e se preparar para responder. Porque na hora da resposta, a primeira pessoa que der a resposta correta no chat, tem que ser aqui no chat, vai ganhar um prêmio. O nosso prêmio a gente vai estar hoje dando só na palestra do Isidro, hein? Do Isidro. E tem mais ao longo da semana ainda. Na palestra do Isidro, para essas 2 perguntas. O primeiro a responder cada uma delas corretamente vai ganhar aí um cupom de desconto de R$80 na loja do Sou Java. Você pode comprar camisa, squeeze, caneca. Você pode ou pegar um monte de coisa e completar, ou pode incluir até o frete, se você quiser comprar só uma coisa e não gastar nada. Então, pronto.
Aí, ó.
Aí, ó. Já bota aí no modo apresentação aí,
Presentation. Bom, e vou
Tá
tentar
com
fazer um
duas
negócio
telas,
pro meu...
Vai
From
acompanhar
the
o chat ou
scratch.
você quer que eu traga?
Oi?
Você vai acompanhar o chat ou você quer que eu traga as perguntas?
Você consegue, senão eu vou ficar meio louco aqui, que aí eu vou ficar com o código, com a colinha tá do lado de cá, o código tá do lado de cá, e a gente vai tentar fazer
comigo,
um negócio...
meu brother.
Pronto!
Toca pau nesse carrinho, Marcos!
Gente, vamos falar um pouquinho... Bom, não sei se todo mundo acompanhou a palestra do Eric, e o Eric falou muito de AI agents, né? Usando, inclusive, o que a gente vai fazer, só que, né, para muita gente, talvez o idioma possa ser um fator impeditivo. Então, eu vou tentar fazer alguma coisa parecida com ele, com o que ele fez, porém sem trazer muita sobreposição, né, entre eles, entre esses assuntos, mas assim... Como é que a gente consegue fazer um negocinho prático aqui, bacana, legal, para a gente conseguir minimamente colocar algumas coisas? Então, eu tentei fazer alguns pequenos exemplos, tá? E vamos ver se a gente consegue colocar um cara fazendo mais ou menos no mesmo ponto de vista prático essa nossa dinâmica aqui. E a minha ideia é o quê? Colocar alguns exemplos de como um agente pode facilitar a nossa vida. E isso começa a ficar legal. Vamos lá então, né? Bom, para quem não me conhece, prazer. Para mim é uma grande honra. Karina, obrigado, viu, por estar aqui com vocês. Eu estou muito feliz de poder participar de mais uma Celebration Week aqui dos 30 anos do Java, né? Para quem não me conhece.
É claro que ele não vai falar que ele é Java Champion, tá? Mas eu já vou aqui, ó, spill the tea, tá? Eu já joguei na cara logo de todo mundo, ó. Java Champion brasileiro, segura! Segura!
Você me quebra as pernas.
É só pra tirar o cara da linha de raciocínio, que ele já tava entrando nesse.
Ai, senhor, eu vou te contar, viu? Mas ok, vamos lá. Gente, então assim, a ideia é a gente conseguir trabalhar essas coisas. Para quem não me conhece, eu sou o Isidro, vamos embora, vai. E aí, turma, as IAs generativas vão mesmo mudar nossa forma de trabalhar? E eu quero falar uma coisa que eu falei no encontro do Quarkus Club, tá? IA vai acabar com alguns empregos? E aí, pode ser que sim, pode ser que não. Pode ser que a gente melhore alguns empregos, pode ser que a gente otimize algumas tarefas, pode ser que a gente potencialize outras coisas. Isso é legal. Mas assim, onde que a IA vai mudar assim, ó, de forma muito, muito, muito incisiva? Na verdade, ela já está mudando, tá? Quem ainda não percebeu, cara, se liga um pouquinho que a IA já está mudando muita coisa interessante pra gente. Vamos lá, primeiro ponto, tá? Quais serão as tarefas que a IA vai engolir com maestria? Guardem este tipo de informação. A IA vai acabar com os corno jobs. Nós somos desenvolvedores, todo mundo sabe o que é um corno job. É ou não é? Né? Aquele trabalho que você fala, putz grilo, mano. Vou ter que fazer esse tipo, vou ter que ficar limpando planilha, vou ter que ficar fazendo limpeza de base de dados, vou ter que ficar, cara, pegando e resumindo documento para poder fazer uma postagem, vou ter que ficar fazendo, sei lá, artezinha para eu poder colocar alguma coisa. A IA vai acabar com um monte de tarefas que a gente acha, primeiro, repetitivas, mas que estas tarefas ditas repetitivas, elas dependem minimamente de vamos dizer assim, de uma intelectualidade. Não é uma tarefa simplesmente repetitiva, porque senão a gente faria um script para isso. Mas é um script que minimamente pode trabalhar de forma um pouco mais intelectualizada. Beleza? Show! Então, o grande barato eu acho que a gente pode potencializar os nossos trabalhos em relação a isso, né? Por quê? Porque no fundo eles são mesmo inteligentes? Aí é uma questão até filosófica que a gente pode entrar, mas o que é legal? Se a gente pensar, por exemplo, no poder dos LLMs, LLM tem muita coisa legal que consegue processar texto muito rápido. E a partir daí a gente consegue fazer muita coisa interessante para a gente poder trabalhar e a gente conseguir, vamos supor assim, nos ajudar a criar ferramentas que acelerem nosso trabalho, ou que pelo menos não nos levem a ter que parar o que eu estou fazendo para poder, vamos supor, responder um determinado e-mail que eu já sei qual é a resposta, eu posso treinar um agente para isso, eu posso fazer um cara que tira dúvidas minimamente, eu posso fazer... Isso é muito louco, tá? Um acesso a um determinado recurso via comando de voz. E a gente consegue fazer isso de forma muito... Hoje, com essas ferramentas, exemplo, LangChain4j, a gente consegue fazer isso de forma muito rápida. E é isso que eu quero mostrar para vocês. Muito bem, né? Eu queria mostrar uma pequena demo que eu fiz aqui. O que acontece, né? Por que é um agente inteligente? Um agente nada mais é do que uma porção de software. Que essa porção de software, ela fica disponível para nós como um cara que consegue... e acho que esse é o grande mérito do agente, interpretar informação não estruturada. E a principal característica de informação não estruturada para nós, ela é o quê? Texto, linguagem natural. Por quê? Porque eu posso interagir com esse agente do jeito que eu converso, que a gente conversa aqui, nós, né, informalmente, e o agente consegue entender qual a mensagem que eu posso passar para vocês. E a partir daí eu posso instruir este agente para que este agente, eventualmente, faça uma chamada a uma API minha, uma API externa. Então esse exemplozinho aqui que eu quero mostrar, isso aqui eu filmei, né, porque sempre tem o fator demonstração, então eu vou tentar deixar o fator demonstração para eu poder perder a dignidade no código daqui a pouco e a gente tentar fazer alguma coisa pronta. Onde que está o grande barato aqui? Esse é um pequeno exemplo, tá? Eu tentei fazer isso via Alexa SDK, mas eu não consegui concluir. Então eu fiz um front em HTML puro, que ele ouve a minha voz. Ponto. Ah, Isidro, eu poderia mandar isso via WhatsApp? Poderia. Simples assim. Porém, este front, ao ouvir minha voz, ele consegue, obviamente, fazer uma transcrição mínima com a API nativa do browser, tá? E a partir daí, esta transcrição torna-se um prompt. Uma vez que esse prompt é enviado ao meu agente, eu consigo, com este prompt, fazer acesso à API de um sistema, um ERP, e, por exemplo, responder algumas coisas. Então vamos lá, eu vou tentar narrar o que vai acontecer aqui de forma extremamente simples, beleza? Então eu tenho meu frontzinho, eu chamei esse cara de Jarvis, por quê? Porque eu sempre quis ter meu Jarvis. Hoje vocês podem ter o seu Jarvis muito mais fácil do que vocês imaginam, então cada um de nós aqui pode ser o próprio Tony Stark da sua vida, tá? E a partir daí, ó, o que eu fiz, né? Eu clico nesse botãozinho central e ele fica habilitado para que a gente possa falar. Então uma vez, ó, cliquei no centro, clique, aqui eu posso falar. Uma vez que eu falo, ele fica mudando, né, o visual desse carinha aqui. O que eu fiz aqui? Eu fiz uma pergunta. Basicamente, Jarvis, me dê o faturamento do mês. Beleza? Beleza. Ok. E aí o Jarvis fala, eu entendi isso de você, tá correto? Tá aqui, ó. Jarvis, gerar o relatório de faturamento do mês. Beleza. E a partir daí, ó, o que o Jarvis me deu? O faturamento do mês de, sei lá, junho de 2020, era 2025 que eu mudei aqui, errei. É de 150.318,72. E o que aconteceu nessa história toda? Basicamente, um agente rodou ou entrou em execução. Como? Vamos lá. O que aconteceu nos bastidores? E é isso que eu gostaria de mostrar para vocês. O que aconteceu aqui nos bastidores? Deixa eu parar de apresentar de novo. Tá aqui, ó. Vem para cá, aqui. Fizemos um pequeno assistente de voz, o Jarvis. A ideia é, usando uma API Speech to Text, né, disponível em qualquer navegador, a gente conseguiu narrar uma pergunta, enviar essa pergunta para um back-end nosso, que esse back-end, de novo, o agente, turma, não necessariamente é uma porção de software isolada. Cara, ele pode estar numa API. Ele pode estar acoplado à minha API, ao meu back-end, a qualquer coisa que eu quiser. Beleza. A ideia é que a gente consiga, então, transformar essa pergunta em um prompt usando uma técnica chamada RAG, que esta técnica de RAG, ela tem um que a gente chama de conhecimento acessório, não apenas o conhecimento da OpenAI, e a partir daí, eu, via engenharia de prompts, isso tem que ser muito importante, eu consigo, vamos supor, por exemplo, fazer uma determinada chamada ao meu ERP. Como assim, Isidro? Como assim? Vamos lá, vamos entender a arquitetura desse cara aqui. Eu tenho meu app feito em JavaScript purão, beleza. E eu tenho o ERP aqui disponível, que ele tem uma API aberta, eu precisaria ter isso aqui minimamente. Então, como que eu faço para esse app de voz conversar com esse ERP, que teoricamente são duas aplicações totalmente distintas, são duas aplicações que não se conversam, são duas aplicações que não tem nenhum, são desenvolvidas em linguagens distintas. A única coisa que este sistema tem, ele é um sistema onde eu consigo ter uma API aberta, eu consigo invocar funcionalidades.
Mas tem
dúvida. E aí, já tem a dúvida. Posso já responder a dúvida do Rafa que eu acabei de ver aqui?
Então vai seguindo aí. Eu esqueci que você é live streamer. Aí qualquer coisa, se passar o tempo e você não vê, aí eu trago.
Beleza. Então eu respondo já, Rafa. Então, ó. Então o que eu fiz aqui? Eu criei o tal do Jarvis Agent. O que é o Jarvis Agent? Basicamente é o quê? É um cara que se comunica com a OpenAI, mas poderia se comunicar com qualquer... Isso é muito importante, tá? Hoje, a gente acha que criar modelos, né, criar agentes é você se conectar com a OpenAI. Não! Você pode se conectar com a Anthropic, com a Gemini, com a Llama da Meta, você pode se conectar com modelos locais, com o Llama, por exemplo. Quando você tem, por exemplo, o próprio JLlama, né, que é legal pra caramba, que é um motor de inferência feito 100% em Java, para rodar usando as instruções SIMD da sua CPU. Então isso é muito louco, tá? Mas o que esse cara faz? Bom, a OpenAI, claro que ela não consegue acessar a nossa API, porque ela não tem os endpoints. Eu posso criar um documento, aqui ó, onde eu descrevo o que cada API do meu ERP tem, por exemplo, como chamada, certo? Então tá bom, né? Vamos supor, o endpoint X me dá relatório de produtos, o endpoint Y me dá relatório de, sei lá, de estoque, o endpoint Z me dá relatório de faturamento. E eu documento tudo isso num arquivo texto, tá? Respondendo a pergunta do Rafa. Rafa, a API consegue reconhecer em qualquer idioma. Obviamente, você tem que setar qual que é o idioma que ela está disponível para responder, tá? Depois eu acho que eu tenho esse repo no GitHub, depois eu vou procurar, eu posto aqui para vocês ou posto no comentário do vídeo, tá? Mas basicamente os principais idiomas, né? Português, inglês, alemão, japonês, espanhol. Acho que esses 4 aí já abrangem quase 90% do globo terrestre. Mas português, sim, reconhece muito bem, tá? Mas assim, não é robusto como, por exemplo, um modelo Whisper da OpenAI, como um modelo da Google. É uma API bastante modesta porque ela roda dentro do browser, né? Então é o motorzinho do V8 lá do JavaScript dentro do seu browser que te dá isso, beleza? Ele está embutido no browser. Show? Beleza. Então vamos lá. O que vai acontecer? Esse documento aqui que fala quais são os endpoints e o que esses endpoints me retornam, ele entra como um recurso de Retrieval Augmented Generation, que é o quê? Basicamente, eu colocar esse documento como uma base acessória para que a OpenAI, usando o processamento de texto que ela tem, que é muito bom, ela consiga fazer consulta nesse documento e me retornar, por exemplo, o endpoint correto de acordo com a minha solicitação. A partir daí, então, o meu app, no meu speech to text, me manda a string da transcrição do áudio para o meu agente. Este agente pega essa transcrição, transforma isso num prompt estruturadinho. A partir daí, a OpenAI fala assim, legal. Né? E neste prompt ainda tem que ser muito claro para falar assim, OpenAI, eu quero que você me retorne exclusivamente apenas a URL correspondente ao endpoint. Eu não quero que você me retorne texto nenhum, me retorna só isso, beleza? Beleza. O que vai acontecer? Esse agente faz uma chamada REST à minha API. Por quê? Porque agora ele sabe via texto, via áudio transcrito, qual a necessidade do usuário que falou alguma coisa aqui, ele faz a chamada e ele, uma vez recebendo este resultado, ele manda uma resposta para o meu usuário, um agente. Por que isso? Ah, Isidro, mas isso é uma baita de uma firula. Não, cara. Posso falar? Se ao invés de eu ter esse app que fica aí, sei lá, é o Jarvis, né? Eu tivesse o WhatsApp da empresa. Atenção, pessoal, eu preciso o bot, company bot, aproveitando que a Karina adora falar um inglês com sotaque, company bot, me dá o relatório assim, 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 assado.
Só sobra pra mim. Só sobra pra mim.
Sobra pra você.
Mas falou bonito, company. Não
é
falou company.
É tipo de Durham, lá na Carolina do Norte, sotaque da Carolina do Norte. Então, qual que é a ideia? A ideia é que a gente possa, então, fazer isso para otimizar, porque imagina se alguém está numa reunião e precisa apresentar um determinado número para um gestor, e aí fala assim, putz, espera aí um minutinho, deixa eu pegar meu notebook que descarregou, e aí eu vou precisar ligar na tomada, botar, acessar o sistema. Cara, a reunião já acabou, os caras já estão, tudo puto da vida e não conseguem mais trabalhar. Corno job. Por quê? Porque eu não estava com esses números na mão, mas eu posso pedir via WhatsApp. Eu posso pedir via aplicação que está instalada aqui, ó. Fale com a empresa, caso eu não queira WhatsApp como meio de comunicação, no Discord. Essa é a ideia. Faz sentido, gente? Então, agentes com IA vão ajudar neste sentido, que eu acho que é uma necessidade imediata, sabe assim, uma necessidade imediata, uma necessidade não só imediata, como urgente, e uma necessidade que quando as pessoas entenderem o potencial disso, cara, isso vai facilitar a vida de muita gente. Faz sentido? Vou dar um segundo exemplo aqui. Então me segurem aí pra gente não correr o risco. Esse cara é um cara que eu fiz agora, e esse aqui eu posso mostrar o código, tá? Que é o EasyBot. Eu tava inclusive falando com o pessoal da EasyFlix ontem, né? Que eu falei, gente, eu consegui concluir, eu vou poder apresentar lá no Celebration Week. Onde que tá o grande barato? Eu fiz o que eu, por exemplo, vou dar uma dúvida recorrente que acontece lá no canal. Isidro, pô, fiz a trilha tal, não sei o quê, qual que é a melhor sugestão que você me dá? Cara, eu respondo com o maior prazer. Mas por uma questão de teste, eu falei, cara, e se a gente fizesse um bot que responde isso para nós? Por exemplo, o EasyBot, ele tem o que eu chamei de knowledge base aqui, ó, nos meus documentos, que eu coloquei aqui uma descrição sobre cada um dos projetinhos que a gente tem na EasyFlix para quem quiser, né, trabalhar. Então, ó, peguei cada um dos projetos, fiz aqui uma descriçãozinha deles, etc, etc. O que vai acontecer com esse cara? Esse cara vai ser a minha base de conhecimento acessória para via Retrieval Augmented Generation fazer uma vamos dizer assim, um acesso mais especializado a essa informação. Um acesso mais especializado. Guardem isso. Tá bom? Tá bom. A partir daí, o que eu tenho? Eu criei aqui, né, um serviço RAG, onde eu tenho, por exemplo, ó, eu escolho um modelo, lá, né, eu crio aqui, né, antes de qualquer coisa, né, um OpenAI Chat Model, uso a API da OpenAI, tá aqui bonitinho, uso o modelo, nesse caso o GPT-4 Mini, e a partir daí eu crio um assistente, tá aqui, que é esse Chat Model aqui, e eu falo, ó, eu tenho uma memória aqui, ele pode usar um certo número de memória, e ele usa, ó, esse Content Retriever, que é basicamente o quê? O conteúdo que eu subi do meu documento. O que esse Content Retriever faz? Basicamente, tá? Usa um conjunto de segmentos, faz a ingestão, ou seja, eu pego aquele documento, transformo todos os tokens em números, que a gente depois pode fazer um estudo um pouco mais aprofundado disso, que é basicamente transformar aqueles tokens em números para poder representar cada uma das palavras, e a partir daí eu consigo retornar aqui, né, essa Content Retriever aqui para falar assim, ó, converse com o meu usuário, não apenas usando os recursos da OpenAI, como também usando estes recursos aqui. Estes caras, tá? Ó, a ideia é que a gente pode trabalhar de modo muito simples. Por quê? Porque a partir daí, ó, eu criei um bot para o Discord, que também não é uma coisa assim muito rápida de se criar. A API de criação de bots no Discord tem uma documentação sensacional. É rápido, você consegue fazer isso muito fácil mesmo. E a partir daí, eu tenho aqui basicamente, ó, um receiver event. Falei, pô, show de bola. A partir daí, com esse receiver event, eu falo assim, ó, recebi a mensagem e agora eu consigo retornar isso. Por exemplo, eu instalei o bot aqui num outro serverzinho de teste, eu não instalei ainda na EasyFlix. Por quê? Porque eu terminei ontem, eu preciso deixar isso aqui em produção. Tá aqui, ó. Eu tenho um server aqui, tá? Eu criei um canal EasyBot Teste. O EasyBot está aqui já instalado no meu canal e eu posso vir aqui e falar o seguinte, ó. @EasyBot, tá aqui. Por favor, quais são os projetos disponíveis? Acho que é isso. O que vai acontecer? Olha só. Se ele está rodando e ele está rodando, né? Tá rodando, beleza. A ideia é que a gente possa, nessa brincadeira, saber qual é a pergunta. Ele vai fazer a conversa com a OpenAI usando o meu documento e vai tentar me responder. Vamos ver. Manda aí. Quais são os projetos disponíveis? Ó, recebido de professor Isidro para EasyBot. Por favor, quais são os projetos disponíveis? Nessa brincadeira, se der tudo certo, ó lá, ó. Aqui estão os projetos disponíveis e olha que coisa bonitinho, ó. Aqui estão os projetos disponíveis, ó. Mas meu prompt está muito tranquilo. Ó, tem, ó, o software para servir, complexidade. No fundo, o que ele fez? Ele basicamente consultou e trouxe do jeito que está. Eu poderia melhorar esses documentos e falar, ó, qual é o melhor, para qual perfil ele se encaixa, etc, etc. Tudo bem? Tudo vai depender do quê? Do meu prompt e do meu conteúdo RAG. Faz sentido, gente? Pô, mas Isidro, gostei. O EasyBot pode fazer mais alguma coisa além disso? Por exemplo, ó, EasyBot. Não vou falar meu consagrado, mas assim, ó. Qual o problema que tem no meu código, né? Já que ele não compila. Então, eu vou colocar meu código aqui. Por exemplo, vou escrever aqui, ó. Vou pegar um notepad mesmo. Aqui, ó. Então, ó, public, né? Public class test. E aí, ó. Public static void main string arg está aqui. Se, ó, vou pôr, já sei, ó. System, vou esquecer um ponto e vírgula. O erro clássico, tá? System out println hello world, tá aqui. E aí vou esquecer o ponto e vírgula. 1, 2, 3, aqui. 1, 2, 3. Fiz esse código, não compila, pipipipopó. Tá bom, o que eu vou fazer? Vou colocar aqui no meu... Tá aqui. Não compila. Será que o EasyBot consegue me responder e tirar essa dúvida básica? Vamos ver? Olha lá, se eu olhar o código aqui, ó. De novo, ó. Professor Isidro, ó. Meu código não compila. Já me deu a resposta, já, ó. O problema no seu código é que você esqueceu de adicionar um ponto e vírgula ao final da linha que você chama um método system.println. O Java piriri parará, papapum. Sempre que você encontrar... Ou seja, dá pra gente falar? Dá pra gente fazer? Claro que dá. Dá pra gente fazer muito fácil. Muito simples. Quer dizer, guardadas as devidas proporções. Imagina o seguinte, tá? Se eu tivesse, por exemplo, a necessidade de eu colocar, por exemplo, imagina se eu tenho, sei lá, 200, 300, 1000 alunos aqui na EasyFlix me perguntando a todo momento. Esse cara não poderia ser um assistente do Isidro? Me ajudando a responder dúvidas, ajudando aos alunos a não esperarem tanto pela resposta? Faz sentido isso, gente? Porque se está tudo na minha mão, cara, uma hora eu vou me sobrecarregar. Esse cara não pode nos ajudar? É aí que as coisas começam a funcionar de forma um pouco... Lembra? Não vou falar que responder aluno é um corno, mas sim, muitas vezes eu, sei lá, estou numa reunião, estou dando aula, estou ocupado e o meu aluno está lá esperando, coitado. Eu não quero deixá-lo esperando. Eu poderia, por exemplo, tirar um monte de pequenas atividades de atenção para os meus alunos para justamente, obviamente, dar mais atenção para eles e não deixar a galera no vácuo. E óbvio, né, a minha intervenção continua sendo necessária, com toda certeza. Mas algumas dúvidas pontuais, eles já podem ter eu gosto do termo que assim, por que o GPT é legal? Porque na minha cabeça, o GPT ele é um Google anabolizado. Eu posso ter aqui uma FAQ, Frequently Asked Questions, é isso aí, um pouco mais anabolizada, que o meu aluno pode, com isso, trabalhar de forma mais interativa, usando esses recursos, de novo, para facilitar o trabalho dele, para ele não ficar tanto tempo esperando, para não sobrecarregar as tarefas que a gente tem, para a gente conseguir fazer de forma um pouco mais especializada. Consigo fazer, Isidro, cara, me faz um code, EasyBot, me faz um code review aqui. Vamos pedir um code review? Vamos ver se ele faz um code review. Vou pegar uma classe qualquer aqui, ó. Vou pegar, sei lá, da Isidro API. Tá aqui, ó. Tá aqui, ó. Vou pegar esse cara aqui. Um service aqui, deixa eu ver. Um container service implementation. Vou pegar esse cara aqui. Vou copiar. As is, tá? Do jeito que tá. Pronto. E aí, olha só que legal. Vamos ver se a gente consegue fazer assim, ó. @EasyBot. Tá aqui. Quero que você faça um code review neste código aqui e me dê sugestões de melhorias, baseadas em clean code e legibilidade. Vamos lá. E eu vou colar o código aqui. Sua mensagem é muito longa. Voltar em chato. 2.000 caracteres. Tá bom. Vou tirar algumas coisas aqui. Vai. Puta, 612. Tá bom. Vou tirar uns 2 métodos aqui só para... Porque eu não implementei envio de arquivo, né? Então, pode ser que dê algum forrobodó aqui. 335. Tá aqui. 170. Mais um. Caramba. Cara chato, velho. Ah, podia ter tirado um monte de import aqui, né? Eita. Já sei. Vamos ver se eu consigo destirar esses caras aqui. Pronto, ó. Tchau. Vou tirar esse monte de import aqui que pra mim vai agregar pouco. Pronto. Tá aqui. Aí, ó. Resolvido. Vamos ver se ele consegue fazer um code review. Vamos lá. Vamos ver. Ah, tá bom. Senão, perdi. Tudo bem, não tem problema. Depois eu posso fazer melhor esse cara aqui para para ele não acessar. Tem questões de código aqui para não rolar essas tretas aqui, ó. Quando você não compartilha o servidor com o destinatário, ok. Tudo bem, depois eu faço essa... Ele deve ter dado alguma exceção aqui. Não deu. Tudo bem. Já sei, vou pegar um código menor. Será que um código menor ele aceita? Vamos tentar um código menor aqui, ó. Static Service. Esse aqui, vamos ver. Vamos ver se eu pego, vamos ver. EasyBot, me deu aí. @EasyBot, ó. @EasyBot. Qual? Só para ver. Mais atual do Java. Só para ver se ele está funcionando, se ele continua funcionando. Então, continua, fechou. Beleza. Ok, show de bola. Então, tá. @EasyBot. Você consegue fazer um code review deste código Java, melhorando a legibilidade dele? Vamos ver se ele deixa. Vamos ver. Eita, mandou. Vamos ver. Pegou, hein? Pegou. Peraí, volta aqui. Cadê o server do Discord? Vamos ver se ele pega. Se pegar, gente, aí vai ficar legal pra caramba. Vamos combinar. Deu ruim. Não tem problema. Ok. Event Listener, ok. Ele pegou aqui, ó, não pode ser mais do que 2.000 caracteres. Preciso configurar esse cara aqui para ele aceitar mais de 2.000 caracteres. Não tem problema. Mas, ó, olha que coisa louca. Ele já me deu aqui, ó. Melhorias aplicadas, ó. Depois, obviamente, ele acabou truncando a palavra. Faz sentido, gente? Tirando essa configuração que eu posso fazer depois para poder colocar mais de 2.000 mensagens, eu consigo ter um assistente e fornecer um assistente para os meus alunos poderem usar. Por quê? Porque aí, de novo, eu tenho uma conta que pode me permitir usar uma API. Porém, nesta conta, eu consigo fazer com que os meus alunos possam aproveitar e usar esses recursos de forma, vamos dizer assim, a não precisar de uma segunda interface. Lá no próprio canal do Discord, eles perguntam, no próprio uso da ferramenta, eles conseguem trabalhar com isso? Gente, é basicamente esse tipo de funcionalidade. Para quê? Para facilitar a vida das pessoas. A gente fala core job porque, assim, óbvio, tem a questão do trabalho repetitivo. Mas quanto de produtividade a gente não poderia ganhar com isso? Quanto de vantagem competitiva a gente não poderia ganhar com isso? Quanto de facilidade a gente poderia ganhar com isso? Lembra que a gente fez a API? Deixa eu ver se ela está aqui em outro... Posso fazer uma mudança de workspace aqui? Karina, quanto tempo eu ainda tenho?
A Alina começaria às meio-dia e meia, mas vai indo aí. Qualquer coisa, ela espera uns minutinhos.
Tá, só para ver se eu consigo testar um negócio. Acho que esse workspace aqui... Pô, que pena. Preciso configurar depois o EasyBot para me aceitar mensagens maiores. Mas ok, vamos lá. Cai fora. Não quero salvar. Sai daqui, senão vou... Vamos ver se dá tempo da gente criar um agentezinho mais simples aqui. Opa, tá pro lado de cá. Deixa eu ver se tá aqui. Não é esse cara aqui não. Putz, espera aí, que é outro workspace. Eu tô com tanto workspace. Rex. Deve ser. Calma aí, segura aí. Aí a gente pode tentar fazer um segundo agente aqui para poder fazer uma coisa bacana. Tá, segura aí, segura aí. Calma aí, Karina. Calma aí, Karina.
Tá tudo bem, tá tudo legal.
Pronto. Pera aí. Tá indo, tá indo.
Vai que vai.
Deixa eu ver se eu tenho aqui chat.
Galera, enquanto ele tá procurando, ó, a gente vai ter sorteios aqui de... Sorteio nada. Quando o Isidro trouxer aí as perguntas... Isidro, tem uma das perguntas ali que tá muito fácil.
Isso.
Tem alguma delas você vai ter que complicar mais, porque tá muito fácil. A galera que é pró, ontem tá com de certificação, fi. A gente coloca uma pergunta aí, já sei. O que a gente pode... Não, vou pensar. Se você pensar primeiro, pode ser também. Mas teremos duas perguntas. E a primeira pessoa que responder certo no chat vai ganhar um cupom de desconto na loja do Soljava, hein, de R$80. Então, vamos lá.
Aí sim, hein? Cara, eu preciso achar o bendito do... Vai falando aí, vai falando.
Então vai procurando. Então, galera, ó, lá na loja do Soljava vocês vão poder comprar camiseta, vai poder comprar squeeze, vai poder comprar caneca, tem um monte de coisa com o logo do Soljava, tem até o Duque com a camisa do Brasil, assim, umas coisas bem legais. Você achou, Isidro?
Boa. Eu acho que é esse workspace aqui. Porque eu quero só juntar duas coisas que eu já fiz. Ah, não é esse... Tá, depois eu vejo aqui, porque assim, eu tenho, acho que tá no outro, no momento eu vou fazer só uma arquitetura aqui rápida, vai, pronto. Senão a gente vai ficar muito aqui. Imaginem o seguinte, turma, existe um portal, não sei se vocês, todo mundo já viu esse cara aqui, chamado News API. Esse News API, ele me dá um monte de notícias. Eu posso selecionar notícias do meu interesse aqui, ó, tá aqui minha API, pronto, ó. E olha só que interessante, tá? Se a gente parar para pensar nesse News API aqui, ó, Get Started, ó, eu poderia usar esses caras para, por exemplo, recuperar notícias do meu interesse, fazer um prompt que seleciona a melhor notícia, a partir daí eu chamo a OpenAI, resumo essa notícia com o meu jeito de falar, Depois disso, eu posso traduzir essa notícia, esse resumo numa imagem. Tenho já a imagem da notícia que eu quero falar. Eu tenho o texto da notícia. Faço uma integração com uma rede social, eu consigo basicamente ter o meu social media que diariamente seleciona as melhores notícias de acordo com o meu perfil, gera um resumo, gera uma imagem e publica. Fim. Ele ainda poderia fazer o seguinte, colocar isso num banquinho de dados, eu vou lá e num endpoint e falo assim, approve. Eu posso ter um preview e eu dou um approve nele e o meu social media está pronto. Usando o quê? Recursos de IA. Dúvida do Max. Tem uma dúvida se o modelo faz muita diferença quando se usa RAG, já que esses dados estão ingeridos em forma de texto ou PDF. Não, Max. Na verdade, sim. O modelo vai depender... Assim, o que a gente vai usar do modelo, né? A priori, a capacidade de processamento de texto. O que vai fazer diferença na questão do RAG? Primeiro, o seu prompt, o seu contexto de prompt, que você pode colocar, nesse caso, como uma system message e tal. Por exemplo, aqui nesse exemplo, né, não deu para a gente fazer o código from the scratch, mas nesse exemplozinho do EasyBot, eu poderia fazer um system prompt muito sofisticado, falando, ó, você é um professor, você tem uma plataforma, você tem alunos que estão como iniciantes, como avançados, como sênior, pleno e etc. E a partir daí, você consegue respondê-los de forma didática, objetiva e sem precisar de documentos para poder gerar para os nossos alunos a melhor experiência de aprendizado para ele. Pronto. Então, o seu documento pode estar estruturado de uma maneira bastante clara, simples e vamos dizer assim, objetiva, e o seu prompt indicar como que o seu agente vai funcionar. Nesse caso aqui, ó, se a gente olhar o EasyBot aqui, ó, eu tenho esse AI Assistant, que eu coloquei aqui, ó. Eu posso colocar essa System Message aqui, ó. E nessa System Message eu posso colocar aqui, ó. Você é um professor universitário que se destaca pela sua didática, blá, 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 blá. E aí eu moldo o meu agente, por exemplo, a partir daqui. Faz sentido, gente? Tudo bem? Essa é a ideia. Então, assim, óbvio que essa palestra foi uma palestra mais demonstrativa, né? Se eu tivesse os outros endpoints aqui, a gente poderia até tentar fazer uma demo, mas como a gente tem um pouco menos de tempo disponível, eu vou fazer o seguinte, Karina, eu posso fazer um convite para a galera, para a gente poder fazer depois um workshop sobre criação de agentes em Java, usando LangChain4j, Reg e automação? Já fica convite para a galera. Peraí que você está no mudo.
Vai ser aonde?
Online. Fazemos online.
Uma talk?
Vamos fazer uma talk só sobre como construir esses agentes.
Mas pra ontem. Bora.
Beleza? Mas aí a gente agita, eu faço essa talk pra galera de forma...
No Java ou lá no canal do Isidrão?
Pode ser no meu canal mesmo, não tem problema nenhum.
Fechou, então já deixa o link aqui no chat privado antes de sair da call, que eu mando pra eles o link que eles já mandam subscribe lá.
Boa. Depois eu monto uma pagininha pra gente poder fazer tudo isso. E aí, as perguntas. Karina, vou falar das perguntas pra galera, porque assim, eu sei que meu tempo tá acabando, não quero deixar
a
isso...
gente tem ainda 8 minutos. Tem algum slide de pelo menos de obrigada,
Não, tem um de obrigado, né? O de obrigado eu vou colocar aqui. E para quem quiser trocar uma ideia, gente, e não tiver o meu contato, por gentileza, sintam-se à vontade. A ideia é que a gente possa trocar uma ideia com um pouco mais de calma e fazer coisas com muito mais profundidade. Esse aqui é meu Instagram e também o meu YouTube, tá? Quem quiser pode me adicionar lá, pode se inscrever no canal. Toda semana a gente tá fazendo lives aí. Ainda não, né? A gente tá com um projeto que é o projeto Isidro, que é o Hiroko do professor Isidro, que a gente tá fazendo API para controlar Docker, etc, etc. Então, quem quiser, a gente tá com essa série sendo feita toda semana ao vivo. Excepcionalmente essa semana, por conta do feriado, acho que eu vou fazer a live hoje, tá? Então vou avisar até a galera pra gente poder fazer a live hoje, ao invés de sexta-feira, que sexta-feira eu sei que a galera quer descansar. Karina!
Me ajuda a fazer nessa live aí no horário que você não vai conflitar com o nosso evento aqui, né?
Não, vai ser de noite.
Pronto.
Não,
Quero
a
mais
partir das
nada.
8h30 da noite, 8, ó, já vou fico o convite, 8h30 da noite hoje, live de conclusão do dashboard do Isidro pra gente poder fazer basicamente, dado um GitHub, você tem a sua API Java no ar, funcionando
Quero mais
bonitinho.
o quê? Quero mais o
Entendeu?
quê?
Depois que o Iroko ficou pago, a gente tá órfão de ferramenta legal para poder colocar as nossas APIs no ar. Então, o que eu fiz? Comprei uma maquininha aqui, coloquei ela no ar, instalei Linux, instalei o serviço que eu queria, Docker, e hoje você coloca o link do GitHub e você consegue ter sua API no ar funcionando via túnel do Cloudflare. Sensacional.
Mas aí, cara, tá faltando você colocar o link aqui do canal do Isidro aqui no chat privado para mim. E aí, Isidro, eu tenho dúvida lá. Dá dúvida, eu tenho a dúvida da dúvida. Qual é a pergunta que você quer trazer pra galera? Se você quiser que eu copie e cole aqui, essa aqui do OpenAI aqui.
Boa.
Posso colocar ela?
Vai, coloca. E aí uma outra pergunta, uma sugestão que se a galera tem uma ideia, acho que a ideia acho que é válida.
Tá, escreve pra mim que eu vou copiar e colar, que é pra não ter nem caô. Então
vai lá, bora.
Quem tá assistindo a live, por favor, se liga aí no vídeo agora, vou colocar a pergunta.
Vai ganhar. É pra ganhar.
Pra não falar que teve delay, não sei o quê, dar um refresh na página. Eu tô dando um tempo extra pra dar tempo de chegar em todo mundo. A mensagem que tem um delayzinho, né, no stream. Então, ó, a primeira, qual que é o esquema? A primeira pessoa que responder corretamente essa pergunta, gente, o Isidro é muito bonzinho, ele não é professor de rasco, não, a pergunta é mais fácil. A primeira pergunta é fácil, gente.
Já sei, vou falar o seguinte. Não, já sei.
Tá bom, então. Então, gente, ele mudou a pergunta.
Peraí, vou fazer outra, peraí.
Ele mudou a pergunta fácil, hein? Eu vou colocar, vai aparecer aqui embaixo, rolando, tá? E aí, a primeira
pessoa
que responder correta... bem melhor.
Então
a primeira pessoa que responder corretamente no chat, o Isidro que vai julgar, não sou eu. Então, ó, blame it on him. Não tem nada a ver com isso aí, viu? O Isidro vai julgar a primeira resposta certa.
Boa.
Alina is on the backstage. Hi, girl. So we are about to wrap up. We are just doing some giveaways, and we will soon get started. All right. So you can still grab your coffee and be my guest. So, e aí, galera? Então, voltando ao português, dá um tilt na cabeça. A primeira pessoa que responder corretamente leva aí o cupomzinho, hein? 3, 2, 1. Tá aqui, passando aqui, ó. A primeira que o Isidro falar, tá certa essa aqui, vai ser a que vai levar. E aí, ó, vai levar um cupom de desconto, vai poder comprar um montão de coisas na loja do Soul Java. Vou até abrir aqui para vocês verem que legal que é a lojinha, enquanto a galera tá respondendo, Isidro.
Você colocou na... Ah,
tá passando aqui embaixo, ó.
Ah, boa.
Cara, meu cachorro tá comendo... é só um pote de tic-tac. Ó, aqui, galera, eu vou compartilhar a tela aqui só para vocês virem, hein? Respondam aí. Se não responder, não leva. Valendo o cupom, hein? De desconto na loja do Soul Java. Compartilhar tela. Aqui, olha que legal. Para quem tá vendo aí, enquanto isso, ó, canequinha. Tem camisa do Javali, do Soul Java. Tem aí, os mascotinhos. Tem aqui o Duque com a camisa do Brasil. Ó, surfando. Tem um monte de presente legal, galera. R$80, ó, dá para comprar, incluindo o frete, hein? E aí? E aí, Isidro, essa resposta do Samuel tá válida?
Boa, do Samuca vale. Voltar, ó, solução mais específica voltada, que é justamente você ter sua base de conhecimento acessória. Perfeito.
Então, Samucão levou a primeira.
Samuca, aí sim, hein?
Samucão levou a primeira. Ó, Samuel, me manda uma mensagem no LinkedIn, por favor, vou te mandar aqui. Você me mandou uma mensagem lá, que aí eu vou com o seu e-mail que eu vou te mandar, beleza? E aí, galera, parabéns! Não, a Carolina tava ditando uma resposta bonitona lá, ó.
Cara,
tá vendo?
Já que nós temos dois cupons,
Isidro,
posso?
Faz uma pergunta de responder A, B, C, D, porque não dá tempo para quem digita devagar. Ou então ABC.
Ai, você me fode, cara. Você me pede essas coisas de última hora.
Se vira.
Cacete de agulha, viu?
Se vira enquanto eu faço aqui, ó. Galera,
cacete.
Dá um follow lá no profile da Alerix, que os cupons que a gente está sorteando aqui são sponsored by Alerix. Então, a Alerix é um dos supporters do nosso evento aqui hoje, junto com a Eclipse Foundation e junto com a... que está próximo aí de fazer o release do Jakarta TI. Então, se você está gostando dos brindes do evento, já dá um follow lá na Alerix para poder mostrar aí o seu suporte também para quem está suportando a gente. Ó, manda lá para mim no LinkedIn, aqui meu perfil. Manda seu e-mail lá, Samuca, que eu vou te mandar o seu gift card.
Pronto. Vou
Alina,
mandar, hein?
Alina, Professor Isidro, I'm gonna bring you to stage, girl, just so you can say hi to everybody. Hello!
Hey, oh my God, I'm
Hello,
so happy
Alina.
to see you again. Hey.
Oh, you tell me. So Isidro is also a Java champion. He's like one of the best in Brazil. He's been changing lives, really, with Java. And people like just building careers with Java. He's getting all shy. And Isidro, Alina is one of the greatest speakers.
Yes, from GraalVM.
Yes.
Yes, I follow you, Alina.
Oh,
I really
nice.
appreciate your work.
Thank you.
Later on backstage, I'm going to get your contact because I have lots of questions about GraalVM and so many things that we can do together. But okay, I'm not going to bother your presentation.
You're
So
perfectly on time.
but
Thank you
Alina
so
will
much.
not start yet. Alina, we are doing the final question now for the giveaway.
Okay. Yes.
And this is the last one. Whoever answers first will get a gift card for Soul Java store, online store. So I just put it on the comments because it's too long. Isidro, it's too long. I'm going to copy the answers here. Don't worry.
Okay.
I'm going to copy it
Answers.
here. So these are the answer, the question, then the answer here. Okay, just a second. Oh, galera, sorry, Alina, I'll bring it to backstage and switch to Portuguese real quick. Oh, galera, seguinte, essas são as respostas. A pergunta aqui... Já foi?
A Ana ganhou. Pronto, ó. Desfizemos também a injustiça que tínhamos feito com a Ana, tá? Obrigado, Ana. Resolvemos. Ó, o Samuca tinha ganho, a Ana ganhou agora a B.
A Ana foi. Nossa, ela tava ligada mesmo na live, porque eu tava botando de tudo que era gente aqui, saindo na loucura. Ela merece demais.
Oh. Show, Ana. Nossa, meu, o Igor ficou SD? Como assim, Igor?
Galera, foi muito legal ter todos vocês aqui com a gente. Isidro, você é show.
Obrigado, gente. Pena que foi rápido. Vamos depois fazer uma live muito mais longa sobre isso.
Se qualquer coisa tiver à toa aí essa semana ainda, a gente vê alguma coisa, viu, Isidro? Obrigadão aí pela presença, pela
Obrigado, gente. Valeu mesmo.
E pelos sorrisos. Ficamos por aqui. Obrigado, Isidro. Tchau, tchau. Ana, Samuca, me mandem mensagem lá no LinkedIn, por favor, que eu vou enviar para vocês todos os detalhes do cupom, ok? Me manda uma mensagem com seu e-mail. Se não der para mandar mensagem, me adiciona lá que eu vou aceitar e aí eu mando. Now, let's go back to English. And bring over to the stage the best of the best. Hi, girl. How you doing?
Hi, so happy to see you again, at least virtually. It's been, what, like 2 years? Oh, my God.
2? It's more. Devox Belgium, it's been more than 2, no? Just 2?
That's your cue to come again to Devox Belgium this year.
I got to send my talk on the call for papers. I got to send it. Especially because this event is just triggering all the event like willingness in me again, you know, all the fun that we have in this network when we are networking with the community. So I'm very happy. I'm very happy to have you here, and thanks for accepting our invite. It's an honor
to be here. Thank you so much for having me.
By the way, you're gonna tell us about how to use GraalVM in production. So you're not going to bring anything AI and none of those hype stuff. So this is what I want to ask you, because I've been asking this to other speakers as well, but I know you will be able to be more persuasive than them. Why should people stay around to hear your talk?
Okay, you should stay around because I will show you everything that you need to know to be using GraalVM in production, all the tooling, all the latest features, all the features that you definitely need in production. And talking about LLMs and AI, I will show you something that maybe you haven't seen before. A colleague of mine implemented an LLM engine himself in Java, pure Java, no Python, no C, no anything. So stay tuned until the end of the talk where I will show you this LLM inference engine.
Wow, okay, so there is AI and there's JVM there as well. Okay.
And so, native. So either JVM or native, whatever you want, you can do with it. Yes.
I love native. It's just so fast. It's crazy. By the way, will you cover also, this is a question from myself, like, will you also cover why GraalVM? Because many people are just used to the traditional OpenJDK or whatever they find out there that is easier already, like on automatic mode, brew, install something. So you're also going to tell them why GraalVM?
I will. I usually like, going deeper into the details and all the technical deep dive, but I realized talking to people at conferences that some of them are rather new to GraalVM. So in the beginning, super shortly, like 1-2 minutes, I will spend telling people why GraalVM and which parts of GraalVM.
Exactly. Thank you. I will love it. Something from the marketing work that I've done on the past years is that it is very hard to get people to change from something that is already working for them, even if we have something better to offer. So it's going to be very interesting to hear from you, the best of the best, about why GraalVM and how to do the best, to make the best out of it for production. If you want to share your slides.
I love your excitement. Let me share. In the meantime, I can see that there's already a question about GraalPy in the chat. So stay tuned. This is not about GraalPy, but I will have a GraalPy demo. So that will be also interesting.
GraalPy demo during the session today. And so do you have
but remind me how much time I have. Do I need to finish at past?
You have as much time as you want. You're my friend.
So
let me see here. But while you are sharing, I'm gonna check that out. And one quick question, girl. Oh, you have an hour. You do got time.
Cool. Let me start sharing.
So real quick here. Do you have 2 screens or only one?
I do. Not my first time. I have 2, and I started sharing. You need to bring my
Of course,
screen on
it's not your first time. But I wonder if you prefer to follow the questions and bring them whenever you feel proper, or do you want me to bring them over?
Up to you. I think I'll try to keep the screen with the questions, but up to you. If you see that I'm not responding to something, you can bring that up too.
I already know I won't have to do anything during the session. The stage is yours, girl.
You can go and take yourself a coffee and have some rest. I got it. Don't worry. I have water.
Okay, girl. Okay, go ahead.
Thank you. Awesome. Okay. Hi, everyone. I'm super happy to be here. I was here on this YouTube channel a while ago, maybe a year or 2 years ago. I had the best time ever. I had a lot of cool questions and great conversations. So I'm happy to join you guys again. And this session today is called Bringing the Action Using GraalVM in Production. So I will try to show you as many practical things as possible so that you can use GraalVM to the fullest, all the latest features, all the performance optimizations. But also, I want to reserve some time in the end to talk about upcoming features and big projects we are working on. Karina, what's up? You're back.
I'm back. I would like to ask you to increase the font size, please, just to assure everybody.
Sorry, girl. Yeah. Good point. So much for me bragging that this is not my first time. Let me increase it. Now, I'm not a big fan of doing slides, and especially I don't have a lot of time. So if that's okay with you guys, we will have this little agenda in the README, so in this markdown. But also, if you prefer slides, I will share with you in the end a link to this repo, and there you will find all the links, the demos that I showed today, and also kind of a slides version of this talk if you prefer slides, if you are maybe more of a visual learner. So with that, let's dive into GraalVM. So a very quick introduction, as I promised Karina. So here is a quick overview of what GraalVM is and what it can do for you, because, some people are confused. It's a new project, fairly new project in the Java ecosystem, and there are so many things you can do with it. You might have heard terms like polyglot VM. You might have heard that it's a JIT compiler. So what is it? It's a lot of things. It's a big name, kind of combining a lot of things inside of it. But what you need to remember about GraalVM is that there are 3 main kind of big parts of it, 3 main big components. So one is GraalVM is a JVM, just like any other JVM of your choice. And you can use GraalVM to run your Java applications as normally on the JVM. So in this mode, in the first mode that you see on the screen here, we have underlying the same JVM, such as, for example, your OpenJDK, but we have a different, more optimizing Graal JIT compiler. So you might know that in your OpenJDK, for example, you have the C2 compiler, which is very good, but then GraalVM is a brand new compiler implemented by our team. We did a lot of research to make it better, to make it as good as possible. So if you want, you can just use GraalVM as your Java installation. And in that case, you can expect 10 to 15% performance improvement just by swapping your Java installation to GraalVM. So that is this first part of the screen. Now in the middle, there is a part called native image, and that is ahead of time compilation part of GraalVM. So we can take your Java application and compile it ahead of time into a native program. In the end, what you have is something similar to how you would write your program, let's say in C. So it's a native executable, but you still get to write it in Java. So you have all your favorite developer productivity tools, all your favorite Java features. You just write your program in Java, and in the end, we convert it to a native executable. And then the last part here is you might have heard that there are more languages than Java that we can execute, and indeed it is so. So on the screen here, you see all the different language implementations that are implemented by our team. So you can run, for example, JavaScript on GraalVM, you can run Python, many other languages, and better yet, you can embed all those languages in Java. So let's say there is some cool data science, machine learning library in Python that you would like to use, but your current application is in Java. So with GraalVM, you can bridge the best of both worlds. You can have your existing Java application, and you can just add that Python library to it. And in the end, if we have time, I hope we will have time, I will show you a demo of how that Java and Python works together and how you can set up such a project. So this slide is basically my answer to, when sometimes I go to conferences and people ask me when they should not use GraalVM. So what is a not good use case to use GraalVM? And my answer is always use GraalVM. Just choose which part of GraalVM works best for you. So do you want to stay in the JVM world and just have a better JIT compiler? Then you can just go with GraalVM as your JVM, like the first part here. If you want fast startup, low memory footprint, low resources usage, go ahead with native image, so ahead of time compilation. And then if you want to mix and match languages, if you want to extend what your Java application can do, go ahead with those polyglot capabilities of GraalVM. So this is an overview, but just not to confuse anyone, in this session today, I want specifically to focus on this ahead of time native image part of GraalVM. I'll be honest with you, this might be my favorite part, and there are a lot of cool things to show there. So we will talk mostly about this ahead of time compilation here, but if you have any questions about other parts of GraalVM, just feel free to follow up with me on social. So this was a quick intro to GraalVM. Let me just find where we are. And then super quickly about native image. I'm kind of hoping that by now you have tried native image yourself, but just in case you haven't, this is your quick intro to native image and all the things that you need to know. So if you think about it, ahead of time compilation, you might be wondering how it's possible even to take something as dynamic as a Java application, where typically a lot of things are happening at runtime and are dynamically resolved at runtime, how it's possible to take it and then compile it ahead of time before the runtime has even happened. So to do so is you need to do the following. So when you run our native image command and give it your application, and then as input, it needs to take bytecode. So it needs to be your jar or your class files. So you run native image, you give it your application, and then what happens next? As at the build time, native image will look at your application, and it will try to analyze everything that your application does. So what is supposed to be the behavior and function of your application at runtime? And native image will do so starting from the application's main entry point. So from main, it will look downwards and downwards into your application, trying to find all the reachable code. So all the code that your application actually needs to be doing what it's supposed to be doing. And then we will take that code and compile it and only include that code that is actually involved in what the application is supposed to be doing, only include that into that native executable. And at the same time, we will strip away, we will remove everything that you are not using. And this way, we can really aggressively remove all the code that you are not using and then optimize to the fullest the code that you actually need. And all that I mentioned applies to your code that you actually yourself wrote, what you call user code, but also to your dependencies, to the JDK. We just look at your project as a whole and then compile only the parts that you need into that native executable. So this is one part of the story. And another part is that we will look at your application's heap and we will see what is safe to initialize at build time. And we will also prepare with you a version of heap, kind of a snapshot, so that you can start faster with this pre-populated heap. But obviously, since this happens at build time, this needs to happen under a closed world assumption. So everything there is to know about your application needs to be known in advance when we actually compile your application. And then in the end, you have a native executable that doesn't need a JVM to run. So you can even run it on a machine that doesn't have any sort of Java runtime on it, just as a native executable, and it will be fully functional, it will start very fast, and it will use very little memory. Now, with that intro out of the way, I love doing demos, so let us switch to the first demo. Okay,
See,
and the first application...
I knew I wouldn't regret having you around. Demos, we all love demos. Go ahead, girl.
I have the complete folder of demos. Let me see how many I can do in this hour.
Wow.
Okay.
See how fancy that girl is. I have a full folder. You can pick and choose. All right, what are we going to see now?
Okay, guys, let's look at the first application. It's called Dictionaries. So as you're going to guess, it is some sort of dictionary application. And we are here on GraalVM for JDK 24, so the latest released and patched version of GraalVM. In case you're wondering, in case you want to remember when do we release GraalVM, when is the next release, it's very easy. So every time there is a new Java release, so as you know, it's March and September every year. On the exact same day, you also get a new GraalVM release on the exact same day, exact same time. So if I may suggest, when you upgrade to your latest Java version, you can just download GraalVM, and this way you have the latest Java features, the latest GraalVM features, all with one download. But let's run our application. So we are here on GraalVM for JDK 24, and the app that we will be running will be a Spring Boot application. So let's run it like so, and we will see what it does in a sec. So it runs, and I need to say that this runs on a cloud instance. So hopefully it's not affected by my local machine. It should be nice and clean and isolated environment. Let's see what this application does. The endpoint is translations. And normally I like asking people what they think is this language, but I will save you the trouble and I will just give you the answer. This is Swiss German. If you happen to be a language nerd like I am, I encourage you to look into Swiss German. It's a very fun language.
How many languages
so this
can
is
you speak, girl? How many languages can you speak? Are you like Otávio? Otávio speaks 5, I guess.
I can speak 3 languages solid, and then 2 or 3 I understand to some extent, but probably not as good as Otávio, I must say.
Which would be those languages? Just out of curiosity.
So what I speak good, or fairly good, we can agree, I speak Ukrainian, I speak English, and technically I speak Russian. Then also I understand Polish very well. I understand Spanish to some extent, and I'm trying to learn German, but I must say I'm not succeeding much. So those are my languages.
Sounds like the hardest. Entonces podemos hablar en español.
Un poco.
Okay.
Okay, so this is our application, and it runs, and it maybe exposes some endpoint. Maybe you can have something like that running in production at your work, where you have an endpoint where, let's say, your client can retrieve some sort of data. But this application started in 2.5-ish seconds, and I think we can improve that. So let's move it to GraalVM. For that, if you want to move any random application you are working on to GraalVM, what I would suggest as number 1 step is to go to Native Build Tools. And this is the project from our team where we have implemented for you Maven and Gradle plugins so that you can easily build your projects with GraalVM. So as the number 1 step, whatever you're working on, I suggest that you go here and you start from here. For example, if you want to go with Maven, I personally prefer Maven, you can just go here and copy our plugin and take it from there. But my project happens to be a Spring project. So one more thing that I can do is, for example, go to start.spring.io. And here, when I click dependencies, I can see that native image is even the very first thing on the list. So here, when I click explore and namely go to my POM.xml, I see that there is this one plugin responsible for native compilation, and it's called Native Maven plugin. So it's the same plugin as here from the GraalVM team, only here it is kind of exposed as a Spring dependency. And the Spring team is nice enough to include this by default as their way of kind of adding native image capabilities to projects. And I recommend that you do this because whatever you need to configure for building your applications, this is the place where you would start. And also, if you need to use libraries, this plugin will greatly help you make those libraries work specifically in the native image mode. In the meantime, I see a question. So before I jump into compilation, I can maybe even answer it. When we use native compilation, will we be able to run it on the same OS only, say VM architecture? So indeed, I would get to it later down the talk, but indeed, we don't have cross-compilation capabilities out of the box. So you need to build for the specific operating system and architecture. So for example, I cannot build on my Apple Silicon Mac for Linux. In that case, you can use either CI/CD or do containers, because we do need some JDK-specific classes for each platform. So out of the box, indeed, you need to build for all the platforms that you need, where you plan to deploy or give your users applications. So let's get to the compilation. So I will just get this native Maven plugin from here and add it to my project. Let's go back. And dictionary, and this is my POM XML. So I will just add our native Maven plugin here. Looks good. And normally I can compile it like this, but for the sake of saving time and also for the sake of making this a bit more, I think, useful for you, I would like to add one little configuration block. So this configuration block with the native Maven plugin is how you would configure anything related to native image. And the way to do so will be to add configuration section, build args, and then within that, you can add an individual build arg. And this is a way to pass whatever you want argument to native image. So let me pass mine, and then I will tell you what this is doing. I did this, and now let's compile our application. So the command that I ran right now started my build. As my application compiles, I can tell you what this is. So this -OB stands for optimize for build. Since I have limited time, but also this is something I would do at work as I'm still building my application. Maybe I'm not ready to deploy it to production yet. I just want to compile it and see if it works. Maybe I added some changes. Maybe I added a new dependency. So I'm not deploying yet. I just want to quickly compile it and see whether it is still functional. So this flag will give me faster compilation times at the cost of not optimizing for the best peak throughput. So my application will still be fast, but not as fast. And you can think of it as a development mode as opposed to production mode. So if I just want to compile and see that my application works, I would do -OB. If I'm ready to deploy to production, I can either remove this flag and then rely on defaults, or if you want to optimize for, let's say, the best possible peak throughput, I can pass -O3. So this is optimizing for the best peak throughput. And there are also other things that you can optimize for. For example, if you want to have smaller packaging, smaller container image, you can do -OS, and this will be optimizing for size. But for me, for demo purposes and also for kind of development purposes, I like using -OB for quick build. And normally, if I'm showing this at a conference, people are asking me, Alina, this is so long. Why does this native image build has to be so long? I don't have this kind of patience. I don't have the attention span for those builds. But look at this. So this was actually our project. And the project, you've seen it exposes one endpoint. It's not that complicated. So this is our controller. It has a service. And then we are retrieving our data from H2. And then we have our actual translations over here. So nothing too complicated, right? What I wrote myself is 5 classes. And then granted, I have my Spring Web, Spring Data, all of that as my dependencies. But nevertheless, even this fairly trivial demo project, if we look at the analysis performed by native image, this project itself included 33K reachable types, 51K reachable fields, and 187K reachable methods. So all those reachable things mean actually things that are needed for the application actually included in the app. So as you know, Java gives us great peak performance, great developer productivity, libraries, etc. But under the hood in our projects, there is quite a bit of complexity to enable that great peak throughput and great developer productivity. This is indeed what native image discovers down the line. So under the hood in my fairly simple project, there is a lot of complexity going on. And that native image needs to understand all that at build time analyze, optimize, compile. Nevertheless, my application was compiled in 1 minute 7 seconds, which I would say is pretty good for a fully blown Spring Web application. Yes, I see that was thanks for the question. All good. So let's see how our application runs. We see our build artifacts. What we actually need is this dictionary executable, and the rest is just files generated alongside the build. What we need is this dictionary. So let's go ahead and run it. Target dictionary. So if you remember previously, our application started in 2.5-ish seconds. Now it starts only in 143 milliseconds. And if we go back here and again open our endpoint, we see the exact same data. So our application does the exact same thing, only now it starts not even like a fraction of time faster, but order of magnitude faster, 143 milliseconds as opposed to 2.3 seconds. I think this is pretty good. But this is just the startup. There are many other interesting aspects of native image. One that I think might be even more important than startup is resources usage. So maybe if you can have the same application consuming less memory, less CPU, less electricity even, you can deploy it on a smaller cloud instance, or if you're running on your own hardware, you can then use less hardware. So let's go back to our application and do quick, not even benchmarking, we will do benchmarking down the line, but let's do quick resources measurements. For that, we will just use the Linux standard time command, and we will start our application again, and I will go back to it and won't even do load testing, but let's say send some load to the application so it's not completely idle, but it is serving some mild traffic. So when we go back and kill the app, we have sent maybe, I don't know, 15-ish requests over 3 seconds. Those are some of the metrics of our process running. So this application, and I didn't even set any memory settings or anything, this was just running and having full machine available to the process. So as it ran, we see that the CPU that our application used was only 1%. So it was very low CPU. Granted, the application is not that complicated, it's not doing much, but even in this kind of minimal load state, it's not burning unnecessary resources. It's very efficient because it was all compiled at build time and optimized at build time. And overall, this is the promise and kind of idea of native image, to shift all the work that the JVM normally does at runtime, such as loading classes, compiling, profiling, optimizing, etc., shift all of that to the build time and do it once so that you can start faster and using fewer resources every time you start your application. So in terms of CPU, we used only 1% of CPU. Sometimes it's 1 or 2, but like very low numbers. And then when it comes to memory, we are at 100, let's say 40-ish megs of RAM. Granted, again, this is still not doing much, but for fully functional Spring Web application serving some requests, I would say 140 megs of RAM is a pretty good memory usage, again, without limiting. If we wanted to, we could have set here XMX to some minimal number, and the memory would have went down even lower. But I would say still 140 megs of RAM is very good for a fully deployed application. Okay, I see another question here. Will future versions of GraalVM support automatic handling of reflection like hotspot without needing manual configuration files? Good question. I will talk again in the end towards our future projects, and there we have some work in progress which I think will address your reflection concern. But also I will switch soon to a section where I'm talking about libraries, and there we will talk about how you can use libraries and what are the efforts there that we make to make sure that you can use more and more libraries in native image without any need for manual configuration. So there will be update down the line. With that, let me wrap up that first demo. And let's say I convinced you that maybe, okay, GraalVM looks interesting. This is something you would like to try. But what about using libraries, and specifically such as we were just asked just now, what about reflection, and what about using reflection with GraalVM, and how does that affect using libraries? Let's talk about that. So How is using libraries in GraalVM and namely native image different from the JVM, and what are the things that we need to know there? So as I mentioned when I was describing how native image works, it builds your application under closed world assumption at build time, meaning everything there is to know about your application needs to be known at build time. And this means that those more dynamic Java features such as reflection, serialization, proxies, GNI, but typically it is reflection, they require a configuration in native image to work. Now, I can talk about this for a long time, but I'm not sure we need to stop much there. But detailed DR for reflection is that there is basic support for reflection in native image out of the box. So those more kind of predictable, more simple reflection calls, native image can even figure out automatically. So things like class for name, etc., they will just work in native image with zero configuration. But what to do in cases when there is more advanced reflection at runtime, which requires configuration? Let's talk about that. And here I will talk about how libraries approach reflection and how you can also approach reflection in your application. And this section of the talk maybe will be a bit less entertaining, but I think it's very important if you will use libraries with native image. So stay tuned, and I hope we will go through this fast, and then we'll quickly switch to, again, fun things such as performance benchmarking. So how can you use libraries? And typically the main candidate for things breaking there is reflection. So how we can use libraries with GraalVM when it comes to reflection. Here we will talk about a few scenarios going from the best case scenario to, let's say, a scenario that requires a little bit more work from your side. So the best case scenario, if you want to use a library with native image, is when a library is designed out of the box in a native image friendly way, such as maybe don't using reflection as heavily. And this is a very new trend, but we see more and more of this trend lately where new libraries appear in the JVM ecosystem, and some of the maintainers decide to design them in the maybe less reflection heavy way, because reflection, while being useful and powerful, can also add a bit of complexity and kind of overhead in terms of performance. So we see this trend where maintainers develop their libraries in a way that is less reflection, kind of relying on reflection, and then those just work with native image out of the box with zero effort. But also we realize that there are many libraries that have existed in the JVM ecosystem long before GraalVM became popular. So what to do about those libraries and how to solve reflection issues in those libraries. So the dictionary application that I was sharing with you in a couple minutes ago, I like showing that demo because that demo uses H2 as a database. And in the past, I used to have a different demo where I showed how I built an application with H2 and it successfully compiles, but then it breaks at runtime because the application doesn't understand how to work with reflection in H2. But now my application just compiled, and one of the reasons why it worked so easily is because H2 added config for native image within the library itself. So here we are looking at the source code of H2 on GitHub, and there we have a file called reflect.config.json, and here they're specifying all the necessary configuration for GraalVM and native image. So when you build such an application, for example, using H2, native image will look for this null location for config files, and this way it can understand how to work with those applications. So if you happen to be a library maintainer, or if you happen to be in touch with a library maintainer, the best way to add support for native image is to add those configuration files within a library directly. And if you want to do it, you can talk to me and I will help you figure out how to add such support in your library. But then again, we understand that not all libraries can do this. Not all libraries have big teams, especially of open source maintainers behind them. So what to do if a library hasn't added support for GraalVM and native image yet? Now, here you would think that if you would need config for many different libraries out there, it will be great if there existed kind of something like Maven Central, but for this config, where let's say if I have figured out config for H2, maybe my friend, my colleague doesn't need to do the same thing. They can just reuse my config that I have already tried and I know that it's working. So we, together with our community, sought the same thing, and we have created this space on GitHub, this repo on GitHub, where we host configuration for many known libraries in the ecosystem. And this is a community maintained project where, for example, I don't know, for OpenTelemetry, let's say you have for all the different packages within OpenTelemetry config for native image stored here centrally on GitHub. And the best part of it is that if you are using our native build tools, so our native and Maven and Gradle plugins, the ones that I have mentioned in the beginning, they are integrated with this repo. So if I'm using one of those libraries that have config in this repository and I'm using our native build tools, the build tools will go to GitHub and will look for config and will automatically pull this config from GitHub without me having to do any kinds of manual reflection config. So this is pretty great, and we are very grateful to our community for doing this effort and helping figure out config for many libraries in the Java ecosystem. A quick note here, if you want to very quickly evaluate your libraries and understand if your project will compile successfully with native image, I mean, I would always just add a plugin and see if it compiles. But if you want to have a very quick answer with basically very little effort, what you can do is you can go to this page on the GraalVM website called Ready for Native Image. And here you will find a very, very long list of libraries and frameworks that we know are integrating and testing with native image constantly. So let's say I want to use, I don't know, one of the Micronaut packages. I can find all of them here and see that they are tested with native image, and most likely, definitely, they will compile successfully. Or I don't know, maybe I want to do test containers. They are also on this page. So as the very quick step to evaluate if your applications will compile with native image, I would suggest to go to this page and look for your dependencies here. And in any case, you can just try compiling and see how it works for you. Now, so if you're starting a new project now in 2025, I think config will be solved for you by one of those scenarios. But then let's say maybe you have code that you yourself have wrote, or maybe you have some internal, I don't know, library at your company that is using reflection and you would like to make it work with native image, but because it's your internal code or library, there is no config for it somewhere in the open source. What to do in that case? In that case, I would suggest you would look at the framework that you are using. So many of the popular Java frameworks, such as Spring Boot, Micronaut, Quarkus, Helidon, they integrate with native image, and they even give you tools to automatically generate this config for things like reflection. For that, let's quickly look at the Micronaut application that I have over here. And here we will have, again, a web application that is trying to do reflection. And you can see that it's doing so in a maybe less obvious and more confusing way. And this is to try to retrieve this message field from the message class. So the one over here, but we are intentionally passing the class name in a way to confuse native image, because if this was a normal reflection call, native image would have just resolved this automatically. So again, we are doing this intentionally in a such confusing way. How to make this call build, how to make this application build and this call work with native image. So because I'm on Micronaut, I have a support from my framework to generate this config for reflection. So all I need to do is I need to go to my place where the reflection should occur, so my callee site. And here I just need to add one annotation from the Micronaut framework. And what will happen when I compile my application, so under my classes, Micronaut will generate for me config for that one reflection call. So this is a bit of work as a developer, but I would argue that adding one annotation and generating that config programmatically is still an acceptable way to go if I have some custom kind of reflection-heavy call. Now, just two final notes on the reflection front. If none of the previous options work for you, if you are out of luck, you have some custom library, maybe you have some older framework, you have no support whatsoever, you are still not completely out of luck. What you can do in that case, you can use our tracing agent that comes with native image, and you can run your application on the JVM, and this agent will look at your application and everything that it does, specifically in terms of reflections, serialization, etc. And it will generate those JSON config files for you. And then lastly, you can also manually create a JSON file for any of those dynamic Java features. But I hope that you'll never have to get to this. And I hope, especially for newer applications, that you would stay somewhere here where that config either will not be necessary at all, or it will be provided to you by a library or from our reachability repository. Now, if you are watching this and if you want to know how to use libraries with native image, you can screenshot this specific part of the agenda. And now we will switch into what I think is a bit more fun and entertaining section, and that is we will do some live performance benchmarking. So I quite often get this question about how AOT code can get anywhere.
When you tell them to screenshot something, then you gotta do the thingy that you did on the picture, you know, because you're gonna be on the screenshot, yeah.
Oh, yeah, let me open it again. Yeah, okay, guys, now you can screenshot with the heart. Thank you. Now, performance benchmarking. So I know that as Java developers, we love our peak throughput. We are not willing to compromise it. Even if we have fast startup and low memory footprint, we want to make sure that our applications are still very fast and are very good at throughput. So how to do it with native image, and whether or not can IoT code even be as fast as JIT compiled code. Let's see some of that in action. For that, let's go to yet another demo. Here we will have another application. Here we will switch back to Spring Boot. And I will quickly show you our performance benchmarking setup. So the application that we will be running will be the famous Spring Pet Clinic application. For the sake of saving time, I will not start it now, but it's basically a typical kind of web enterprise app where you have different endpoints, you can read and write data, and it basically emulates an application that could have been used at a pet clinic, where you can create owners, create pets, schedule visits, read data, write data, so kind of act as an application used by veterinarians. And that will be our application. Now, our actual benchmarking setup will be the following. First, we will run on C2, so the standard OpenJDK compiler, and this will be my benchmarking script for that. So I don't have even OpenJDK on my machine. I only have different flavors of GraalVM. So to emulate C2, we will be turning off the GraalVM JIT compiler and then starting our pet clinic jar. Along with it, we will also use the tool called PS Record to observe our application's memory and CPU usage. And then we will start our application and let it for 10 seconds. We will just let it start. We are not even touching the application. Then for 10 more seconds, we are sending requests, but we are letting the application warm up. And then for the last 20 seconds, we are actually measuring, benchmarking the already warmed up application on the JVM in this OpenJDK kind of setup. So this is still not entirely scientific. The benchmarks that we run internally are way more complicated, also way longer. But let's use it because for like the sake of conference talk or online talk, this is probably the closest you can get to proper benchmarking. So then let's run this one, and this will run on C2. Oh, I see Max. Max was my host from previous time when I was speaking at the same channel. Hi, Max. So we talked about the methodology, but I didn't show you what are the actual requests that we are sending, and I want to show it to you because it's quite interesting. So instead of starting the application and just bombing one endpoint with countless requests, we are trying to be smart and we are trying to have a fair benchmark. So what we are doing is we have our workload script defined in Lua, and here we are creating a new owner, creating a new pet. Then we are navigating to the owners list, then we are creating a visit. So we are trying to hit all the different endpoints and both read and write data so that we can have kind of emulated human behavior in a way, and we can have a more fair benchmark instead of overly optimizing just one endpoint, because you would say that this is not fair, and I would agree with you. So as I was sharing you the benchmark, our application finished running. And again, this is running kind of on OpenJDK. What do we see here? One observation that I have is that in the warm-up run, our application had 500 requests per second, and then the JVM warms up. We all know that. So in the end, it arrives at 1.5, almost 1.6K requests per second. Is this fast? maybe it is, maybe it isn't. Maybe we wouldn't know unless we have a comparison point, right? So let's compare this with a native application. So now enters GraalVM. Let's look at our native benchmark. And here we have a very similar setup. So this is our native benchmarking setup. So again, very similar. We are starting, we are waiting for 10 seconds. We don't have to, but we just want to have a similar setup as we did on the JVM. Then we are warming up for 10 seconds, and then we are benchmarking for 20 seconds. That is the exact same setup, only now it runs as a native application. So let's go ahead and run this. Bench native. So now our application starts, and we are waiting the same 10 seconds as we did on the JVM, because the JVM needs to do a lot of work. It needs to load the classes, look at them, interpret, profile, compile, etc. So the native application also waits, but as you will see in the end in the charts, it doesn't need to wait. This is just the time that we are waiting so that we can have apples to apples comparison. But honestly, the native application right now is just idle. It's all started. It's all warmed up. It doesn't need any warming up curve. It's all ready to go. We are just waiting to have the same kind of setup as we did on the JVM. Okay, so our benchmark is completed now. Maybe I can zoom out a little bit so we see the numbers better. So what we see here is our native application indeed didn't need to warm up. We see that in both warming up and benchmarking round, the performance was very stable. It was at 1.2K requests per second, but it is stable and it is high, but it is lower than the JVM. And here I could have told you, guys, the JVM is amazing at peak throughput. It's very hard to beat it at its own game. It's so amazing. And it is all true. And the JVM also does the profiling runtime. So it's very hard to compete with the JVM when it comes to peak throughput. It is all true, but I do think we can do better. Let's see if we can do better. For that, I will run one final configuration on our benchmark. And there I will run an application that is called Native Optimized. So I have built a different version of this app. And let me try to carefully close this so we can talk about the specific optimization things that I have did in that last application. So how is this application different from what we ran in the middle, where we had our native config out of the box? And in general, what do you need to do if you want to optimize your native application for the best peak throughput? So the most powerful thing that you can do to have the best peak throughput is called PGO. This is Profile Guided Optimizations. So you know how the JVM profiles your code as you run. The JVM looks at it, looks at your application, sees which part of the application are warm and are performance critical. So which part of the application are most often executed, and this applies to methods, to loops, to everything. So the JVM has an understanding of your application as it runs, and it can adapt on the go. And you can tell me that a native image cannot do it, but this is not entirely true, and this is where PGO comes into play. So what you can do with PGO is you can build an instrumented version of your application, then run it with relevant workloads, and when you shut down your application, so when you stop it, you will get a profile files that is similar to how the JVM profiles your application. So you can collect the information about how your application runs and what happens at runtime, and then you can start your native build once again with those profiles in place. And this way you can kind of have the best of both worlds, where you can still optimizing your application ahead of time, and you can use all the time and resources to optimize for the best peak throughput. But also you have the insight into the runtime behavior of your application, because we have collected this information in advance. So with PGO, you can get very close to the performance of a JIT compiled code. But clearly, this requires a two-step process where you collect profiles and then you build again with profiles in place. So what to do if you don't want to do this, or maybe you don't have the time for this, or maybe you just don't care about peak throughput that much. Maybe you just have your kind of pet project and you want to run it fast, but you're not ready to do this two-step process. Now, you would think it's 2025, we are in the world of AI and ML, and maybe we can use some sort of ML to drive compiler optimizations. And we saw the same thing. So we are shipping in native image a tiny little ML model that can infer, predict your application profiles. And clearly, it's not as accurate as the information that you would have collected yourself manually, but still it can give maybe 8-10% performance improvement over not having any profiles in place. So 8-10% performance improvement out of the box. I think this is pretty good with one build. Now, there are different GC options in native image, but I would suggest if you want to have the best peak throughput to use G1 GC. And then the last option here, MARC native, this says optimize this native executable for the specific hardware features of my machine. So even within the same platform and architecture, there could be different kind of sorts and like generations of models. So this is instructing native image to specialize for this specific machine as opposed to, let's say, different generations of the same platform. Now, with all this explanation, I have a benchmark finished running. So let's look at our results. Now, our JVM was in the end, in the final performance run, it was at 1.5, almost 1.6K requests per second. Now, native image out of the box was at 1.2, so somewhat slower. But then native image with all the optimizations was at 1.6, or even 1.64. Now, clearly this is a benchmark, and I need to tell you to take all numbers with like critical thinking and benchmark on your own app. But I think it does convey the message that if you apply those additional optimizations, you can have peak performance on par or very similar to the JVM. Now, I know I don't have that much time, but I want to illustrate a point about which I care about, and that is resources usage. And as we were benchmarking our application, we were also doing resources measurements of each of our benchmarking round. So let's very quickly look at that. So before you ask me, because I know everyone wants to know this is collected by a tool called PS Record, and this is observing the process and measuring the CPU usage. So CPU is vertical red lines, and the horizontal blue line, that is memory usage. Now, I have several observations here. One is that the JVM, remember how I told you that the JVM needs around 10 seconds to start? So it needed around 5, but we gave it 10 just to be on the safe side. So it did have all the time it needed to start. So we see that the CPU is quite busy when the JVM starts, because there is quite a bit of that overhead work that needs to happen when you first start the application. And then when we hit the application with the load, the CPU is still very busy because it needs to profile and compile that code on the go. Now, the memory settings were the same for all 3 benchmarks, but the JVM went a bit through the roof with our 512 max, because under the load, it needed more memory. Now, native image, remember how I told you that it was just waiting for 10 seconds? And indeed, we see that the application loaded. But then as we were waiting for the application for our load to come in, it was just idle and ready to go. We were just waiting for the JVM kind of version of the setup. And lastly, memory usage in native image out of the box, it was very low. So even given 500 max, it just used around 200. And then the last version, the one that was more performant, memory usage here is a bit higher because we are using G1 GC, but it's still much lower than the one that we had on the JVM. So the conclusion here is that with native image, if you apply additional optimizations, you can have peak throughput on par with the JVM while having less CPU, less memory. And we are not measuring here today, but you also even use less electricity with native image. Now, I do want to spend some time to talk with you about some of our future projects and also address some of the questions that we had in the beginning, where, for example, we wanted to see GraalVM. So let me skip through some of the sections because you can find all the info in this repo on GitHub. And I want to talk about the future projects. So remember how I told you that native image compiles your application into a native executable. The native executable has everything that you need, and that is this deployment unit. And then we throw away everything that you don't need. Now, we are working on a new big project in the native image space. It's very ambitious. We have a big team working on it, and we will see results hopefully soon. And it's called native image layers. So with layers, we are working on a way to give you a way to build native image applications, kind of similar to how you have Docker images and Docker deployments, where let's say I have a Micronaut application, and I can compile once my JDK base, my Micronaut base, my, let's say, Micronaut web, Micronaut data, and those stayed compiled as my base layers. But then every time I need to introduce changes to my code, the code that I wrote, I only need to recompile my user code, and then those base layers, they stay compiled, and I'm just linking that to my application. With this, we expect that we can take compilation times down significantly to maybe a matter of seconds, because you are only recompiling your user code and not the whole project. So we are changing things dramatically, but we think this can improve build times significantly. Now, another interesting benefit here is I talked a lot about resources consumption. This is something I care about because I believe in efficiency, and I think all applications should be more efficient. But then with layers, you will also be able, let's say, if you deploy your application, and again, I have maybe 5 instances of my Micronaut app, of my Spring app. If I have the same base layers deployed there, those 5 instances can just share those base layers. And let's say I can only have one layer for JDK, one layer for web, and then all my 5 instances are using the same base layers. And this way I can even further reduce resources consumption in the cloud because we are reusing those base layers among my instances. So this is very exciting, and I'm really excited to see it in action. Now, one more, even maybe more mind-bending project in the native image space will be called Project Crema, and this builds on this native image layers project. And the way Crema will work is, imagine I told you about layers very briefly, but imagine your top layer, so your application layer. We will add there a Java interpreter, and this way we will be able to load new classes in native image. So we are lifting this default closed world assumption. It doesn't exist anymore because you can still have your native image compiled, but you will be able to load new classes. And we think this will address many of those issues with compatibility, allowing libraries that want to load new classes at runtime. So again, another big ambitious project, but we will be able to have open world for native image where you will be able to load new classes as your native image is still natively compiled. Another interesting project, and this might be arriving sooner than the previous two, is called Preserve All. And this is, again, kind of rethinking and maybe taking a different direction for native image or a parallel direction, where we want to give you a chance, if you want, to compile your complete project into a native image, so not strip away anything. So let's say I want to compile everything that I have in my project, or maybe I want to, I have some problematic package or module that I'm not sure will compile with native image. So I can specify to either compile everything or compile that specific package or module as is completely. And this way, we think we will solve a lot of those library changes for libraries that haven't added support for native image. If you want, you can just take an old legacy application, build it with this flag into a rather big native image, and it will compile out of the box. You will probably not run into any issues at all. So this will be very interesting. This is merged already, and I think we will see it in the next release in 25 in September. Now, I was also asked about GraalPy. GraalPy deserves its own separate talk, but let's see if I can very quickly show you a quick GraalPy demo. I know that I'm a bit behind on time, or like not behind, but like running out soon, but let's see if I can make it happen. For that, let's go to a different place called GraalPy. And here we will look at a Micronaut application that is using GraalPy to plot a chart. Let's actually run it first and then see what it does. So I have compiled already here. Target. It's just called demo. So it starts, and it's normal Micronaut application. It started very fast. And then if we go to our application and see what it does, Python, it will load for us. Let me just zoom out. This beautiful chart that is also interactive, so you can click and retrieve different data here. It's all very nice and interactive, but how does it work under the hood, and what has GraalPy to do with it? Let's look at this project. So GraalPy Micronaut, and this is a Java application, as we can see. So far it looks pretty normal. And there we have many different endpoints where we are using in our base Java Micronaut application Python to a different extent. Overall, we are using the PyGal library from Python to plot this chart, this nice chart that we saw just now. And then you can use either like define more logic in Java or define more logic in Python, up to you. So for example, here we are looking at the Python version. And basically, the way you program something like this is you create this context for a language, and you say which language this is. In our case, it's Python. And then you can write the code directly in Python. So for example, have it's done here, again, from within a normal Java Micronaut application. And the best part of it, which I like the most, is recently we did a lot of changes around developer experience of embedding languages in Java. So currently, the way this works, let's say you have your existing deployment in Java and you want to add Python, all you need to do is to add two dependencies. That is to add GraalVM Polyglot and add GraalVM Python. And also, I do recommend that you add our Graal Py plugin. And then what you can do, the best part is you can define from your POM.xml your Python packages, because if you ever did those kind of polyglot projects, you know that it's very hard to bridge those gaps between different package managers, languages, ecosystems, etc. And here I can define my packages, what I want to use in my application and the specific versions straight from my POM.xml. Again, this is just defining my Python packages from POM.xml, which I think is the best thing ever, because I don't need to figure out all those Python virtual environments things. I can just do it from my POM.xml or from my Gradle, whatever is the language of my choice. And then I can easily use Python from my Java applications. So this is pretty mind-bending, but to finish with the last, even more mind-bending, potentially demo, I want to show you one more thing. This is actually something you can also try at home. We have this page deployed on our GraalVM org website. And this is called, as you can see here, Java C on WebAssembly. So the page might look to you like some sort of Java learning environment. Maybe it's coded in just plain HTML, CSS, JavaScript, but no. So this is the actual Java C, the Java C compiler, the one that turns your source code into the Java bytecode, compiled to a WebAssembly module just deployed here for demo purposes. And this is done using native image, because native image, I told you many times that it outputs a native executable, but technically there is no limit to what native image can take as input and output as output. The limit is only your imagination. And to prove to you that this is real, I can modify this code slightly. So let's say we want maybe to add another string. Let's say we want to say hello from, I don't know, YouTube. And we can even add some sort of emoji, because why not? And we can compile this. It compiled, but also to prove to you that this is real, I can disassemble it. And here I will see all my instructions. So this is actual Java bytecode and actual Java C compiler running here completely in WebAssembly compiled with native image. And we can see that this is real because we see our original string, we see how all of the instructions are loaded, and then we see even our YouTube string that we have added just now. So let me just summarize this by coming back to my IDE and showing you all the final links that I wanted to share with you, where it is my GraalVM deep dive. So to get started, the best way to install GraalVM, I recommend to everyone, is to use SDKman. I love SDKman, a big fan, and you should love and use SDKman as well. It's the best thing to install and manage your JDKs. And if you want to try some of the demos that I have showed, they are here on the GraalVM demos, but also I will share the link to this repo specifically. If you have any sort of questions, you can always catch me on social. And again, here you can find demos. And for this repo that I was showing you here in this talk with the readmes and all the links and all the resources, including slides, this should be the QR code to the repo, but also you can find it on GitHub under my name, and the repo is called GraalVM Deep Dive. Now, that is it. I hope I was not too much over time. I think we started a bit later. What do you guys think?
Oh my gosh. And sorry for the delay in coming in. I was talking to our next speaker who is already here, but this was brilliant. And now I believe that you actually have 1,000 demos over there ready to just pull up whenever we need to see something.
At all times.
The thing that I love about GraalVM that you just showed today is that it really thought about all the potential uses that developers might need. So even when it's not ready for the very specific thing, it is still flexible enough to offer them a way to do it, and not even to mention all the innovation that you presented also. So, girl, it was really cool to have you on board on
Thank you so much.
Week.
This is such a great live stream. I was so happy when you messaged me. I thought this is a brilliant idea. All the speakers just coming together celebrating Java. This is so awesome.
Right. And it's been crazy because it all started just as an idea of let me do 1 or 2 talks, like 1 or 2 hours, something, and now we have a full week, hours and hours on a day. Just
Insane.
today, like we're still on the like mid at the middle, midterm, we got half of the event, you know. We're just like past half of the sessions. We still have many more to come, and we already had 500 people coming across the lives. So the number of concurrent viewers does not really reflect all the impact that guys like you, rock stars and brilliant speakers like you have been bringing to the Java community worldwide. So thank you so much, Alina.
It's my honor. Hope to see you in Belgium again this year.
Yes, let's hope for that. I do think we will post a picture to our Java community here in Brazil.
We should. Thank you so much for having me, guys. And I hope I can make it to Brazil in person at some year. Let's hope it. I will try to make it happen.
1 minute before you leave, Elder, you are on the stage now, and I didn't even tell you. Let's make it happen. Let's create such an awesome event in Brazil that we can even get Alina to come over.
And you should take Alina to have a barbecue. Yeah.
Yes, Brazilian one with picanha.
Sounds amazing.
All right, thank you, girl.
Thank you so much for having me. Good luck, Elder. Good luck.
Okay,
amazing session, Alina. Thank you.
Elder, would you like to do your session in Portuguese or English?
You said that we have more Brazilians, so we can.
Yes, some days we do have many people watching in English, but I think that because of the list of the lineup, we have today, many of them are in Brazil, maybe, or outside, but they're Portuguese speakers. So guys, just let us know on the chat if you have any preference. If you are not able to speak Portuguese, we will immediately switch to English or just do the presentation in English. But if you're fine with Portuguese, we can switch now. I'm switching, Elder, to Português. E aí, Elder, bem-vindo.
E agora o YouTube tá dublando os vídeos novos no idioma da pessoa que tá assistindo. Então, outro dia mesmo, eu tava vendo o YouTube, por acaso eu tava numa janela anônima e um vídeo meu apareceu dublado em inglês. Eu falei, olha só que maravilha.
Now people are asking for you to do it in English.
Yeah.
So we have a decision. Thank you for the comments there, guys. Elder, you're gonna talk about Java concurrency, but why should people stay around to hear what you gotta say?
Because even though you didn't notice yet, you are using a lot of concurrency on daily basis if you are using Java. So let's talk about it.
Yeah, because and people, like the people who are watching us now, I have not told the speakers that I was gonna ask this question, so they are actually having to think like on the go why you should stay. This is not pre-planned. This is not prepared to answer. You know, so one thing that is also important to say out there is that many people are depending on vibe coding and just using AI to generate code, and when they don't really understand problems like concurrency, when they go to production, they will see the pain it is when you actually have a real problem on this topic, right?
Yeah, and they won't have any idea where the problem is coming from. So that's the problem when we are building stuff that you don't know how it works. So this not this only this session, but the whole material that I created for this session today is made to be a kind of reference for you guys to go deeper on concurrency if you want. So I hope to give you some insights about it.
All righty. So you can share the screen now. Feel free to do so. While you are sharing, I'm going to ask some questions. Some people cannot multi-thread, but I think you will be able to. So while you are sharing there, would you mind sharing with us what was your first Java version? Because Isidro said that his was Java 1. I was so impressed.
My first Java version was...
Yeah, even like when you first touched Java in your life.
Java 1.3 or 1.2 maybe.
See, guys.
Because
See,
I was still in the college, so yeah.
these people saw all the improvements in this language over the years. So now, without further ado, Elder, the stage is yours. Do you have two screens? Can you follow the comments? Just asking,
No,
because I can also bring
no,
them.
but I opened the session on my iPad, so I'm following the chat.
Okay.
Here, so
If
don't worry
anything passes through, I can also bring it on. Can you
Okay.
put on presenter mode, or do you? Okay.
Yeah. Yes. Okay, let's go. Awesome. And yes, Alina, everyone is invited to the barbecue. Brazilian barbecue, the best one in the world. Okay, guys, so thank you very much for the invitation and for Karina and all the organizers, and especially you that is watching. Can be now, live session, or afterwards if you are watching the recording. Thank you for your time. And I hope that you are willing to learn a little bit about Java concurrency. And my main point to create this session is because, as I told you a few minutes ago, we all, Java developers, we use a lot of Java concurrency, but under the hood. So we are just relying on Java concurrency, and sometimes we don't even know about it. So, but when we go to some kind of projects that I will mention for you in the session, you need to know not a little bit about it, but a lot about it. So that's why I created this one here. So a little bit of our agenda. So we'll learn about the importance of concurrency in modern applications, some basic concepts of concurrency, the evolution of concurrency in Java throughout the years, how we are doing modern Java concurrency in these days, some best practice and design patterns, and the most important part, the real-world applications and use cases. So how you will use this stuff on the practical way. And then we'll touch some conclusion, future trends, and Q&A time. Okay, so if you don't know me, my name is Isidro Moraes. I'm the Java champion. I'm a developer advocate here at Red Hat. I published a few books, and I've been doing some sessions around the world. And also, I'm a mentor at Confraria Dev and Mentoria Quantum's, two mentorship programs that I host. And if you would like to follow me some social media, here's my YouTube channel, and Instagram is where I'm mostly active in these days. Okay, so let's go to some general overview. First, the importance of concurrency in modern application, because concurrency is not just a nice to have feature, it's a necessity these days. Because first, performance. When we are using concurrent programming, we can make our applications make a better usage of multi-core processor, for example. And also by doing that, we can improve the performance and the responsiveness of our applications. Also regarding the resource utilization, because when we touch the concurrency features, we can enable our systems to better use the resources like CPU, like RAM memory, like network connections. I will talk a little bit more about it on the virtual threads, because the main reason why we created the virtual threads was because the underutilization of hardware, especially. So let's put it to in a little bit. Also for scalability, because as our user bases grow, our data amount of data also grow. We can use concurrent application to have better scalability. Of course, if we handle it properly, and also to increase and to improve the user experience, because we can increase the responsiveness of our application. We can improve the way that we consume the tasks on the background and so on. Okay, let's see the chat. Okay, all right. Oh, one missing. And also for real-time systems, when we are dealing with financial trading, gaming platforms, sometimes whatever we need the real-time processing, that's the way we gonna manage it with concurrency. And also these days we are doing a lot of AI and big data and those stuff when we are processing all those large data sets and running complex algorithms. Also the concurrency programming will help us a lot to do parallel executions. Okay, so some basic concepts so we understand better this whole concurrency stuff. We have the process. A process is an independent program running on its own memory space. Okay, so each process has its own resources like memory, like file handles, like security context, CPUs, and so on. We have the thread, and thread, it's our main feature, our main resource, our main stuff that we use as Java developers to deal with concurrency. So everything that we do as Java developers for concurrency, it's something around the threads. So the threads are so important for us. So it's a lightweight unit of execution within a process. Okay, so it's all the resources that are inside the process are shared by the threads. And some key points here, you can do concurrent execution inside a single thread between and among your threads. And the threads also, as I said, they share memory, which will make easier to communication between them, but also can introduce some potential synchronization issues. And the JVM is responsible to make all the management of the thread execution, scheduling, and so far. And so on, not so far. Also, another aspect of concurrency is the synchronization, is the coordinating of the execution between threads, so we can ensure that they don't interfere the shared resources that they are touching. Also, thread safety. It's when we have a class or a method that is thread safe, we can assure that they will behave correctly, especially when we have multiple threads running simultaneously. And we have some mechanisms to deal with synchronization. We have, of course, the synchronized keyword. We have some lock objects, locks in the interface that we use a lot when we are dealing with concurrency. So we have a reinstance lock, we have a read lock, and if you ever tried the virtual threads, before Java 24, we have a potential issue with virtual threads that was pinning, that we'll explain a little bit more in a few minutes. But one of the ways to work around the pinning is by using lock objects. And also we have the atomic classes like atomic integer, atomic reference, and so on. So those are mechanisms to deal with synchronization. And also we have the volatile keyword, so we can, whatever changes that we do in some objects, we can spread them across the other threads that are accessing those objects. So a little bit of evolution on concurrency in Java. So since Java 1.0, we have threads, some kind of threads, some kind of concurrency. So from Java 1 to Java 1.4, we have the basic thread class and synchronized keyword. On Java 5, we had the introduction of the package concurrent. On Java 7, we have the launching of the fork join framework. On Java 8, we had the completable feature and parallel streams. On Java 9 and ongoing, we had the refinements in addition to all those concurrent APIs. On Java 21, we had the launching of virtual threads. And on Java 24, it's missing here the slides, but on Java 24, we have the fifth preview of structured concurrency that is related to virtual threads, and I will talk about it in a bit. Some milestones. So on Java 5, we have some game changing for concurrency because we had the introduction of the executor framework that is responsible for managing the thread pools. We had the concurrency collections like concurrent hash map, copy on write array list, and we had the atomic variables, so we can have lock-free thread safe programming. Some new synchronizers like countdown latch and cyclic key barrier that I will talk about it in a bit. On Java 7 in 2011, we have the launching of fork join framework that it's an implementation of a algorithm called divide and conquer, so we can use it to do parallel processing. We had the introduction also of transfer queue that is made to implementation of a producer-consumer scenarios. On Java 8 2004, 11 years ago, we had the incompletable feature, so we can use it to make composing asynchronous operations, and also the parallel streams, so we can use it parallel processing to, especially when we are dealing with a big amount of data. In Java 9 2017, we have the reactive streams, so we can use it to, of course, do non-blocking operations for asynchronous stream processing. Java 21, 2022, virtual threads. The first version of virtual threads came in on Java 19, so it's the first preview, then 20 second preview, and 21 the final release. And Java 24, as I told you, we are in the last preview of structured concurrency. It's a way to organize the execution of virtual threads, and I will show you how in the next slides. Okay, so exploring a little bit of modern Java concurrency, we have two main guys here to look to. So we had executors and we have the thread pools. And basically the executor is a framework where you can separate, you can split the task execution and the task submission. So we have two separate ways to deal with this, both the two parts of thread execution. So executor servers will manage the thread lifecycle. Okay, so the starting and the management and the stopping and all the exception handling and so on. And we have some different kind of thread pools, and this one is really important because I saw a lot of Java codes that people just use one kind of thread pool without think about it. So it's important to know the difference of each kind of thread pool so you can have your best option, your best way to select the one that we will use. So first one, we have the fixed thread pool. Of course, as the name suggests, it's a way to have a fixed number of threads. So your threads will be always fixed one. And you send your tasks to some kind of queue, and they will stay on the queue where the thread pool is busy. Okay, so if we don't have enough threads in the pool available, so your task will be waiting for one thread to be available. And this one, it's used in, we recommend to use this kind of thread when we have predictable workload and especially limited resources. Okay, so it doesn't make any sense to have a lot of threads available if you don't have this same amount of thread available in your host. The second one is the cached thread pool. As the opposite, it's the way that you can have threads as needed. Okay, so you can, when you can preview the amount of threads that you need when your application's on runtime. So that's the way to deal with. This one is indicated when you have more fluctuating behavior of your application. But of course, you need to have enough resources to host this fluctuation of threads, and especially when you have short-lived tasks. Okay, so those tasks that will start up, do some stuff, and then will shut down, especially when they are dealing with serverless, when functions, lambdas, and so on. And this one has some potential risk that you can have excessive thread creation if you don't manage the behavior of your application. The third one is the scheduled thread pool. It's just like the fixed, but you can schedule it. Okay, you can have some kind of way to have some kind of schedule to create more threads or shut down your threads. Okay, so the only difference from the fixed is that you can schedule the creation. And the last one is the single threaded. On the single threaded, guys, you have just one worker and all the tasks will be in a queue waiting for the time to be executed. So this one is recommended when you have a specific order of execution of your threads. Okay, so basically the only recommendation for this kind of thread pool is this one. Okay, so we have a specific order of execution. So whatever kind of thread pool that you use, the main benefits here is you can reuse threads so you can reduce the overhead, and you can of course improve the performance and the resource management of your application. So here we have a simple code of this case a fixed thread pool with 4 threads. So we have the 4 threads always being executed here. We have also the concurrent collections. So they are collections designed to be thread safe. So it's not that you will only using threads in whatever part of your application and doing all the stuff concurrently. So if you are dealing with collections, you should use the proper collections for each case. So for example, we have the concurrent hash map. So if you are using hash map, if you are using maps, and you have a highly concurrent application, have concurrent code, scalable application, you should be using this collection. The other one is copy on write array list. So it's basically an array list, so made to be thread safe. So if you are using for really heavy scenarios, you should be using this one. And the concurrent and linked queue. So it's a queue that is non-blocking. Okay, so if you are dealing also with this one, you should be using this. The benefits of using the concurrent collections, of course, you have better performance if you are using a multi-threaded environment. So they are made for doing that. And by the way, I don't know if anyone here was on my talk on TDC last Friday. One of parts of my code should be using concurrent hash map, and I completely forgot. And when I was sit down, one of the Quarkus committers, George, was sit down on my side, and he said, "Hey man, you should be using concurrent hash map here." Yeah, you should. And once I changed it, the code was much more faster. The execution of my application was much more faster because I was dealing with concurrent execution. Reduce the need for external synchronization. So I don't need to worry too much on synchronization stuff because it's handled by the collections. Okay, so I can focus on my code, I can focus on my business code, and let the collection to deal with the thread safe part. And here I have an implementation using the concurrent hash map. It's a very simple hash map, string, integer here to put and so on. But for example, if I would like to do some kind of computation inside the mapping, I have some methods made to handle it. Also, I have the synchronizers. They are utility classes to help us to coordinate the actions of multiple threads. So the main classes, we have the countdown latch. It's in a class made to allows us to have one or more threads that they will set. I will show the code. It will be easier to see. For example, this one. I have 3 threads being executed here, and when I do this await, all the 3 threads will be waiting for everyone to finish, so we have the execution made by them. This one is very likely to a structure concurrency, but with slightly changes that I will show you in a bit. I have also the cyclic barrier, where I can create some kind of barrier point and make all the threads to reach that barrier so that we can execute all them together. All those classes are made to help us to organize the execution of threads. That's the main point of them. Okay. And the semaphore, imagine that you have, for example, a database and you have, for example, 20 connection pools opening for that database, but your application have 1,000 users trying to reach your database, for example. So the semaphore will help you to control the access, so you don't have a lot of timeout, a lot of waiting. The semaphore can handle this traffic for you. It's very helpful, especially when you have a lot of concurrent access to some kind of limited resources. Let me get a sip of water. All right, so we have 30 people here. Guys, the fork join framework. This one is very interesting. It's a framework that will help you to really use multiple processors, okay? Because it's not just that we are instantiating some kind of threads, we are accessing the threads, that we are really using the processor for our host. So the fork join framework help us to really do it. Especially when you have some kind of work, some kind of tasks that you can break into smaller pieces. The goal here is to help you to improve the usage of your resources by using this framework. So it's basically an implementation of executor servers. It uses an algorithm called work stealing. Okay, so it's how it works on providing the resources so your application can be executed. And it's on top of the worker threads. So it's managing the worker threads so it can have better orchestration of all the execution of your threads. We have 2 main classes here that make usage of the executor service. There is recursive task and a recursive action. The main difference between them is that the recursive tasks return some kind of result and the recursive action doesn't return. Okay, so of course there are some other slightly difference, but the main one are those. And this framework is really helpful if you have some kind of problem that you can split and can break it down into smaller pieces, and it will make automatic balancing between the threads that are on the pool on that time.
Okay. There's a question on the chat about work stealing pool. If you want to take a look.
What about work stealing pool? Sub kind of fork join pool. I will check I don't know the name, but I didn't see this one. Okay, I will check and let you know. Okay, and by the way, in the end of the session, you will be able to download this material, so you will receive on your email, and if you download, I can check the answers.
Yeah, you just commented something like the class, the code, the method.
Yeah, just saw here on the chat.
Mm-hmm.
Okay, so here we have an example of the fork join execution. Sip of water. completable future. This one is very known, maybe from the last few years of Java programming. Maybe this one is one of the most used by Java developers, especially doing some kind of async execution, async code. So a lot of people are using completable future these days. So here the key features, of course, the first one is the ability to chain in the asynchronous operations. So we have a lot of asynchronous operation happening in the same code, so we can make them happen on a chain of execution. We can combine a lot of different asynchronous computations and having the exception handling for asynchronous tasks. For me, this one is the best one because the most difficult part is having the exception handling when we are doing synchronous tasks. And compared with others asynchronous frameworks and APIs, this one is a lot of simpler. I don't say that it's simple, really simple, but it's simpler than other options that you have in the industry. And we can have the composition done by easier way. And here, of course, another example of completable future. And here's the composition. So we can have then apply, then apply, then apply, then apply. So each one of those asynchronous execution can be done in a more readable way. Parallel streams. So we can have execution, a parallel execution of streams operations. This method, the parallel, to create a parallel string. Under the hood, we have the fork join framework happening under the hood of parallel streams, especially when you have large data sets or some kind of heavy computation. The parallel streams is very helpful, so because it can make a better usage of our CPUs, so we can have parallel execution, as the name suggests. Easy way to parallelize operations, and we can have a significant improvement of the execution and performance because we have a better usage of CPU especially. And here, another example. Of course, this is not a huge data set, but it's an example. So this is how we do parallel computation using parallel streams. Okay, so it's not so much different code. We have just a different method here to help us to do that. Virtual threads, this one maybe is one of the topics most talked and most spoken about in the last 2 years, maybe, in the Java industry. The story is interesting because when you, as a Java developer, when you touch the new threads API, it didn't change a lot, but it took 5 years to not change a lot, of course, quoting, because a lot of changes were made under the hood, okay? So basically, here in the virtual threads, all the threads are managed by the JVM and not the operation system. Just for context, when you do thread dot some stuff on your Java code, you are accessing the real thread on your operating system, not only on JVM. So that's why it's so expensive to use threads on JVM before virtual threads. At the point that the threads are a kind of resources. So you have memory, you have disk, you have network connections, and you have threads, because it's a limited resource. When we are switching to virtual threads, the thread is not a resource anymore. Now it's a business object. So we can make a really better use of threads by using virtual threads. Okay, you can have a high number of concurrent tasks with a very low overhead, exactly because you are not accessing directly the operating system threads anymore. You are just relying on the JVM. And by the way, the JVM is handling all those virtual threads by creating potentially a single thread that they called a carrier thread. Carrier thread. So this carrier thread will manage the execution of all your virtual threads. So 1,000, millions, I don't know how much, but they are all being executed by one single thread. That's the carrier thread. Of course, the carrier thread is limited. Once you reach the limit of the carrier thread, you just allocate the other one. So we have 2 threads and not a lot of threads like before. And it's designed to simplify the concrete programming because through the course of years, our coding, especially our concrete coding, became to be complex and complex and complex, because all those async synchronization and parallel streams and completable future and so on. So the virtual threads help you to create a simple Java code, like a blocking code, and it will handle the block execution for you. So it's very, very interesting the way that they created the virtual threads. So you can increase the throughput of your application, especially if it is a I/O bound application, and of course, as I just said, a way to simplify the programming for concrete application, because you don't need reactive anymore, you don't need completable future anymore. You just write plain Java code and you have it done. A key difference, so much lower footprint, is, of course, this is just kind of comparison, but 1 kbytes versus 1 megabyte compared to platform threads, so it's very, very light. You can support millions of virtual threads in one single JVM, in one single carrier thread, as I just told you. And all the blocking operations, all the yield are handled automatically by the JVM, so it will improve the efficiency. Of course, some considerations may require resyncing some patterns. I read an article from Brian Getz from Oracle, where he wrote to properly use virtual threads, there is more to unlearn than to learn to be done. So you need to unlearn a lot of stuff that you've been doing with threads around through the course of stories. So as I told you, a lot of things that you learn to deal with threads, maybe you need to just ditch and use your simple Java code that will be better and will be easier to use virtual threads. And of course, it's not a silver bullet, okay? As anything in the industry, is not a silver bullet. So here we have a simple example. So we have thread.start virtual thread. So whatever I have inside this block, it will be executed as a virtual thread. And here I have an example of something that is preview, okay? So it can change because structured concurrency is not ready to this day. So here I have an example here. So basically, the structured concurrency happens inside an scope. So we have here an scope. I created this scope, and I will create subtasks inside this scope. So subtask 1, this is subtask 2, is wrong, okay? I will fix after. Subtask 1, subtask 2, and etc. So whatever subtasks I can put here, in the end, I declare the join, I declare the throw if failed. What these 2 lines of code will do for us? This one, they will make all the subtasks really happen, be executed on parallel, let's say. And if one of them fail, everyone fail. Okay, so they will guarantee that all the threads happens in the same time, being executed. And once they are done, then we are here in the end. So we have the result of 1 and result of 2. Okay, so that's a way, because imagine that we have a specific order, as I told you, in the single thread pool, but I don't need to have a queue anymore. So I have a single order, but everyone happens and be executed in the same time. So it's very interesting. Let's see when it's done the structure concurrency. Some best practice and design patterns. So we have some thread safe techniques that we should look at and try to implement as much as possible when we are trying to create thread safe code. So try as much as possible to use immutable objects because they are inherently thread safe, so they cannot be changed after creation, of course, because they are immutable. Use encapsulation as much as possible. Carefully do it. Okay, so try to encapsulate the thread state, try to synchronize it if possible. And a strategy that I didn't heard before studying for this session, they call it the defensive copying, is a way that you create a copy of your object, especially if this object will be shared among a lot of threads. So you guarantee that you have a defensive copy of this object that can potentially be changed by other threads. Okay, you guarantee that you have the safe state of this object. This one is interesting. Try to use atomic operations as much as possible, like atomic classes and or especially for fine-grained synchronization. If you would like to create a thread confined variables, use thread local. For avoiding common pitfalls, so common mistakes, because of course, when we are using concurrent code, concurrent execution, we can introduce some potential issues. So to avoid deadlocks, a deadlock occurs when you have 2 or more threads that are blocked and they are waiting for the resource of each other. Prevent that by using the correct acquisition ordering, timeouts, and avoiding nested locks. It's difficult, yeah, but we need to be careful when we are writing this kind of code. Race conditions, it's when a correctness of computation depends of a timing of execution between multiple threads. So use proper synchronization, atomic operation, and try to avoid as much as possible to share the state between the threads. And here, avoid share the mutable state. So that's why you need to try to use immutable states as much as possible. Some performance considerations, because of course the concrete is made to improve the performance, but if you commit some kind of mistakes, you can decrease the performance. So take a very careful look to the thread pool sizing. So study the different thread pools and use the proper, and especially if you are using the cache thread pool, try to estimate the right size of your caching. The granularity of the tasks, so don't make it then over granular or the opposite. So find a good balance between the overhead of when creating them. The contention management is when you try to handle multiple threads to compete to a shared resource. So it can lead to some kind of bottlenecks, so you will decrease the performance. So take care about it. When you are doing synchronous processing, so use the asynchronous APIs, the APIs that are done to do it, so like completable future, so you are not creating your own blocking code without knowing. And of course, you make a good use of profile and monitoring. And this one is even improved by the virtual threads, because when we are using the plain reactive APIs and like completable future or so on, we are not relying that much on threads anymore. So we lose a lot of observability. And when we are doing virtual threads, for example, we have a lot of more potential ways to profile and monitor our applications. And as I told you in the beginning, the purpose of creating this application is that we know how to use concurrency coding, especially professionally on our applications, on our projects, on the companies that we work for. So I brought here some real-world applications that if you are doing that kind of project, you need to know a lot of concurrent, so it will benefit from this session, this content like this. So for example, if you are working with web servers or creating microservice, because you are dealing with high concurrent, asynchronous, and IO-bound applications, here you use a lot of executor, completable future, and potentially virtual threads as well. And because of this point here, I believe, so it's my belief in this case, that a lot of web servers in the future will use virtual threads because it will provide a simple way to create what they are creating very well so far. Financial training platforms, because they require low latency, high throughput processing for market data. A lot of data came from these applications. You can leverage concurrent data structures and lock-free algorithms by using this kind of applications. When you are doing big data and string processing, you can use parallel processing, especially when dealing with datasets in frameworks like Apache Spark, for example. Here, you will lose a lot of parallel streams. If you are doing games and simulations, you can use a lot of concurrent simulation of multiple entities, physics, rendering. You can use here thread pools, task-based parallelism, and so on. If you are doing mobile and embedded systems, concurrency is essential, especially for responsiveness of the interface and resource management. Here you use a lot of event-driven and asynchronous programming models. Some performance improvements that you can achieve by using concurrency. If you are doing web server performance, you can, for example, switch from thread per request model. When you are using the operating system threads, like the former thread in Java, you are using this model, thread per request. It's when your request will use the whole thread for the whole time of execution of that thread. If you are using, for example, virtual threads, you can switch and you can get a performance increase for these cases. You can use, for example, completable future to use non-blocking I/O bounding in your and reduce the latency of your application in web servers. If you are doing data processing pipelines, you can parallelize the data transformation aggregation by using parallel streams. You can use fork join framework to use the divide and conquer algorithm. If you are doing reactive microservice, you can use the reactive, of course, programming model, but you can as well use Dmytro. That is an API made to make simpler to run to write reactive code, especially here in Quarkus. Dmytro is the API of reactive execution in Quarkus. If you are doing real-time analytics, you can use concurrent processing to big data streams. This one is used on Apache Kafka and Flink, for example, when we are building real-time analytics applications. And of course, you can make use of Java concurrent collections like I showed you a few minutes ago. Guys, going to the end of this session, we talk about the package, Java concurrent package, these features such as executors, concurrent collections, and synchronizers. We also talked about the fork join framework and its use for parallel computation. We talked also about the completable future, asynchronous programming that it enables. We talked also about the parallel streams and virtual threads and all the changes that it made to the usage of threads in Java. Also, we talk about the best practice in some design patterns, so we can write thread-safe code. And also about some real-world examples where you can use the concurrency coding in Java in these days. And talk a little bit about the future and what we can see in the trends around the Java concurrency. Of course, the continuing evolution of virtual threads, some refinements and stabilization, and potential broader adoption. So we can see the industry started to use virtual threads in the new versions of some platforms and applications. And the final version of structured concurrency that is deeply related to virtual threads. And in Java in general itself, we can see some improvement performance and scalability through the research and optimization of JVM concurrency internals, and some better ways to use the newer processor architectures. What else? Tooling, improving profiling, monitoring tools for concurrent application. It's a challenge, but we have better options these days, especially with virtual threads. And also the integration of concurrent best practice for frameworks and libraries. And if you would like to access this material here, I will let this QR code and the link so you can get the slides. And let's switch to the questions. I don't know if Karina is here.
Of course I am. It's just because you were such in a flow that I didn't even dare to interrupt you. But I do see a question here on the chat. Let me pull it up.
I see one from Leonardo Segala. In the servlet GSP app, does not good idea uses thread inside the request. True, yeah. Especially because in this case, the application server is handling the thread for you. So, and it's like you should not touch something that the other person is handling. So, leave the web server to handle it for you. And then the second question from Leonardo, microservice era, is a good idea to use virtual threads inside the request? I will give the architect answer, depends. Yeah, because
I think that everybody who passes through this stage has to say it depends on at least once.
Yeah. Especially when you can, the way of look to virtual threads is when you can isolate a task, really isolate a task. So if you have a task that is really isolated and is not interfering in other tasks, yes, you can use it. Okay, so depending of your business case, on the demo that I did on TDC last Friday, I used a lot of virtual threads with microservice because I was able to isolate the task from each other. So that's the case. If they are not interfering on the resource of each other, yes, you can use, but you need to be careful to not mess up, basically.
Awesome. Okay, if there are no further questions, Elder, do you want to just mention what is going on the confraria, maybe even in Portuguese for those who are around, because there are many people who are reaching out to me in different contexts, and they do mention the Confraria Dev, which is, I think, your initiative. So I think, and it has been helping so many people. The things these guys are doing are helping other people. So you are helping them help others. So if you just want to share some words on this.
Ok, so we'll switch to Portuguese. Pessoal, eu tenho, basicamente são dois programas, né? Um é a Confraria Dev, que ela é focada.
Do you want to put it on the screen? Is there any page or link? Because then I can put it here. If you want to open on the browser.
Yep. Deixa eu abrir aqui.
Oh, mudar aqui para português, eu esqueci completamente. Aí dá um tilt na cabeça. Tem reunião que eu entro. Thanks everybody for attending Elder session. By the way, coming soon we will have our next guest. I'm reaching out to him to see if he's already ready to jump in. So in the meanwhile, let's just hear about this great initiative from Elder in Portuguese, all right? Here, where is that? Okay, perfect.
Então, a confraria é um programa feito, como eu falei, para desenvolvedores entre nível pleno e sênior, tá? E a ideia ali é ajudar você a dar o próximo passo na sua carreira, né? Então, e eu foco bastante ali na galera que é back-end Java, que é a minha praia, então é onde eu consigo realmente ajudar mais eles, do ponto de vista técnico e também comportamental, tá? Então a gente trabalha ali, tem mentoria uma vez por mês, tem um monte de módulo, a gente teve mentoria com Uncle Bob esse ano, enfim, tem bastante coisa legal acontecendo lá. E a partir de nível sênior e acima, então tem um overlappingzinho ali, né, do nível sênior, mas também nível acima, tem a outra mentoria que é a Quantum, que eu tô até com a camiseta dela hoje aqui, acho que não dá para ver ali, que aí é a partir do nível sênior e acima, mesmo tem a galera staff, tem a galera principal, tudo lá, que é para trabalhar aquelas coisas além do técnico, né? Então vai trabalhar liderança, vai trabalhar influência, vai trabalhar influência não do ponto de vista de influencer, como a gente está acostumado a ver, mas a sua influência realmente no seu projeto, no mercado, na empresa que você está. Então, tem esses dois programas. A confraria não está com inscrição aberta no momento, tá? Mas tem lista de espera. Então você pode entrar aqui na lista de espera, é confrariadev.cdv. Vou pôr aqui no chat interno para a Karina colocar lá no...
Com certeza.
E é isso, pessoal. Então, fica aí. Obrigado, Karina, pelo espaço.
Claro, deu tudo certo aqui. E eu que agradeço pelo conhecimento super avançado. A gente não vê esse tipo de conteúdo por aí assim tão fácil, não, Helder. Obrigado por continuar ensinando a galera aí sobre esse tipo de tema que só quem tá lá mesmo na sala de guerra que a gente chama, né, é que tem que se preocupar com isso. Então, valeu, velho, pelo conteúdo, viu?
Obrigado pelo espaço. Thank you everyone for being here, and thank you, Karina, again for the space, and see you next time.
See you, bye. Now, Bené, can you tell me on the private chat here if you want to have your session in Portuguese or English? I don't recall. So, guys, our next speaker is already here on the backstage, and we are going to switch to Portuguese because we need also to share some knowledge in Portuguese. But you don't have to worry because, as I mentioned before, every session is going to be properly translated. All the subtitles are going to be available afterwards for those who are watching in English and want to follow up on the Portuguese content. And same, e a mesma coisa vale para quem assiste que fala português e vai querer ver as palestras em inglês. Todo o conteúdo vai ser polido. So with this, let me switch to Portuguese. And remember to keep an eye in our Celebration Week agenda. Here's the link, because that is where you can get the most up-to-date information on the sessions that are coming through. And we have a lot of exciting stuff still coming today, tomorrow, and the day after. All right, so let me switch here now. Galera, vamos falar em português. Tá? Começou até a travar aqui, olha que coisa. Não sei por quê. Mas, seguinte, gente, agora a gente vai ouvir sobre observabilidade com uma pessoa que todo mundo ama no Brasil. Ele acabou de chegar do TDC e eu tô super ansiosa. Não sei se foi a mesma talk que ele deu no TDC. Caso tenha sido, tô super ansiosa para ver, porque eu não tava em Floripa. Rafa, Bené, bem-vindo.
E aí? Tudo bem?
Finalmente encontramos. A gente teve aquele incidente do outro dia. Cara, gente, eu nem contei para vocês. Eu tive que cancelar uma talk por causa de um problema que aconteceu, alguém tentando pegar meu cachorro. Eu tava super, sabe, fora de mim, assim, não tava legal naquele dia. Mas finalmente a gente se encontra de novo, Bené, no online stage, né?
Eu que diga. E até dando um contexto aqui para a galera. Obviamente, eu poderia fazer a talk em inglês, mas eu tenho um propósito pessoal que desde que eu voltei dos Estados Unidos, meu propósito é trazer conteúdo em português para a galera daqui, né? Lógico que existem grandes profissionais, mas o consumo na nossa língua mãe ela é muito mais fácil. E por isso eu faço essa opção. Como, obviamente, vai
Não,
ser
tem muitas
traduzido se eu
pessoas que,
falei
às vezes, elas são avançadas também, já são sênior, mas elas ainda não tiveram, às vezes, não está no momento na vida em que elas conseguiram parar para estudar inglês ou se preparar, ou então não consegue parar para assistir lendo a legenda, né? Então a gente precisa de mais pessoas como você, trazendo conteúdo super avançado, de qualidade, para essa galera também. Porque, assim, observabilidade não é tema de júnior, né?
Não, mas é algo assim que é bom já os júniors saberem que existe.
Exatamente. Para saber,
Então,
pelo menos, caramba, eu lembro isso que o Bené falou que tinha a ver com observabilidade. Vou olhar, né?
não, principalmente hoje, como todos sabem, eu trabalho como arquiteto, atendendo vários projetos na Red Hat. E uma das coisas que eu mais vejo o pessoal desejando é como que eu faço a correlação entre aquela mensagenzinha de log que apareceu no meu microserviço A mas o erro pipocou lá no meu microserviço C.
Não é nem isso. O microserviço já é um nightmare para você saber o que está acontecendo. Se você tem que rastrear um problema, como é que você vai saber aonde foi? É uma loucura. Ainda mais quando você começa a escalar essa quantidade de serviços independentes, cada um ali feito do seu jeito, na sua linguagem, com o que você faz, velho? É uma loucura em produção, né? É isso aí que você vai ajudar a galera hoje, então?
Exatamente, esse é meu assunto. Como fazer observabilidade focado mais em Quarkus, porque a gente tem aqui 45 minutos, a gente não vai conseguir pincelar todas as linguagens e frameworks, Spring Boot, por exemplo, mas já vou adiantar aqui, já vou fazer um spoiler.
Faça.
Na demo tem Spring Boot. Tem Node? Tem. Então nós estamos falando de Java com Quarkus, com o Spring Boot, integrando com outra linguagem, que poderia ser Node, poderia ser Go, mas a ideia é mostrar que rastreabilidade está além da linguagem. Ela é um paradigma
é uma prática mesmo, ela tem que ser uma coisa que a gente tem que usar, né? De qualquer forma, né? E aí, a sua talk, ela vai ser usando qual tecnologia? Só por curiosidade.
OpenTelemetry.
Pronto, olha só que legal, cara. Não, perfeito. Vai ser para habilitar mesmo as aplicações Java para que sejam observáveis, então. Quero mais o quê? O Jorge Tanquetave, eu chamo ele Tanquetave, falou aqui no chat que ele vai fazer uma talk de observabilidade semana que vem, só que no contexto de DevOps. E aí, George, se você quiser deixar aí aonde que vai ser também, para quem curtiu o assunto, já deixa aí, já faz o jabá. Bené, se você quiser ir compartilhando a tela.
Vamos lá, vamos para compartilhar a tela.
Perfeito.
E eu vou compartilhar só a minha janela e vamos fazer o seguinte. Eu sei que você não gosta daquele efeito que faz assim. Então, peraí, vamos fazer outra coisa aqui. Pronto, tá aí.
Oxe, eu não tenho nada de gostar ou não gostar, não. Eu tô vendo o demo time, viu? Aí, ó. Já descobrimos que hoje tem
demo. E aí, como é que tá saindo a tela?
Que hoje tem demo, tá tudo perfeito. Então você tá só com o monitor, né? Você não vai conseguir acompanhar as perguntas, né?
Não vou. Eu só vi rapidamente que o Segala deu um oi, vi a mensagem do George.
Tranquilo.
Espero que sim fazer vários insights.
Não, e aí se tiver perguntas eu vou trazendo quando tiver uma brechinha, tá?
Show, você vai me pingando.
Certeza.
Bom, uma prática que eu tenho já há vários anos é já deixar os slides para a galera que quiser seguir. Então, por exemplo, se você vê alguma coisa legal nos slides, não preocupa. Os slides estão disponíveis aqui nesse link. bit.ly/opentracing Quarkus. Tá? Facinho. Mas eu recomendo você não abrir agora não, tá? Vai seguindo aqui junto comigo para a gente ir construindo esse conhecimento em conjunto. E já fazendo um jabazinho aqui também, abram o Instagram, no Rafa Bené Dev, já clica lá em seguir. Eu não estou postando na última semana como eu gostaria, porque como a Karina falou, foi uma semana atípica, foi TDC essa semana com o evento, semana já é mais curta por causa do feriado, mas em breve eu volto a colocar uma quantidade de conteúdo relacionados a desenvolvimento, especialmente Java com Quarkus, para a gente ir crescendo esse conhecimento junto, tá bom? Bom, pergunta interessante aqui, até voltada para quem gosta de cinema, né? Mas você sabe o que o seu microserviço fez ontem à noite? A pergunta é interessante.
Eu tô com medo, eu tenho medo. Eu acho que eu não sei, não sei se eu gostaria de saber. Talvez seja essa a resposta.
Aquelas respostas assim, não sei, não quero saber e tenho raiva de quem sabe. Mas vamos lá. Já foi feita a introdução aqui, já falei do Instagram. Vamos passar para a parte onde a gente viu o mundo mudando. Né, a gente falou até mais cedo de DevOps, eu vi lá o George falando da observabilidade né, com foco em DevOps, mas o fato é que dentro do desenvolvimento do processo, lá nos primórdios, a gente tinha um modelo em cascata, depois falou muito em Agile ali nos meados dos anos 2000, início do ano 2000, prevaleceu até 2010, e hoje é consolidado as práticas de DevOps como processo de desenvolvimento. Na parte de arquitetura, também teve modernização. Né? Acabamos de falar aqui de microserviços. Né? A gente começou com monolítico, depois a gente resolveu dividir isso em 2 camadas, 3 camadas, N camadas, e agora vamos dividir isso até em nós físicos separados, fazendo invocações remotas com microserviços. E para suportar isso, o processo de deploy também mudou, de deploy e de empacotamento. A gente tinha os servidores físicos, depois a gente começou a falar muito de VMs, vamos virtualizar, vamos pegar um hardware grande, vamos colocar lá várias VMs, e hoje em dia a gente já fala de containers, unidades bem menores, onde a gente coloca os nossos microserviços lá e faz todo o processo de implantar isso em produção com um time de developers e um time de infraestrutura, que é o DevOps, que eu acabei de falar. E a infraestrutura também precisou acompanhar essa modernização. A gente, antigamente, alocava um data center, em algumas situações existiam infraestrutura on-premise, e hoje a grande maioria, não é o default, eu não diria assim que é o caminho mais, como eu falaria, o caminho que todo mundo deveria seguir, cada caso é um caso, mas o default acaba sendo você hospedar na nuvem para evitar um custo inicial de ter uma infraestrutura própria, né, financiar máquinas e etc. Mas o fato é que microserviços hoje, como a gente havia falado, já virou uma espécie de commodity. Quando eu comecei a falar de microserviços, a gente via, a gente estava aqui vivendo uma curva após o pico das expectativas. Toda tecnologia, ela segue esse ciclo. A gente está vendo isso agora com inteligência artificial. Tá todo mundo no pico das expectativas. Vai acabar com a fome do mundo, vai acabar com os desenvolvedores, etc. Até que vem, né, a tecnologia passa pelo vale da desilusão, você vê que não é tudo aquilo que as pessoas falavam que ia fazer, né, aprende com os erros e fala, cara, mas é uma tecnologia massa, vamos usar ela. E microserviço passou pelo pico das expectativas, passou pelo vale da desilusão, e agora ela está subindo na ladeira do encantamento, que é onde a gente sabe o que faz, o que não faz, como faz, erros e acertos, e principalmente, agora que temos vários microserviços, né, como que nós vamos ver o que está acontecendo com esses microserviços. Porque quando era lá na época dos monolitos, era um tempo onde tudo rodava, né, no monolito, era lento, mas era previsível. Tinha só uma única caixinha, que os erros só poderiam estar ali, todos os problemas estavam ali, o deploy só era uma única peça, um banco de dados só, e estava tudo bem. Mesmo que eu dividisse em N camadas, era um deploy único, era um monolito. Só que aí, ao longo dos anos, a gente pegou esses monolitos, que obviamente lá dentro dele é composto de módulos, né? Nós temos o módulo de comercial, o módulo de estoque, o módulo financeiro, o módulo de segurança, o módulo de BI, de Business Intelligence, e assim por diante. E a gente pegou todos esses módulos e começou a separar ele em microserviços. Porque veio o hype do microservice, onde a promessa, como eu falei lá no pico das expectativas, era de autonomia, escalabilidade, times independentes, o que é uma verdade para microserviços, tá? E aí a gente pegou esses microserviços, tirou eles dos microserviços de dentro de um monolito, né? Quebrou até mesmo um módulo grande em partes menores e começamos a espalhar esses microserviços em deploys independentes. Obviamente, o software ele não funciona sozinho. Eu preciso ter uma interação entre os microserviços para eles funcionarem. E para que eles possam ser realmente independentes um do outro, cada microserviço tem que possuir o seu banco de dados. Pelo amor de Deus, gente, não construa microserviços todos pendurados num banco de dados porque alguém falou que você iria ter uma integridade relacional. Quando a gente vai para o mundo de microserviços, a gente fala de integridade de consistência eventual, tá? A gente fala de consistência eventual em termos de não duplicar dados, etc. Mas o fato é, para que os microserviços sejam independentes um do outro, a gente precisa ter bancos de dados independentes um do outro. Mas não é só isso. Além dos microserviços possuírem bancos de dados independentes, eles têm múltiplos pontos de entrada. Eu posso ter requisições que veio do front-end, eu posso ter requisições que vieram de um API Gateway, que veio de um Postman, né, que algum desenvolvedor está testando lá em produção, por favor, não façam isso. Pode vir de um aplicativo mobile, pode vir de outros sistemas, mas é uma realidade. Outra realidade do microserviço é que cada bolinha dessa que vocês estão vendo aqui, cada microserviço que vocês estão vendo, precisa de um pipeline que pega o código-fonte, testa, empacota e faz a implantação em produção. Tá? Aqui eu não consegui representar todos, mas a gente sabe que cada microserviço precisa do seu pipeline independente. São projetos independentes um do outro. Ou seja, no mundo antigo, a gente tinha, né, o seu monolito rodando, né, com o seu banco de dados, e hoje, nesse novo mundo, a gente vê microserviços com seus bancos de dados rodando em containers em cima de uma orquestração, seja ela o Kubernetes ou o OpenShift. Tá? E aí está tudo bem. Lógico que no mundo de DevOps a gente não espera que isso aconteça, que o desenvolvedor lance o seu pacote por cima do muro da confusão para o time de operações, principalmente se isso for uma sexta-feira, 5 horas da tarde. Né? A gente espera que ambos trabalhem em conjunto. Quando a gente fala de DevOps, isso aqui não existe. O que está tudo bem é que enquanto o servidor estiver executando e funcionando, ninguém vai reclamar. Ninguém vai reclamar se existem silos, ninguém vai reclamar se as práticas do DevOps estão sendo ou não sendo seguidas, ninguém vai reclamar de nada enquanto o servidor está funcionando. Agora, se o servidor sai fora do ar, o cliente tenta acessar, principalmente se for cliente externo, porque aí está envolvida a imagem da empresa. O cliente tenta acessar e a aplicação está fora do ar, é aquele zoom, zoom, zoom no corredor, é aquele WhatsApp que não para, telefone, ligação, é literalmente o fim do mundo. E pode acontecer situações inversas não, mas situações onde o servidor está ok, né? A gente olha lá na tela de monitoramento, tá tudo verdinho, mas essa tela aqui foi um timeout. A latência explodiu. A aplicação está no ar, mas ninguém consegue acessar mais nada. Parece que tudo travou. Né? E, por favor, também não venham com aquela solução mágica. É só reiniciar o servidor. Isso é... A gente, né, nós estamos em 2025, por favor, não façam mais isso. Nós temos que ter aplicações com self-healing, né, com mecanismos que previnam essas falhas. Né? Reiniciar o servidor não é uma solução, é um paliativo, ok? Então, como eu disse, parece o fim do mundo quando a aplicação sai fora do ar, todo mundo gritando, zum, zum, zum no corredor, o WhatsApp não para. E o porquê que acontece isso? Mesmo estando, né, nos sistemas de monitoramento, tudo verde. Acontece isso porque nós distribuímos o código, mas a gente não distribuiu o controle. Como assim, Rafael? Cada bolinha daquela, cada serviço virou uma caixa preta. E olha só, eu amo esse Twitter aqui, que eu tenho print dele, foi tirado em 2015, né? Nós trocamos nosso monolito por microserviços, assim, cada vez que a aplicação está fora do ar, parece mais como um mistério de assassinato. E é bem isso que nós vamos fazer hoje, tá? Quem está nos assistindo aqui, eu tenho uma aplicação que ela faz uso de microserviços, mas ela está falhando. E nós vamos utilizar observabilidade para descobrir o que é que está falhando. E vamos aprender nesse processo como usar a observabilidade para que nós, nas nossas aplicações, a gente saiba fazer os mesmos diagnósticos. Bem legal, né? Bom, vamos lá. Numa situação dessa, quando a latência explode, quando acontece algum tipo de problema, surgem várias perguntas. A primeira dela é, qual que é a ordem de invocação, né, dos meus N microserviços? Imagina que você tem uma estrela da morte como essa. Qual que está sendo a latência de cada serviço para a gente descobrir se é um ou vários que estão deixando a minha aplicação lenta? E qual desses microserviços, desses 1 milhão de microserviços aqui que nós temos, que causou esse erro, que está causando essa lentidão? Isso seria possível de responder se em cada requisição a gente pudesse carregar a nossa própria trilha de invocação como se fosse um GPS. Então imagina aqui naquele desenho que eu fiz, se a gente pudesse analisar qual que é o caminho crítico de invocação do meu caso de uso. Qual que é a latência a chamada entre um microserviço e outro, né, e o seu tempo de resposta? E se houver uma falha, por que falhou? Quando a gente tem só o monitoramento, a gente não consegue ver esses detalhes. É só a ponta do iceberg. A gente precisa ir para baixo do iceberg e ver coisas que a gente não consegue ver com monitoramento. A gente precisa ir para o que é chamado de observabilidade. Observabilidade, ela é composta de 3 pilares. A gente sempre vai escutar isso. Toda reunião que eu participo, a gente fala assim, olha, lembrando que observabilidade são 3 pilares. Estamos falando de qual? É bem isso.
Oxe, mas quem é que fala isso aí? É o vovozinho? Quem tá falando?
Tô imitando algumas pessoas que falam assim na reunião, né? Vou usar essa voz mais vezes durante a apresentação.
Usa,
tá?
Muito boa.
Então, a pessoa fala... E é muito comum, a gente fala de observabilidade, e a pessoa, mas você está falando de quê? Aí, não, eu estou falando só de métricas. E aí a pessoa vem, mas cadê o log? Cadê o tracing? Então, é só para você, viu, Karina?
Galera que curtiu a vozinha do Bené, comenta aí no jardim. Hashtag vozinha do Bené, né?
Hashtag. Nossa, vai ser legal. Mas o fato é, e é até interessante a gente ver que aqui do lado tem o que tem baixo volume e alto volume de informação. E quando a gente tem métricas, as métricas, elas, até mesmo que a gente consuma ela frequentemente, né? Eu posso ficar ali, me dá as métricas aí do consumo agora de memória. Elas tendem a não mudar muito, né? Depois mas as métricas, elas são dados agregáveis. Depois a gente tem o trace, que ela tem um request do escopo do meu caso de uso, é aquela por onde passou aquela requisição, e a gente tem os eventos de log, que é bem aquele log que a gente faz mesmo no Log4j, no Java Util Logging, né, no seu framework de log preferido, que é aquilo que você cospe na console do seu container. Bom, sabendo que quando eu tenho esses 3 pilares, eu consigo ter muita informação da minha aplicação. E aí, eu falei, a Karina perguntou aqui, que nós vamos falar de quais tecnologias? Eu falei, nós vamos falar do OpenTelemetry. O que é o OpenTelemetry? Primeiro, ele é uma especificação. Assim como a gente tem especificações em Java, dentro da CNCF, que é a Cloud Native Computing Foundation, existe uma especificação voltada para a telemetria, para a observabilidade, que ela traz as informações de métrica, de logs e de trace. O que mais que ela fornece, essa especificação? Ela fornece APIs sem relação nenhuma com nenhuma plataforma, fornecedor. Tanto que essa demo que eu utilizei aqui, ela já usou no passado o Zipkin. Aí eu fui modernizando ela, passei a usar o Jagger. Depois fui modernizando, passei para um produto chamado Grafana LGTM, que é o lock, grafana, tempo, e eu esqueci o que é o M, tá? E inicialmente essa demo ela era só baseada em tracing. Porque antigamente, antes do OpenTelemetry, só existia o OpenTracing. Né? O OpenCensus eu não conheci, mas o OpenTelemetry virou um merge desses dois projetos. E ele traz o que nessa especificação? Ela traz a especificação do protocolo de comunicação. Por isso que a gente consegue utilizar linguagens diferentes, porque o protocolo é especificado. E existe uma convenção semântica, né, para que as informações coletadas sigam um padrão. Existem APIs para gerar dados. Por isso que uma vez eu atendendo essa API, falando no protocolo certo, usando a convenção semântica, independente da linguagem, eu vou ter a observabilidade da minha aplicação. Existem bibliotecas para eu implementar a instrumentação no meu código-fonte, e são N bibliotecas. Eu tenho biblioteca para Java, eu tenho biblioteca para Go, eu tenho biblioteca para Node, né? Para JavaScript de forma geral, se eu quiser implementar Trace no meu front-end. Eu tenho bibliotecas para Python, eu tenho bibliotecas para N linguagens, e existe um coletor do OpenTelemetry. Então, como que o OpenTelemetry funciona? Eu vou lá, pego o meu código, pego o SDK do OpenTelemetry, instrumento o meu código, e ele vai, dentro da minha aplicação, olha aqui o contexto, ela vai começar a exportar dados. Esses dados vão ir através do coletor, que o coletor ele possui um receptor e um exportador. Mas por enquanto ele só faz... A única coisa é coletar métricas. Quando ele recebe as métricas que veio da sua aplicação, ele coleta e exporta para um back-end de telemetria. Estando nesse banco de dados de telemetria, eu posso consultar os logs da minha aplicação. Eu posso consultar as métricas da minha aplicação e posso consultar os traces, né? Inclusive, já fazendo um disclaimer aqui, quando eu estava falando de métricas, inclusive essa pergunta surgiu lá no TDC, a pessoa perguntou assim, tá, mas qual a relação disso com o Spring Boot Actuator? O Spring Boot Actuator, ele expõe as métricas, né, num endpoint, se for lá, /métricas, você vai ver todas as métricas, que já é no formato do Prometheus, só que o Prometheus ele tem que ficar fazendo scrapping. A gente tem que configurar um Prometheus para... Vai lá nesse IP e faz o scrapping nesse endpoint. Vai lá, passou X segundos, vai lá e pega de novo as métricas. Eu posso até fazer isso de forma dinâmica, colocando... Vai lá no Kubernetes e todos os pods que tiverem esse label, coleta as métricas. Não é uma alternativa. Mas o processo é sempre a ferramenta de métricas puxando as métricas da aplicação. No OpenTelemetry, eu inverto isso e eu começo a ter a minha aplicação mandando os dados para o coletor e o coletor mandando para o banco de dados. E não é só métricas, é tudo de observabilidade. Métricas, tracing e logging, tá? Então, vamos voltar ao nosso problema aqui. Nós estamos lá com a aplicação fora do ar. E agora a gente vai ver essa aplicação aqui funcionando, tá bom? Por favor, me fale se ainda conseguem ver minha tela. Consegue, estou vendo aqui no... essa aplicação aqui, se eu for lá no /serial /Rafael e tentar acessar, ela me dá um erro. Olha o tempo de resposta aqui, é 2 segundos mais ou menos. Né, fez a bolinha ali. Vou fazer mais uma invocação. E ela não me deu erro. Ela está dando aqui internal server error. E um error ID, né? Que a cada requisição ela incrementa aqui, ó, /6, /7, né? E não me diz muita coisa. O que nós vamos fazer? Lembra de eu falar da stack LGTM? Tem um lock, grafana, tempo e Métricas. Acho que é Métricas o M, tá? Eu vou começar a diagnosticar a minha aplicação usando apenas observabilidade. E para isso, o nosso primeiro passo é métricas. Métricas é como verificar os sinais vitais do paciente. Você consegue até ver a febre, mas não sabe a causa. Tá? E antes da gente olhar as métricas na nossa ferramenta, a gente precisa entender que existem 4 tipos de métricas. Existem métricas que são contadores, né? Quantidade de invocação, custo da minha requisição, né? 1 centavo por requisição. Então, se foram feitos 4 requisições, o contador está lá em 4 centavos, que é o custo total da minha operação. Eu tenho um GOLD, né, que é tipo, são métricas que aumentam e diminuem ao longo do tempo. Né, o contador só incrementa. Mas se você tem métricas, por exemplo, consumo de memória, espaço em disco, se você tem necessidade de dados estatísticos, como percentil, né, tempo de request, né, que o tempo de request variou ao longo do tempo, e você quer saber se né, o percentil, o 0,90, 0,95, você pode usar o histograma. E tem métricas que são sumário. Isso tudo está descrito aqui na parte na especificação do OpenTelemetry, né? Então tem métricas de contador, vamos aumentar aqui métricas que são contadores assíncronos, contadores para baixo para cima, o GOLD, né? Que mede o valor corrente na hora que leu, o GOLD assíncrono e o histograma. Então, vou voltar a nossa... Focando no Quarkus. Se eu quiser... Bom, antes de focar no Quarkus, vamos fazer o seguinte. Vamos ver as métricas da nossa aplicação. Eu vou explorar aqui as métricas, tá? Eu quero vir aqui no Prometheus e eu quero ver algumas métricas minhas. Aqui, a minha aplicação já está configurada para exportar as métricas para o coletor e o coletor já está configurado para exportar as métricas aqui para o banco de dados. Lembra que são vários, né? No caso aqui, o Prometheus, que é o que cuida das métricas. Então, eu tenho as métricas aqui de quantas invocações o meu microserviço A fez para o meu microserviço B. Posso executar as métricas e, né, quando eu comecei a minha aplicação, tinha feito 2 requisições de teste. Depois eu fiz mais algumas, né? Mais 6 requisições. E ela está marcada aqui para mim. Olha, eu tenho 7 requisições total feitas desde que você subiu a aplicação. Né? Qual que é o nome do serviço? Aqui é o MyService. E ele ainda está marcando aqui, ó, do microserviço A. E eu tenho uma... E essa invocação teve uma exception chamado NoStack3. Foi uma invocação com erro, né? Uma invocação, quer dizer, uma invocação com sucesso e 7 invocações com exception. Beleza, tá com exception, eu já sei. Basta eu olhar essa tela aqui, né? Obviamente, eu poderia mostrar a minha console aqui com log, mas nós não vamos fazer isso, tá bom? Eu só preciso agora, né? Nós vamos ver log no segundo pilar. O que nós precisamos ver? O microserviço A é implementado com Quarkus. Como que eu fiz no Quarkus para ele expor essas métricas? Muito simples. O Quarkus, ele usa o micrometer, ou micrometer, para expor as métricas. E aí, uma vez, é só eu ir lá no meu código e anotar o meu método. @counted. Ele vai, obviamente, fazer o quê? Contar quantas vezes o microserviço foi invocado. Se eu quiser usar uma anotação @timed, quanto tempo levou a invocação? Beleza, eu só defino aqui o nome da minha métrica e ela vai ser cuspida lá para o para minha stack de monitoramento, de observabilidade. Eu só precisei colocar no meu .xml essa dependência aqui, Quarkus Micrometer OpenTelemetry. Por quê? Ele vai pegar essas métricas do micrometer e vai exportar elas para OpenTelemetria. Como? Nós vamos ver isso. Outra coisa que a gente pode fazer são métricas customizadas, como nesse caso eu fiz aqui. Eu quero ver uma métrica de custo de invocação em dólar, né? Eu tenho aqui o meu bucket, né? O meu count, né? Quanto que custou? Eu coloquei 1 centavo, né, $1 por invocação, fiz 8 invocações totais. Aqui ele conta com erro e sem erro, tá? E aí, o meu custo hoje, né, o somatório, está em $8. Por que eu fui aqui no Explore? Aqui em métricas, eu consigo ver todas essas métricas, mas é em requisições por segundo, tá? Então, eu posso pegar aqui os últimos 5 minutos e ver como eu fiquei mais tempo parado explicando, o meu custo por segundo, por requisição, caiu. Né? Aqui eu consigo explorar a minha métrica seca. Né? Então, vamos pegar aqui de novo. A minha métrica está em 8... acho que é 10 centavos que eu coloquei. 0,80 centavos, né? Então, eu posso criar minha métrica customizada, eu injeto um objeto meter, e aí o meu medidor, eu crio um counter builder, um gauge builder, dependendo da métrica que eu quero criar, dou um nome, uma descrição, a unidade, construo ela e vou adicionando valores nessa métrica. Se é um contador, adiciono valor, né? Se é um gauge, eu seto o valor. E aí ela vai ser exportada. Aí eu vou lá na minha aplicação Quarkus, vou lá no application.properties e só falo o seguinte, olha, dentro do OpenTelemetry, na parte de métricas, eu quero habilitar, enable true. Eu quero exportar usando o protocolo OTLP. Eu poderia exportar aqui também para login. Ou seja, ele vai ao mesmo tempo, exporta para o coletor e manda a métrica para o meu log. Mas não tive necessidade de fazer isso. Em quanto tempo eu vou exportar minhas métricas? Ele vai, né? Você não fludar sua rede, você não inundar sua rede, você pode definir parâmetros de tempo de envio dessas métricas. O coletor agrega, né? A aplicação agrega e depois manda em batch para a aplicação. E onde está o meu coletor, né? O endereço dele. Essas métricas podem ser as métricas da aplicação, mas o Quarkus por si só pode exportar métricas da JVM, se eu habilitar, né, no micrômeter. E aí, lembrando que a minha aplicação faz uso dessa bridge entre do micrômeter com o OpenTelemetry, e ele pode exportar essas métricas também. Métricas do HTTP Server. Inclusive, deixa eu ver aqui se eu habilitei essas métricas. Né? Acho que sim, que a gente consegue ver aqui métricas do HTTP Server, métricas da JVM, né, para a gente ver qual o consumo de memória, etc. Aqui, memory allocated bytes total, né? E isso aqui em bytes, depois a gente tem que converter. Mas, enfim, é simples assim exportar as minhas métricas. Segundo passo, logs. É o prontuário detalhado. Você vê o que foi feito e quando. Para exportar logs é a mesma coisa. Vou lá no OpenTelemetry, logs enable, onde que está o meu agente e qual que é o protocolo. Vamos fazer isso. Vamos aqui na minha ferramenta. Vamos na parte de logs. Eu já consigo ver aqui o microserviço A e o microserviço B. Eu vi, não estou na aplicação, estou na minha stack, tá? Isso aqui foi coletado e está armazenado no banco de dados da minha stack. Eu consigo ver que tem 3 logs de erro no meu microserviço A e no meu microserviço B tem 18 erros. Já dá para dar uma pista aqui para a gente. Como eu estou vendo o meu sintoma aqui no meu microserviço A, eu posso pegar o meu microserviço A e ver aqui, ó, cada vez que eu invoquei, lembra que eu fiz 6 invocações? Uma funcionou, né? Isso aqui, as outras 6 falharam, por isso que está com tracinho 7. Então, eu consigo ver aqui os horários que elas foram feitas, 14h56 e 14h56, não, aqui, né, chamando o microserviço, né, erro ID, aqui, ó, 6, 7. Eu consigo ver, né, o meu log, e olha que interessante, se eu vier aqui mostrar os logs dessa aplicação, desde a hora que eu subi, eu consigo não só ver o que aconteceu, mas eu consigo abrir aqui e pegar detalhes. Olha lá, ó, o code namespace, Quarkus, Vertex, Quarkus Error Handler, né? Qual foi a exception? Exception é que aconteceu um timeout quando eu tentava invocar o microserviço B. Olha só, o timeout, depois de 1 segundo, ele falhou. Então, a gente já começa a entender o seguinte, poxa, o B, que é o causador, a minha falha está sendo um timeout. Lógico, por motivos didáticos, eu não tratei o erro aqui nessa tela. Mas no log eu já consegui ver que é um timeout, que ele tentou por 1 segundo, enquanto o microserviço B lá está falhando adoidado. Então, essa é a função da gente analisar os logs. Só que, como eu falei, o log é prontuário. Você vê quando foi feito, né, o que foi feito e quando, mas também não diz muitas coisas. Só que quando a gente vai para trace, que é o terceiro passo, a gente já tem a gravação da consulta. Você vê a jornada completa de atendimento. Voltando à pergunta, e se cada requisição carregasse a nossa própria trilha como um GPS? A gente conseguisse ver a requisição por onde ela passou. Aqui a gente precisa entender que o trace, um tracing, ele é composto, né, o trace é a requisição do início ao final. Só que dentro de uma arquitetura orientada a microserviço, a gente tem operações. O span é a operação, né? Cada operação que foi realizada, né? Então, dentro do span, a gente tem o nome da operação, o timestamp, o status, se foi ok ou erro para aquela operação, quais são os atributos, eventos, contexto, relação com outros traces, e se for um trace server ou client, producer ou consumer, server ou client, se for uma requisição HTTP, invocando outra, que é client, a que recebeu é uma server, ou se for assíncrono, como Kafka, se eu estou usando o Kafka como produtor ou como consumidor, se a minha aplicação produziu ou consumiu mensagem de um Kafka, por exemplo. Então, eu posso ter relacionamento entre os spans, posso ter atributo. Lembra das convenções semânticas? Existem convenções semânticas aqui para cada operação. Por exemplo, se for uma operação de banco de dados, eu falo aqui a convenção semântica é qual o nome do banco de dados, né? Qual que é o endereço e a porta, qual a operação que foi realizada, né? Isso são os atributos. São pares de chave-valor. Mas como pares de chave-valor, eu posso colocar eventos também na minha operação. Por exemplo, mensagens de log. Abrindo a conexão, não consegui conectar com MySQL. E eu posso propagar o meu tracing de uma operação para outra, mesmo que seja um microserviço rodando em máquinas distintas. Como que ele faz isso? Peraí, vamos pular aqui. Ele faz isso através de um cabeçalho que ele coloca na requisição. Então, por exemplo, qual que é o meu parent ID? O trace, né? O meu ID do meu trace. É XYZ. Beleza, então eu sei agora que essa operação é do trace XYZ. A outra operação é do pai ABC. A gente vai entender isso vendo isso funcionando. Depois eu volto aqui para falar. Por quê? Vamos voltar na nossa stack aqui de monitoramento. Eu vi aqui o log, que tem um timeout. Timeout me diz alguma coisa? Não me diz nada. Só que eu posso vir aqui, olha que legal, ver o trace dessa requisição. Olha que maluquice. Eu vou pegar essa requisição, abrir o trace dela, que tem um identificador, e aqui a gente está vendo todos os spans que contiveram que causaram aquele erro. Então tem o microserviço A, olha aqui as informações, os atributos, né? Seguindo aquela convenção semântica. Qual que é o IP, o nome da minha classe, né? O erro foi tipo 500, todas as informações da minha requisição. Qual que é o host name, né? E aí ela invocou essa minha aplicação aqui, ela recebeu o meu barra serial. Depois ela chamou um método dentro da minha aplicação, né? E a correlação é de dupla via. Assim como do log eu consigo chegar no trace, do trace eu consigo voltar para o log. Tá? Ele tem aqui, ó, logs para esse spam. Tem um evento aqui onde ele lançou uma exception, né? Aqui o status é erro, né? Eu consigo ver a exception aqui, que foi o meu timeout, né? Que a gente viu lá no log, que gravou na minha informação de log. E ele tentou fazer o quê? Ele tentou invocar o meu microserviço B. Né? Aqui, ó, tentou invocar o microserviço B nessa URL aqui e tomou uma exception. A exception já foi conexão fechada porque ele cedeu meu timeout. Vamos continuar aqui. Se a gente for descer na nossa aplicação B, que foi aquela que gerou 18 exceptions, a gente vai começar a ver que tem um erro aqui no banco de dados. Ó. Store in database. A gente vê pelo nome, né? Store in database. Né? Eu não mostrei o log do meu microserviço B, mas se eu quiser ver, eu posso ver aqui. Eu tenho uma exception. Qual que é a exception? Uma Spring Framework Transaction Exception. Vamos descer isso aqui. A gente pode descer na exception até a gente identificar a causa. Ou seja, qual que é a causa desse erro aqui? Unknown Host Exception, MySQL. Ele tentou comunicar com esse banco de dados. A gente consegue até ver aqui os atributos, né? E não... Vamos descer aqui. atributos, get connection. Ele tentou usar aqui a string de conexão, MySQL na porta 3306, banco de dados OpenTelemetry, e não conseguiu falhar porque o banco de dados estava fora do ar. Simples assim. Vamos subir aqui o meu banco de dados, vou subir ele aqui nos bastidores, tá? E agora a gente pode pegar aquela mesma aplicação que estava dando erro, executar, e a gente consegue ver que ela funcionou. Vamos ver agora o tracing para essa aplicação, né? Para a gente ver o que muda. Vamos ver aqui traces, né? Vamos atualizar aqui dos últimos 5 minutos. Ela não deve ter exportado ainda, né? O serviço. Tem aqui, 3. Microserviço A. Olha aqui a minha aplicação todinha funcionando. Agora não está mais vermelha. Eu consegui ver que o meu microserviço A invocou o microserviço B. O microserviço B chamou para armazenar no meu banco de dados. Eu consigo descer até a nível de ver qual foi a instrução de SQL que ele mandou para o banco de dados. Então, isso é bem legal, né? Fazer esse tipo de correlação. Como nós estamos no final do nosso horário, eu só quero falar aqui para vocês que o básico de usar a API do OpenTelemetry é instanciar um tracer, depende da linguagem, depende do framework, tá? Chamar o tracer.spamBuilder, start spam, ele cria o spam, você seta atributo, seta evento, na hora que você dá o end, ele fica pronto para ser coletado. Ok? Por fim, no Quarkus, é só você colocar essas definições no Application Properties. Quer métricas? Habilita. Quais tipos de métricas você quer gerar automaticamente? Logs, você quer? Habilita. Traces, você quer? Habilita. Para quem tiver curiosidade, estiver usando uma aplicação Quarkus e quiser instrumentá-la, se você for lá no site do Quarkus e buscar por OpenTelemetry, você vai ver uma série de guias para isso. Você vai ver o geral, usando OpenTelemetry, de forma geral. Vai ter o link para usar OpenTelemetry Métricas, OpenTelemetry Logging, OpenTelemetry Tracing. A demo está disponível, né? Se você quiser ver, como que faz isso utilizando Spring Boot, como faz isso utilizando outra, né, linguagem, a demo está no meu GitHub, Bené/Tracing Demo, e fica aqui, né, os links da apresentação e do meu Instagram. Karina, terminei em cima da hora e eu quero saber se teve perguntas, se a gente pode, se eu encerro, fico por aqui, ou a gente continua para responder perguntas.
Tem uma dúvida sim, dá uma olhadinha aqui no chat.
Vamos lá.
Tirei a sua telinha aqui para você conseguir ver. Uma do Denis.
Vamos lá, Denis. Onde posso ver como configurar o Prometheus para receber métricas via push do OpenTelemetry em vez do scrapping job? Bom, no meu caso, o que eu fiz? Quando eu trabalho em produção, eu trabalho já eu trabalho no OpenShift, dado a natureza do meu trabalho. O OpenShift, quando você sobe um operador de OpenTelemetry, ele já faz tudo acontecer para ti. No caso dessa demo, que não está no OpenShift, eu já subi o LGTM, que já está configurado para ter um agente coletor. Eu só falo só preciso falar qual é a porta. Uhum. No caso de um Prometheus que você foi lá e usou ele estanque, eu não sei te responder. Eu te dei o contexto do porquê que eu não sei responder. Mas acredito que você procurando por Prometheus with OpenTelemetry, você vai achar os guias para que te respondam essa pergunta.
Muito bom. Uma coisa que eu vejo assim é que também o pessoal, assim, é porque tem tantas formas de resolver observabilidade, né, Bené? Que às vezes o pessoal pode ficar confuso. Então, por exemplo, vamos falar, tem um istio. Como que juntam? Essas duas coisas, elas coexistem ou você escolhe um ou o outro? Por exemplo, se você colocar um sidecar ali para poder pegar as métricas, aí o pessoal vem falar de Dapper, aí cada um fala de uma coisa, né? Aí, aí qual que seria o próximo OpenTelemetry? Eu já vou dar logo a minha opinião, especificação.
Diga. Qual que é a sua?
Tem roots ali, tem raiz na especificação, né? Então, assim, algumas coisas elas vão ajudar a coletar e expor métricas para o Kubernetes. Outras coisas você precisa, é porque você tem que avaliar. Eu estou dando meu insight, aí você vai me dar o seu, né? Eu vou me dizer como que eu estou falando.
E a ideia é essa, a gente discutir e criar conhecimento.
Assim, eu sei que o cara do Java, ele tem que permitir que a aplicação dele exponha os dados. Igual você falou do Prometheus, que tem que ficar fazendo scraping e tal. E outras tem que conseguir coletar isso daí. Só que quando a gente entra no mundo da cloud, aí entra essa história de sidecar, que ele vai fazer alguma conexão entre o mundo interno e o de fora. Então, só dá esse insight assim, para a gente, como que funciona tudo junto.
Tá. A última vez que eu usei o Istio tem uns 2 anos. Então, talvez eu esteja desatualizado. Mas o Istio, quando você instalava ele já criava você habilitando a sua stack interna de monitoramento, que não era OpenTelemetry, falando de 2 anos atrás.
Exatamente.
E depois nunca mais mexi, tá?
Estamos na mesma. Fiquei 2 anos na IBM.
E aí, o que o OpenTelemetry fazia? Botava o sidecar do lado da aplicação, ela usava esse mecanismo que eu falei. Ela configurava o Prometheus para que todos os labels que tivessem, sei lá, monitoring, Quarkus, não lembro qual era o label, ela ia lá e fazia o scrapping. Era um mecanismo de scrapping, tá? Só que era como eu falei, era métricas próprias.
Então, se a gente não expõe o que a gente realmente quer ver, às vezes ele só pega as coisas genéricas da JVM, né?
Sim. Eu fiz há 2 anos atrás, eu usei para Trace também, porque até tem um projeto Kiali, né? Lembra do Kiali?
Conheço.
Né? Que é de observabilidade dentro do Service Mesh. Aí eu poderia pegar o tracing da minha aplicação e ela ia parar lá no Kiali. Mas tudo a gente está falando de parar dentro do Istio. Obviamente, como a especificação OpenTelemetry surgiu depois disso, hoje já deve o Istio já deve ter mecanismos de você plugar para exportar essas métricas para uma stack externa. Até porque dentro da especificação do OpenTelemetry você tem esse conceito de pipeline de observabilidade. Tá, eu coletei, mas mando para cá. Quando chegou aqui, eu mando para lá. Né? Eu, por exemplo, isso é muito usado quando você tem vários clusters. Eu tenho um cluster de desenvolvimento, tenho 2 clusters de produção, um para uma finalidade e outro. E eu tenho um cluster de observabilidade. Aí eu coleto tudo e centralizo no cluster de observabilidade. Fiz um projeto desse bem legal para um cliente. Então, eu acredito...
Então, peraí, então isso aí que você tá... É porque, assim, muitas vezes, quando vem alguém falar aqui de alguma tecnologia, a pessoa fala muito da ótica de quem está pitching alguma coisa para ver se a galera adota, né? Nesse caso, então, você, de fato, já implementou em clientes.
Já implementei. O cliente tinha essa situação, que ele tinha um cluster só para observabilidade, que ele queria ver o que estava acontecendo. Vários clusters de produção, no caso aqui eu citei 2, mas nesse cliente são vários. E era utilizado um pipeline de observabilidade que a aplicação mandava para o coletor do cluster, o cluster mandava para o coletor central e estava tudo resolvido. O que eu não sei, por não mexer com o Istio nos últimos 2 anos, é se o Istio tem o suporte ao OpenTelemetry e se tiver, é só usar esse mecanismo de pipeline para ele encaminhar para frente.
Pronto. Não, muito legal, velho. E assim, eu tenho participado do meetup aqui em Brasília, da galera do Sou Java Brasília.
Quero
e
ir.
Tem cliente, ó. Agora falando desse cliente, caramba, empresas. Eu procurando uma palavra. Tem empresas que estão sedentas por isso e não sabem nem por onde começar. Então, acho que a Sotalk foi uma ótima referência, especialmente por ser em português, porque os enterprise developers nem sempre já estão ready para o mundo do inglês ali, para as coisas avançadas ali, né?
O que eu mais vi o pessoal pedindo é essa correlação entre o log e o tracing. Sim. Essa é a mais pedida. Tipo assim, eu vejo o log, eu vejo lá a minha aplicação cuspindo um monte de erro, mas o erro está lá no microserviço B.
Aí fica difícil saber, porque, de fato, não, a gente que é do old school, ali do JBoss, a gente sabia ler, a gente tinha que fazer isso meio que manualmente, né, Bené? Era ler no log, achar a hora certinho, o timestamp e caçar o que é que tá acontecendo. De fato, isso daí ajuda demais, velho. O Leonardo comentou aqui que eles hoje estão usando a suíte da Elastic. No meu caso, estou usando o init container para configurar a exportação de métricas.
É o mesmo, é o Istio. O Istio fazia isso, né?
Eu nunca fui
mudou, porque agora estão falando
de
que não tem mais side container, né? Não tem mais sidecar, né? Mas tem tempo que eu não mexo.
Não tem mais sidecar?
Falaram que acho que o Istio versão 1.4 não tinha mais. Não sei como que é a mágica que ele faz.
Vou ter que dar uma olhada lá depois.
Talvez seja init container também, né?
Pô, mas Bené, deixa link, coloca aquele link da sua palestra aqui pra gente, que eu vou colocar aqui pra galera. E o link do seu Instagram também, que você pediu pro pessoal dar follow, né? Eu já vou pra galera.
No privado? Ó, coloquei aqui no privado.
Perfeito. Aqui, ó, galera, ó, o link da palestra do Benel. Cadê? Faz a vozinha pra gente só mais uma vez, aquela vozinha lá.
Agora que o rosto tá aparecendo aqui, eu fico...
Foi engraçado, velho. Oh, meu Deus. Não,
pra falar assim, ó, pessoal, segue aí no Instagram.
A vozinha do Bené, quando ele tá fazendo pergunta, é engraçado. Ó, galera, seguinte. Pô, Bené, muito obrigado, meu querido. Mandei
obrigado ao Soljava pelo convite. Obrigado você também.
Aqui, ó. Segue o Bené no Insta. Nosso palestrante favorito do Brasil. E aí, ó, Bené, continua trazendo conteúdo pra gente em português, porque facilita, né? Ouvir
facilita.
Assim.
É um propósito pessoal.
Te agradeço muito, viu, Bené?
Obrigado a vocês, gente. Tchau, tchau. Valeu,
tchau. Gente, agora a gente vai se preparar para mudar para o inglês de novo, que a gente vai receber 2 English speakers que vão falar sobre Vector Search. Então, a gente começou o dia... Deixa eu mudar para o inglês, né? Vou falar rapidinho aí eu mudo para o inglês. A gente começou o dia falando sobre LangChain e ferramentas para desenvolvedores fazerem RAG, que é Retrieval Augmented Generation. E aí agora a gente vai receber em alguns minutinhos os nossos speakers que são da Weaviate. A Weaviate é um banco de dados open source que é especializado para RAG, para fazer Retrieval Augmented Generation. E eu vi a palestra deles uma vez no TDC, foi ano passado no TDC, aqui em Brasília, e eu achei incrível, assim, o jeito que eles comunicam e como que é diferente o tipo do conhecimento de quem é especialista em banco. Então, na hora que o Deandrea estava apresentando para a gente hoje, ele apresentou da perspectiva do developer. Então, ele trouxe, por exemplo, aqui tem um embedding, eu não sei muito o que é, mas... e aí, assim, agora a gente vai receber a galera que sabe de fato como que as coisas funcionam lá dentro e podem ajudar a gente a otimizar a forma que a gente armazena esses dados lá no banco de dados. Então, agora eu vou mudar para o inglês, só para poder dar essa intro e a gente dar um breakzinho de 5 minutinhos no máximo, beleza? So, now we are switching back to English to say that we are about to receive our speakers that are going to bring to us information about vector search databases with Weaviate, but especially for Java developers. And they are specialists on the team. They will teach us not only from the developer perspective, but actually the most detailed information we can find on how things work under the covers and what we got to do in order to polish the data and maybe like store it and tag it, use some metadata and other things we will learn from them so that we can optimize our RAG applications. We already have Duda on the backstage, but we will wait till something like 5 minutes at max to get everything ready to go. Okay, so take a break, grab your coffee, but don't leave the stream. Just go grab the coffee and return because that's all the time we're gonna need. I will also grab my coffee. All right. So see you in a few minutes, guys. Let me get here by the way, if you're enjoying the event, just post on LinkedIn, like Celebration Week, invite people over and let them know we are having this amazing event throughout the week. Let me put this here so that we can take a quick break. Okay. Where is that? And guys, by the way, tomorrow is gonna be crazy too. We are gonna have the first panel of the event, but not just any panel. We are gonna have Barry Bird, Mike Redlich, and Bruno Souza reminiscing about the 30 years of Java. So it's going to be very cool because you're going to be able to drive the actual conversation. It's going to be open for discussion with you. You're going to bring the topics. Okay. All right, guys. So we'll be back in like 3 to 5 minutes max. Okay. See you in a few minutes. Let me put this here for a second. And we start again, guys. All right, so now we have everything ready to go for us to explore more in depth about the things that most Java developers can't really tell you as well as the guys who are going to talk right now. These are true specialists on the matter of vector database and how we can best leverage it in order to create our RAG solutions, the solutions based on RAG, how we can use documents and insert and save data in a way that we can retrieve it effectively. Here with me, I'm now going to bring you guys to the stage. I have Duda Nogueira and Dymo. How do I say your name, by the way?
That was very good. That was close, like very close. That's Dymo. Yeah.
But tell me in your native language, like how do people say it in your language?
Like if I tell it to my friend, I'd say Dymo.
Dymo. Okay, so Dymo. Nice to meet you, by the way. I'm glad that Duda brought you over because I'm super excited to hear from you guys directly here on our celebration week, more about how we can use Weaviate. Since I saw it back, I think it was last year, right, Duda? On TDC?
Yes. Yes, in Brasilia.
I got in love with the database, and I just want you to spread the word about this amazing solution for the Java community, especially now that you got a Java client. Okay, so now I'm going to share your screen, Duda, and the stage is yours.
Awesome. Thank you, everybody. It's a pleasure to be here on such a nice event with, all the cool presentations that we're having. I'm Duda Nogueira. I'm the community tech support here at Weaviate, and also have here my colleague and friend, Dmytro Solovei, which is, software engineer from the client libraries. And we are going to be talking here about Weaviate and what is a vector database and what you can do with that. So if you know nothing about vector database, you are exactly on the right place, because we are going to learn what is a vector database, what you can do, and what is all that about.
And just to add to that, that is not the only reason for them to be around and watch our talk, because actually during today's sessions, we had many experienced Java developers, really popular rock stars in the Java ecosystem. And during the presentations, we heard things such as, oh, and this is an embedding. I can't really go in depth on what it means or things like that. These were not the words, but they couldn't really distill the topic for us. So this is why, this is where we can really understand what all this stuff means. So thank you.
Yeah. So that's, you're in the right place if you want to learn more about it. And then I'm going to pass here to Dymo. That's going to also show you how to do that with Java. So Dymo, you can present yourself.
Yeah. Hi. So once again, Karina, thanks a lot for having me here. I'm Dymo. I work at Weaviate with the database core team. And at the moment, I'm responsible for rewriting our Java and Go clients, which we already have, but they could use some love, as a bit more love, as the saying goes.
We all need more love with Java clients on these databases that are so cool, like Weaviate.
All we need is love.
We just released a beta, like a preview version yesterday. So today I'm here to demo some short snippets from it, and hopefully get your feedback later and get you interested and excited for what's to come in the next months. Thank you.
Awesome. Okay, so without further ado, let's talk about Weaviate. So this is our agenda. So what is this about? What is the vector? What is a vector database? Where can you use it? Why should you use it? How you can run that? You can install it in Docker, Kubernetes, and all that, or you can use the cloud. We're going to talk about that, and then we're going to have a sneak peek and some demonstration for the new Java client. And also, here is an invitation to join our community. Right? We have our forums, we have our Slack, we have a bunch of weekly events, both online and in presence. So an invitation here so you can join our community. Okay, this is our GitHub, right? You can join there, Weaviate/Weaviate. The company calls Weaviate, and we have the main database called Weaviate. And one thing it is interesting for you to notice there is that we are, rock on open source. We are BSD clause 3, which means that, it's the most open source as open source can be. I used to say that Weaviate is as ours as it is yours, right? So it's open source, it is for you, and we develop it. Everything is open, so it's very nice. And that leads us to one of our graphics, that all your vectors embeddings belong to you, because we believe that you should own your data, not only now your data itself, but also the embeddings.
By the way, we
because
can
that's
even
very
see
important.
that we can also see how cool open source companies are. Having worked at Red Hat for almost 8 years, like a few years ago, this is the type of stuff that developers actually enjoy. So I love the humor in the graphics.
Yeah, we have a lot of very cool graphics in our YouTube and our. I believe the best stickers. We also have some very, very cool stickers. So stay tuned, because there's if you join, for example, our LinkedIn, if you follow there, we have constantly materials, blog posts about what's happening. So it is very interesting to join there. Okay, so this is our website, okay, Weaviate.io. If you join there is a special one that you're going to like, which is the developers. And then there in the developers tab, you have, the documentation, some agents documentation, learning center, a blog, academy, events, showcases, a lot of stuff there bundled for you to learn. Last year we were on the AI 50 or the world best AI startups. So it's growing fast. It's being used by a lot of companies. So it's very cool technology. Okay. So basically is that Weaviate is an open source vector search database. And then, as you know, it's everything used to, usually can start with a search, right? So search is very important for a bunch of things that we do in a day-to-day basis, right? So to make it, I'll try to now to grow on the topic about similarity search, semantic search, and embeddings and all that. And I like to do that in a way that has been worked very well in other talks. So, for example, let's consider these 4 sentences, right? A dog can bark loud. The lion is the king of the jungle. A giraffe is the tallest land mammal, and cats can climb trees, right? Let's say that we only have those 4 objects in our database, right? If we go to the traditional search, let's say that you have those objects in your database, you're developing the Java application, and then someone says, hey, I would like to have a very good system for searching our content, right? Can you develop that? And then usually what you're going to be doing is like select asterisk from, the table, and where, let's say that you want to search now for domestic animals, right? You know what's going to happen here, right? Because in the traditional search, we're going to basically do the textual search, right? So if we do that, and also this is not a search, by the way, this is just a filter. This is a beautiful filter. And then you can make it more, you can break by spaces, and you can go that route that's not going to lead too far away. So this is not search, this is a filter. And if you run that against the data set we have, zero results found successfully, because you're going to find nothing. Because if we get back there, we don't have domestic animals in our content, right? You only have like the word dog can bark loud. So if we search for dog, then we can find the dog, right? But again, that's not the search that you want to do, right? It works, but it does not work at the same time, if you understand what I say. So now enters a little bit of the magic that we can work with the vectors and the similarity search, right? And then this magic we bring to you is not magic, it's technology, technologia. And then we can do some really cool search with Weaviate, right? So this is a Python just to explain, but basically now we have our collection, we have our data, and we are basically doing a search, right? And if you see like, oh, Duda didn't even translate the query, it's in Portuguese, right? But no. This is the cool part, because I was searching for animais domésticos, which is domestic animals in Portuguese, right? But I can search for domestic animals too, even though the content is in English. I can even search for these, which is in Chinese. Not sure how to say that, because all of that, now we are not searching about the content, about the text, the actual word dog or cat or lion or jungle. We are searching on semantics, right? So basically, just by only with that, you can already have a multilingual multi-language search, right? You have the content in English, someone searches in Portuguese or in Chinese, you've got that covered already. Okay, so let's say, for example, that we did the search, and now we query in Chinese, and then we get the objects, and then you can see a very important thing there, that is distance. I got this from an old, this now it's in Portuguese, it didn't translate, but you get the distance there, which is, distancia. And then now you get even, I search for domestic animals, but we can see that the dog and the cat are the second ones, right? And now the lion and the giraffe one, they are the third and the fourth. So now, even though we are searching for domestic animals, we get all the objects. However, we have the distance. And this is the one that's saying like, hey, technology. So this is the one that is saying like, hey, the dog and the cat, they are closer to the query of domestic animals, or whatever is that in Chinese, than the lion and the giraffe, right? So this is semantic search. We never search for domestic animals itself. We did search for domestic animals, but we do not have domestic animals into the object. However, dogs are close to the domestic animals, right? As well as cats. But lion and giraffe, they are far away from the domestic animals. So this is, in a nutshell, what you can do with vectors. And it seems like a magic or technology, but it is a lot of mathematics going on. We are not going too deep into the mathematics. That's a rabbit hole. If you want to do that, we have our research team. We have people researching algorithms, discussing algorithms that love this part. I don't understand that to that level. It is very complex, but as you can see here, we have the abstraction layer, so you can do whatever you need to do and use all the technology for that. So as you can see now, semantic search is like way cooler and can deliver very well good results for that, right? Okay, so let's go. Do you want to say something, Karina?
I'm just here appreciating the memes. But this is the answer this is the question I want the answer for. What is a vector?
What is a vector? Yeah, okay, because we go like, oh, it's a vector database, and a lot of people talk about the AI stuff, but it doesn't go too much into the vector. And it's really interesting to understand what is a vector, so we can understand what is possible and what is not possible, right? So when we are talking about the vector, we are indeed talking about that vector that some people probably saw from the school, right? That's the physics, the mathematics vector that is representing, a direction, that's the vector, right? And the cool part is that if we just say the number 36, for example, we could say, but this is not, right? If a mathematician sees that, they go like, no, this is not a single dimension vector, right? It is just a number. So this is not a vector. This is a scalar, right? It's a number alone and, means nothing. However, if we change now the 36 and you say like, hey, this is a 36 degrees Celsius, right? Now we can see that that's about temperature, right? So the number alone, it's not a lot of stuff, but with 36 degrees Celsius, now we have a meaning to that number, right? So that's not a vector. Again, this is just a scalar, right? So now if we go a little bit further, and now we have a two-dimension vector, right? So now we have two numbers, and probably you see that number and say like, hey, I have seen this before. And you're right, this is a geographic coordinates, right? So now it is interesting because you can understand the different, what about the distance, right? The meaning of distance now for vectors, it is easier to understand, right? You have a location here and you have a location there, and you have a third location. Now you can compare those locations. Which one is closer to the other one, right? So this is a two-dimension vector in reality, in the day-to-days. And it is interesting that we have a contract, or in this case, we can make a connection to a model, which inside that model or that contract, which is, latitude and longitude, this number makes sense. Outside of that contract or outside of that model, those numbers, does not have a lot of usage, right? And the same goes now to the three-dimension vector. Now, this is probably everybody knows about it. So you have the, RGB, which are the ways that we can use the numbers to represent the color, right? So you have the first number, you go from 0 to 255. and then the third and the first, the second, and the third. And each number that you change that number, you get a new color, right? So if you go 25500, you have red. 02550, you get green. 00255 blue, because red, green, and blue. And then when you mix those numbers, you get emerald, which is a brand new color. So this is now a way that you can say, like, okay, so now we have a 3 vector dimensions, and it all started making sense, because as you can see, we can embed, and that's where the term comes from. We can embed meaning into the numbers, right? You can, from those numbers, they can mean something inside a contract, inside a model that we understand together, we agree on. So those 3 dimensions in the RGB vector, they have a meaning into that stuff, right? So we use those numbers to bring some meaning to the to represent that meaning, right? And now if we get, for example, if we plot those 3 numbers, right, and X, Y, and Z, then there's not all the colors here, but you have some colors here. Now you can see, and maybe you can ask yourself, like, hey, what is closer? Maybe this yellow here is closer to this other yellow, or this orange is closer to that yellow. So now you can see the distance calculation. It's got more complicated with 3 dimensions, because with 2 dimensions, you have like a geo coordinate. But then here you can start thinking that, hey, there are some distances between vectors, right? And then we can calculate those distances, and we've been able to calculate that for a long time already, like 400 years already. We have different techniques, algorithms to calculate those distances, right? The main used one is the cosine distance. Then you have the square Euclidean, you have dot product, you have Manhattan. All of them are going to give you a distance from those vectors, right? So this is a vector, and this is how you can understand the distance from the objects, right? In reality, this is a vector, okay? So this is a vector that I got, from the OpenAI text embedding. So this is a 1,536 dimensions, right? So which means that we can apply the cosine distance. Let's say we have 3 objects. We can apply the cosine distance and calculate the distance between those vectors, okay? So where do we use that, and why is that important into the AI and application? How can I use that as a tool in my day-to-day activities, right? So let's say, for example, now that you have a vector space, right, and you have a bunch of objects there. Let's say that you have an article that talks about Apple, the company, and then you have another article that talks about Apple, the fruit, right? If you do a traditional search and you search for Apple alone, right, or like I want to eat an apple, right? You can get both the results, and they are going to be the same because you're doing a textual search, right? Now, if you search about, hey, I want to learn the financial report for the Apple, right? So then the Apple, whatever is related to the Apple, the company, is going to be closer to the query, right? Because we are not talking about the apple, the fruit. So now with the vector search, you don't search anymore for text, but you search for meaning. You do the semantic search, right? It does not matter the word anymore. The word dog does not have the word, but it embeds the meaning of the dog, of the canine, right? So which is very, very interesting. And this is just like the supermarket, that when you go to the supermarket and then you go to the fruits and you expect the vegetables to be close to the fruits, right? You don't expect the magazines to be close to the fruits. As well as the seafood, the meat, everything should be close together to what makes sense. So for example, back to our example, let's say that a dog can bark loud. So how does that work, right? So whenever we ingest this into a vector database, you need to specify which model we're going to vectorize that data, which means that, and Weaviate does all that for you, right? You configure Weaviate. So whenever you ingest the data, that data is going to get some vectors, right? So as soon as you ingested those objects, it's going to pass through Weaviate. It's going to contact the vectorization service, and then we are going to get a vector for that object, as well for each of the objects. So now each object is going to have their own vectors, right? And this vector composes a vector space, right? A vector index where we can do search. Now comes in the query, right? Just like the query I did domestic animals, we're going to go to the same process. We're going to vectorize the domestic animals. We're going to get a vector, and then we're going to position that vector into our vector space, right? And when we do that, we're going to find entries about dogs or about cats or about, rabbits or whatever domestic, closer to domestic animals they are. So this is how the vector search is done, right? And this, let's say that if you have only 4 objects, in my case, you probably don't need the vector database for 4 objects, right? Because you can calculate, you can do the calculation, by CPU there or by code, and then you can do that. However, if you go more objects, like let's say 100 objects, 1 million objects, 2 million objects, right? Then the latency is going to be linear. So the more objects you have, the slowest it's going to get if you calculate by brute force, right? So if you have like 200,000 objects, and then comes in a query, and then you calculate each object every time. So this will not scale. So then this comes in the HNSW, which is an algorithm for better search. So instead of doing the brute force, you have a distribution, like a pyramid. So the top layer is going to be, sparse, and then you do the calculation with the top layers. Then you go down based on the closest object that you have on this top layer, right? So as you can see here, the top layer, the layer 2, this is our query. We search, and this was the object that is closest to the object we have. Then we go one lower level that's going to have more objects, and then we're going to do the search again, and then we go until we get the closest object from the query, and then we get the nearest neighbors, right? So this is how you can make vector search available through scale, and then we still get some low latency for the queries, right? And it is interesting because in this example, I only showed you about text. But now it is interesting because this applies not only to text, but also to, video, to audio, to image. So it is really, really cool what you can do with that, right? So for example, if you're not Brazilian or Portuguese, the word meow is the same of meow, like what a cat could be doing in English there. This is meow. And if you have a multimodal example, and we do have this example, I can send the link later in our GitHub there. I index all those content. I can index like an audio, a video, and all that. And when I search, for example, meow, I can find the cat. Or if I send an audio of a cat, I can find the picture. Or if I send the picture, I can find the audio, right? And the audio of the cat and not the dog, because the model is going to understand that audio is closer to a cat, right? So it's really cool. So this is the link you can reproduce. This is going to use local inference model called Bind, which is from Meta. It is not open source, but you can run in your machine. It is very heavy, so you need to have a good computer. If you have GPU, it's faster. Okay, so now we know about the vector search, right? So we can do this vector search and calculate. It's automatic and it's very nice. But also we have what is the state of the art of a textual search, right? And then come the BM25, which is a very old algorithm already that can calculate, but now not with the vector, only with the text, right? So there's a tokenization step that all the content get tokenized. And there is some algorithm there to identify based on the bag of words, the relevance of that object through the query. And which is nice because in Weaviate, you can mix those together, right? You can do a hybrid search. So what is a hybrid search? It is one vector search and then one BM25 for textual search, and then we fuse those results, right? We fuse the distance that we find from the vector with the score that we find from the textual search. So this is the hybrid search, and it is interesting because you have a lot of tunes that you can change. You can go, there is one called, for example, alpha, that you can go more to vector search or more to hybrid search. You can get weighted properties to the textual search. So let's say that the title, you want to have a better weight to the title. So these you can change those knobs in order to have a better search for your use case, right? So this is the hybrid search, right? So you have the traditional search, which is the keyword. That's not that filter. It's the actual search that we do with BM25 and all that. And then you have the vector search, and then you fuse those results. And then you can ask, okay, what about RAG, right? The retrieval augmented generation, right? This is basically all that search that you can do. You get the most relevant content, you retrieve the most relevant content, and then you're augmenting the content, the context that you have, and then you generate this content, passing that to a LLM model. Okay, so this is a big view of, big picture of this RAG process. So as you can see, you have here the chunks. You ingest your chunks. Okay, you ingest the chunks. So you retrieve. So let's say a query comes. You already have the content ingested, vectorized and all that. Now let's say a query comes in. Then you're going to vectorize that query. You're going to do the vector search in your vector database. This is going to return you a context that you're going to use to pass a prompt and then generate the answer, right? So this is RAG in simple terms, right? And let's see, okay, yeah. So basically, this is the gist of it. To be very, very, very fast, but I believe that use cases, for example, not only the RAG, but one that is very important, very interesting, is recommendation and understanding how recommendation works. It was like, at least for me back in the days. So I'm just going to explain the recommendation before I pass to my friend Dima. But basically, let's say the recommendations that you have, there is a way, for example, in Weaviate, you can do ref to vec, which means that let's say that you have a profile or a customer, right? And then you have all the interactions that customer had with your system. Let's say that he liked the product, he bought actually a product, he had a product to the wish list or something, right? So all those interactions are going to become a vector, and all those vectors that are the interactions are going to be a centroid, right? It's going to have a kind of an average that's going to compose the vector of the customer, right? So now you have a nice representation of what that customer likes or what they doesn't like, right? So now let's say that comes in a new customer and then he just likes some product, or he put a product on a wish list, right? So as soon as you get the interactions from that customer, now you can position that customer close to a customer that you already have, right? And then of course, that if that customer that you already have already bought some of the products, probably the customer that's coming new is probably going to be interested on those products, right? So this is another use case, for example. And there's a bunch of other use cases that we keep finding. And then in order to apply all of those use cases, we have a brand new Weaviate Java client that my friend Dima is going to talk about. So Dima?
Stage is mine. Should I share the screen then instead? Right?
Yeah, you can if you want to.
Yeah, go ahead. As soon as you share, I will add it to the stream.
All right.
And thanks, Duda, for the great intro. I'm sure I will have to reference a lot of people to the specific part. When I'm doing talks, it will save me a lot of time.
My pleasure.
It's always exciting to see demos, so let's see how it goes.
Yeah, may the God demos be with you, Dima.
Yeah, they will be.
Yeah. All right. So it said there on the tips when I was sharing the screen that it's best to do it with two screens. I unfortunately only have one at the moment because I'm in Amsterdam for another conference starting tomorrow. So bear with me, right? I cannot see you, my audience, but I hope you can see and hear me clearly. Right. So as I said before, my name is Dmytro, right? I'm working on the new rewrite of our current Java client. We already have one. It's been written because, well, of course, there's been a demand for it, but it's been done a little bit hastily, right? And now we're learning from our mistakes. Now we're seeing what patterns worked with other clients like Python and TypeScript, and and we're trying to bring that experience and bring like something very convenient for Java client as well, and right to contribute it to the Java community. And before we start to look at the client itself, I'm just going to quickly go over why would we even put a lot of effort, right, in a good client library. Why does it matter specifically for us, right? And if you think about what a vector database is, right, it's a very novel product, and it's a product that is not your traditional RDBMS, which means that the ubiquitous SQL language, which we all know and love, right, it just does not translate very well to all the concepts. And so there is no, at least at the moment, there is no shared query language for all the vector database. So effectively, what you have when you want to interface with a vector database is either the raw REST or gRPC API or a well-structured client, right? And what we're aiming to do via this client library is to provide our users, provide the developers with a idiomatic Java-specific or like language-specific query language for our vector database, right? Because of course it increases productivity working with a well-defined, well-typed client library is much faster than developing your own. It facilitates learning, which is very important because it is, as Duda mentioned before, there's a lot of concepts that might not be familiar to any developer, even if you worked with a database as such before. There's a lot of novel concepts, and we believe that building a good client helps you discover and learn about these topics in a progressive manner as you dig deeper into your use case. And of course, we want to reuse the familiar constructs and familiar idioms that we already have in the Java language, right? That other libraries already use. And we want to base our design on that, right? So with that being said, our focus with this rewrite is on developer experience, right? So we're trying to leverage static typing as much as possible. I'm not going to dig deep into or discuss at length the previous client, right? But we did make a sort of a mistake of using a untyped map, map data type way too much in way too many places. And it's not very intuitive, right? It's much easier if your IDE, if your type hints can offer you suggestions as to what arguments to pass and can catch errors early, of course. So we're trying to come up with a very expressive syntax and with a consistent sort of design language, right? Such that if you learn one part of the API, you should be able to translate that knowledge and that feeling of how the query language works to other parts of the API without having to go back and forth between the documentation and your IDE every time. Right, and now on the very kind of backbone aspect of it is the fact that we've added a gRPC. We did added a gRPC API recently, and gRPC offers a lot of performance gains just by its own nature, which the new client is going to benefit from, right? The old client uses our older GraphQL API, which has some overhead, and the new client will use gRPC communication for like most performance critical queries and steps that you'll have, right? So, sorry, that was a bit of a spoiler, right? So what was the thing that there was a lot of in the older client, right? It was a builder pattern. It was ubiquitous because it is a very useful pattern, right? Java does not have optional arguments as such, right? There is overload, there's function overloading, there is no optional arguments, and having the flexibility that optional arguments give you is very useful for trying to define something as, powerful as a query language, right? You cannot just shoebox a user into a specific, like number of arguments, a specific way of providing them, and you need that flexibility in order to build to adapt each query to every use case, right? So how do you circumvent that the crazy amount of builder patterns that you have in some client libraries, and our own Java client library is one example of that. One design pattern that came up with was we reimagined the builder pattern, right?
Before you go ahead, sorry to interrupt you. I'm gonna take your screen off so that you can take a look at what I will say. If you go to the settings here on StreamYard, you click on the three dots on your profile, and you go to settings on the microphone. Maybe if you can remove the cancel background noise, I don't know how it is written in English. I think it will stop cutting your voice, because sometimes when a car passes by, yeah, it impacts your voice.
I'm very sorry about that. Sorry, how did you say I could do that?
Yeah, on your you'll see your frame down there on the background, on the backstage. You can click on the three dots.
Yeah.
Settings, and then you can uncheck those boxes. And don't worry, all of these will be also. By the way, so in the meanwhile, while you are searching for that, all the sessions are gonna be translated in terms of the subtitles. So we are gonna polish all the subtitles to Portuguese as well. Did you find it?
No, unfortunately. Oh yeah, wait. I have microphone settings.
I believe you can go to configurations. Right to the.
It's not on the computer. It's on StreamYard.
Yeah, exactly. That's the thing.
To the side of for camera, you go to configurations and then audio and then echo cancellation probably.
Or background. No, you cannot. I will add your screen to the stage real quick.
Remove from stage. I see edit name, edit avatar. Oh,
let me see. Oh, it doesn't show the settings. Okay, I see.
No, you can go to settings. That's in the main one, the bottom.
Oh, I can do it for you. I can do it for you.
Oh.
Now I can see this. Now I can see settings. Now
I just did it for you now. Sorry for this. I'm also learning. So let's go. Sorry to interrupt you, my friend. You can share the screen again, the presentation.
No worries. I enabled the echo cancellation and reducing the mic back noise. Yeah.
All right, let's go now. Back to the demo. Okay.
Yeah.
Show me the code.
You can see that. Yeah. Show me the code, right? So the pattern that we came up is something that we call a tucked builder, right? And the idea is it is something. So that's what you'll see here, right? The B arrow syntax. The idea is whenever you have some method, right? In this case, that's an example of a near query, near text search, right? Which has some required parameters, such as the query that you want, and some optional parameters, which configure all those additional, they have all those additional toggles that Duda mentioned before, right? Where you want to adjust how the database will go about searching the matches. Those are optional parameters, right? So what you do here is you, instead of importing a builder, instead of importing another class and having to actually discover that in the first place, right? If you're using a builder pattern, you need to know that this class has a builder, or this class has a method that create me a new builder, and then you have all of those builder build invocations spread throughout your code base, right? What this pattern allows us to do is to hint the user at what exact options are available for this query without them needing to go to the, as I said, go back to the documentation or import any new classes, right? Simply by having another parameter, which is pretty much a lambda function, right? It's this familiar lambda syntax, which just gives you, pretty much passes you that builder inside. So that B object here is the builder itself. It's just hidden away. It's tucked, right? Allowing you to pass all the properties that you want or not, or just use the bare bones so this is kind of the cornerstone of what the new client is based around. It is this is the familiar pattern that I mentioned before. This is the consistent one that we are planning to reuse throughout the whole API, such that you can learn this very simple rule that, you know, the API kind of you'll have some query methods or methods for creating collections or configuring vectorizers or perhaps creating backups, adding tenants, removing tenants, whatever that may be. This pattern will be consistent where the required parameters, the IDE will sort of tell you about them because they will come first, and you will know because they're strongly typed what to pass there. And then all the optional parameters are discoverable if you just start creating the second argument, right? As soon as you say comma and you start creating that lambda function, the IDE immediately suggests to you what are the next possible parameters that you can provide for this query specifically, right? So that's also something to take off the developer's mind, trying to remember if, you know, because near text and near vector and BM25 and hybrid searches may have different parameters, right? Different values, different rules there. And that's something that should help take the burden off the developer's mind, right? Very briefly, you might think, well, very well and nice, Dima, right? But what if my business logic requires me to build up the query as I go? I cannot just, you know, provide everything at once, as this example shows, but rather I want to do it in steps. And the underlying implementation of this pattern allows you as a developer to pick any of the three patterns where you can either pass all the arguments exactly at the point when you're running the query. You can pre-build the query before, because you may, you may have, separate modules, building queries, separate modules, executing them. And then if your logic is complex enough and requires that, you can also use the builder pattern itself, the very familiar one, right? And then construct the query as you go, with conditional statements and so on and so forth. You know what the builder pattern is. Yeah. So now, with that being said, I've prepared a very short demo to show you these three main searching capabilities that Weaviate has, and again, just to show you around the syntax how that works. So what we're going to use for this, we're going to use a Eminem songs dataset, because this is something I used for my coding interview when I was interviewing for Weaviate. I did my interviewing task with that dataset, and I thought it was very nice. And we're going to use our Weaviate Cloud Sandbox, right? So Weaviate comes with a cloud offering as well. You can self-host it. As Duda said, it's open source, it's available. But then you can also try out a managed solution. And for this talk, I created a sandbox cluster where I've uploaded these songs. I'll show you really quickly the UI, because it was quite easy to do, right? And then I just went ahead and experimented a little bit. I wrote some queries. I see what could be useful, right? So let's see the cluster first, right? So here's what the Weaviate Cloud user interface looks like, right? So this is my account. I've created some one cluster specifically for this talk, and in that cluster, I have created one collection with Eminem songs that have these 4 properties, right? They have a title, album, year released, and lyrics. There is a vectorizer configured for it. We're using our own Weaviate embedding service for it. This also comes together with the Weaviate cloud offering.
Dima, sorry,
right,
sorry
and
to
this is what
interrupt
we'll
you
be
again.
using to vectorize properties, right? To
Dima,
what Duda explained before.
sorry to
That will
interrupt you
enable
again.
us to perform near text, so any sort of vector search, similarity search on it,
Dima,
right? So these are the givens. Now, if we go back, so first thing that we'll need to do is we need to connect to the Weaviate cloud instance. Once we're done with that, we're going to have our client object, which we'll use to perform a BM25 search first, and then look at the near text and near vector searches, right? BM25 being slightly more familiar. Now, how would you connect to your cluster? If you go to your cluster, again, that's for someone who's eager to try it out, because the sandbox environments are free for the first 2 weeks, right? So as soon as you create an account with Weaviate Cloud, you can go ahead and create a sandbox and start experimenting. So you will the main 2 things you'll need to know is this REST and gRPC endpoints, which is how the client will know how to communicate to the cluster. And if you set up an authentication, right? If you send an API key, which you probably should, right? Just in case you're going to put some of your own, personal data in there, you're also going to create an API key. And with these 3, with these 3 values, we're pretty much ready to go, right? So now, demo gods, be on our side, because we are switching to VS Code, right? So this, the code for this demo is not on GitHub yet, because of some technical issues maybe pertaining to the hotel's Wi-Fi. But we will make sure to upload that as soon as we can. So after the talk, meaning you can get the project, try to run it locally, try to modify it and play around with it, right? So this this project uses only one dependency. It is, yes, it uses only one dependency, which is the beta release of the client 6 package that I mentioned before. Right, this would just disable logging for it. And what we're going to do, we're going to store our API key, of course, in the environment variable, just not to display it around. Now, connecting to Weaviate client is very simple, right? It just takes providing, you provide the HTTP host I mentioned before, the gRPC host. Both use the secure connection, so both will go to port 443. And here we're just going to pass the API key that we've just fetched from our environment variables before. With that, we've just established a secure connection to the Weaviate cloud instance, and we're ready to get funky with Eminem. First thing you will do, right, whenever you're working with a specific collection, is you'll obtain a handle for that collection, right? So with the use idiom gets you a specific handle that you will then use to run queries or insert data into a specific collection without having to come back and pass these parameters again and again. Right. So this demo is split in 3 parts. I'm going to go through them briefly here. In our first example, right, we're going to use the BM25 search, which is the keyword search, is the most familiar one, which simply takes a query of some words, and optionally you can specify which properties, which columns pretty much, right, which properties should Weaviate search against. I'm going to come back to these 2 operators later, and what we're going to ask back, right, that we get back from this query is the ID of each object that Weaviate is able to find, and the vector that was created by the vectorizer when the data was uploaded, right? So when I created the collection and uploaded all of the data, it was vectorized because the vectorizer was created for it, and now each song has that numeric representation that represents sort of the semantics of its lyrics and the title, which is how we're able to do this search, right? So the rest of the code is more for the, to have a pretty print. So this isn't something that we need to go deep into, right? But yeah, so this is going to be the first part. This is what we're going to do first, and with that, let's try to run the script. You'll see the output includes all of the 3 steps. So we'll just go in steps here, right? And if you see, this is the first thing we did. This is the code we ran, right? So we queried BM25 looking for rep god in title, and this is where you see the 2 result sets that I'm showing here. This is where this interesting AutoCAD feature comes in. Not going to go very deep on that because it's a topic of itself, but this is a very nice helper that Weaviate provides to you in order to sort of trim the results when they stop being relevant, right? What Duda mentioned before is that each vector, when the search happens, each vector receives a score, right? How similar is it to the vector that we provided in the query? And at some point, every vector is going to have some sort of score, but you don't want to receive all of those results back. So at some point, you want to say, okay, that's enough. This is when I draw the line, so to say, right? And the AutoCAD feature groups these objects into like similarly enough groups, right? And you say, so the first group is some songs that have the closest vectors, and the second group is just going to find this point where the distance between the vectors becomes, changes way too fast at that point. I will separate that into a separate group and into the third group and into the fourth group. And by using the AutoCAD feature, you can specify how many groups do you want returned, right? So in our first example, we've specified AutoCAD 1. And so the only 2 songs that were, that are in this cluster of the best matching songs here are the Rap God and its duplicate entry, right, of Rap God with lyrics on Genius. Now, if we increase that to 2, we get all the other songs that have something to do with those words, but they're not as similar, such as Rap City, Rap Battle, and so on. So this is our BM25 search. With that, if we just take the first object from that query, we can be quite confident this is the Rap God song. Right. Now, what we're going to do next is we're going to look into near text search, right? We're still providing a textual query. It's still a string. But now we're not just looking for keywords. We're looking for semantics. And what we're going to do in this example is we're going to, the syntax, you see, the syntax is exactly the same, right? It's songs is the collection we're going to use. We're going to query it. And this is the query method that we'll be using. So what we're going to look for is a list of terms or concepts. Each of them will be vectorized separately, and then we're going to use those vectors to kind of find similar entries, in our collection. And what we're going to do in this case, we're going to use different way of limiting the search space, right, or rather the result space, is we're just going to we're going to look for 5 songs that have something to do with cash or money, right? But let's say we don't want to get any song that has the word gold in it. We're just not interested in that in this case. We're providing this kind of, like a hint, I don't know, like a meta parameter to the database saying, try to stay away from these concepts, right? With such force and such force, right? These are parameters you're going to play around with because it's specific to your data, right? And then we're going to look at the right. We're also going to print the distance. We can retrieve that. That's what Duda showed before, right? And then what I did here with the output, we're going to see if we catch something that has gold in it, it means that our query didn't work, and we're going to see that in the lyrics. And if we see either cash or money, it means that we did find what we were looking for, right? And if you see when we run this query, we retrieve 5 songs, of course, and the number 1 song has these mentions, right? So that you can see he was able to find, there were 5 songs overall. This one had words money in it. And so he was able to pick that up. But of course, in this case, it was the best match because it literally had the word money in it, right? And now finally, to wrap this up, we're going to move into something that's, very data Weaviate specific. I mean, all the other things were Weaviate specific, but this one is vector search, right? So we're not working with textual data anymore. This is useful usually, I think, when you're getting your vectors from elsewhere, perhaps, or you already have a vector. You got it from, perhaps you got it from a different query that you now want to use to find similar objects. And what we're going to do in this case, we already have the Rap God song, and we're going to try and find songs that are most similar to it, but not that song, right? So what we're going to do, we have that Rap God song already, and we can retrieve from that result object, we can get the vector that the Weaviate stores for it. The name of the vector is text to Weaviate because this is the vectorizer that was used to create it. And what we're going to do here, right? We're going to use near vector search to search for songs whose vectors are similar to this vector, right? We're going to cut off results for a certain with a certainty level. So we're going to require that there is a specific score that each result obtains before it makes it to our result set. We're also going to limit to 3, and we're going to retrieve a distance to see, how close those 3 matches are, right? And just to show off the filtering feature that is also in the beta 1, we can use that simple, familiar filters from SQL requests as well, right? With this where syntax, right? You can say, so we're looking for songs where property year released is greater than 2015, so those that were released after 2015, and where title is not equal to Rap God because we don't want to get that result itself, right? And now if we look at the results of that execution, we do get 3 songs, which were all of them released after, right, 2015. You see the distance is rather small, so the smaller the distance, the closer the meanings are. The titles of the songs might not be similar, but the lyrics will be, right? Yeah, and with that, the demo is concluded, right? I don't know how we're doing on time, so I don't want to stretch it further. So I hope it was informative. And just I'm going to use my last minute to talk about the release plan for this client. So as I mentioned, yesterday we released beta 1, which had these features. Additionally, what we weren't able to show are aggregation API and async client, which is also now supported in this client. By mid-July, beta 3, I'm skipping some betas just, to keep it kind of interesting. What we're going to have is batch operations, object document mapping, right? Which means that you'll be able to use native Java classes to insert data into Weaviate and read data into native Java classes or POJOs. We're going to have hybrid query, right? The M25 query is already there. We're going to have sorting, iterator, and streaming APIs. And another month after that, we're going to finish off with dynamic RAG, which is also a very powerful feature of Weaviate, which was just too much to go into, I guess, this time, at least for the demo. The generative API and some more administrative things such as role-based access and backups. Right. So, with that being said, I hope it was interesting for you. If you're curious to use that, try it out. This is the package is available on Maven Central, so you can just include it in your existing project, or you can download that demo code for this talk, play around, see if the API feels intuitive, if you're able to make progress, if you're able to express your ideas in the query. And whether you do or you don't, we would like to hear back from you. I'm sure Duda going to mention like a good way to do it, right? Because as he said, he works with the community a lot. He knows about the channels of how you can reach back to us with any suggestions or any feedback that you have, right? And yeah, now I thank you one more time, and I hand off to either Duda or Karina. Yeah, whoever's
Don't
going
worry
to.
about the time. I'm taking away your screen, so feel free to switch back to whatever you want. You're free now to switch screens. This was amazing. Yeah, Duda, would you like to do any wrap up? Do you want to share the screen or anything?
No, just as Jima mentioned, that if you want to use and help, and if you say like, hey, I would like to suggest something, or even to contribute with the client, right? We have an extensive, we have the forums, we have an open Slack, and here Karina just added the link. We have a bunch of community events, right? So every week we have, this week, for example, we had, I think, 3 or 4. We have one tomorrow. So every week we have events. Every Wednesday we have a community office hours. So, if you want to join, if you want to learn more, join, because we have a very nice community working on there.
Awesome, very cool. And I love the demo, by the way. So I do have a question as someone who is very interested in using Weaviate actually. And I see that you have a SaaS offering as well, which makes things really easy and that developers can use to try as well. But I wonder if Java developers will be able to do things like the thing that actually caught my attention when I heard about the generative feedback loop. I saw a demo on TDC that Duda did, and I wonder if we would have all the operations available to do that type of operation, Duda, using the new Java client once it's out, not the beta one.
Yeah, I believe it is possible, right, Jima? Because the generative feedback loop, it's basically, so you generate
Let me step back. Can you just tell everybody who's watching what is this that I just mentioned? Because this is very special, and this is how you can actually do advanced stuff without having to train the LLM, right?
Yes. So, for example, the generative feedback loop, it's basically, let's say, for example, for one nice example, let's say you have a lot of talks, right, for this event, for example, and then you have the description that is saying about what's the talk about. So what you can do is that, let's say that I want to create a system to search for the talks and then maybe understand possible questions.
I can make it simpler for you. Me, as the event organizer, I am trying to use Claude with MCP to try to do stuff, but it's pardon the word, but it's dumb. It just can't find stuff. Even with MCP, access to the file system with the sessionized JSON files and all the data, it's not that easy. It simply doesn't work.
Yeah. So let's say that you can now get the description, from each talk, and then you can generate some questions. Let's say like, hey, based on this description, generate some questions and reinsert those questions into the event, and into the session itself. So now you are generating some content, and then you are adding that back. Let's say, for example, you have a product that you have a bunch of reviews of that product, right? And then now you want to generate one that is, one big review with as a summary of all the other reviews, and this is going to be easier to be searched, and it's going to be easier to be shown to the customer. So now you can get all those reviews, generate a new review, and insert that back into the product, right?
So basically,
I believe that right now you can do with the
because this is just like a way. This would be a way to use Weaviate in the operations, right? Just like a practice. Or is it a feature?
No, it's just something that you can do with the you can grab data, generate content, and insert that back. So now that generated content is going to be a part of the object itself.
This would be valid for all the other cool stuff that I also saw on Weaviate, such as the advanced, like adding some, I don't know the right word, so please bear with me, but like additional information like metadata that makes it easier for the database to retrieve the right things, not just a part of the text that would be right if we just had just a little bit more. So this polishing of the data when we are creating the chunks of data, right? So all of this stuff will be available for Java as well.
Yeah, no. So for the chunking, you do that before, right?
Yes, that's what I mean. Like all this stuff that I heard, because people already have your links and they are able to go over there and see the details about what I'm mentioning. If you can also give some overview, but it's just that I learned a lot from you guys on the topic of RAG, and I want to use it with Java. So that is why I'm asking if all of this stuff will be available too. Dymo, I think you're on mute.
Yes.
Yeah, I was on mute indeed. So Java client is going to support every API and every capability that any other client supports. So what Duda mentioned was, I think, the generative API, where you can query for something, for some objects, but then you can also give a task to let's say an LLM to generate some additional summary of that, and then you can work with it, right? You can reinsert it back. And there's also dynamic RAG, which I mentioned, which is also going to come into like beta 5, so around August. It will be in Java client as well. Yes. So whatever whatever Weaviate is able to do, you'll be able to do in Java as well.
Perfect. That is the answer that I needed. Whatever I saw will be there. Okay, perfect. So you said
including new features also, Karina. New features that we release. The idea is to have all the features in all clients.
It's been a year.
Java is a first
have a lot of
class.
new cool stuff. It's been a year since I last saw it. Cool. So August, you said, feel free to reach out in case you want to give us an update on the So Java channel. You are more than welcome. All right.
Yeah.
Awesome. Yeah.
Perfect.
Thank you for the event. Thank you. It was a pleasure, and thank you for the invitation. And hope everybody enjoyed that as we enjoyed doing it.
Thank you for joining. You're in Amsterdam. So it's probably late for you. Thank you anyway, Dymo.
I think it's still bright outside, so it's pretty good. Yeah.
Okay, and thank you to Duda. You guys are awesome. Thank you very much.
Nice pleasure. Bye.
Bye, guys. And with this, we wrap up our day 3. Yeah, today is Wednesday, so we are wrapping up our day 3 of the celebration week with a lot of content. Wow, this was crazy. Tomorrow it's gonna be even cooler, so don't forget to bookmark our event page, because I'm gonna reach out to the speakers and grab the assets, like the links to their demo repositories or to the slides they used, any resource that they have shared with us throughout the week. I'm gonna reach out to each one of them, and I'm gonna add it here on our event page. So you can also always go there in order to come to the event. So you can click on the join live stream and immediately be redirected to our session that is going to be live on the day. Tomorrow, we will start with Java 30 Years of Innovation with Luis Real. That's going to be a session in English. And we will have a lot of cool stuff, including Sebi from Red Hat, for those who already know him. So here it is. Let me just show you real quick before we wrap up. Here you go. We're going to have Luis Real talking about 30 years of Java. We're going to have Sebi. We're going to have Barry Bird, Bruno Souza, Mike Redlich. I still don't know if this is the right way to say his name. I think so. And Tim Withenau. Today's going to be a blast. So assure that you're going to go to our YouTube channel here on So Java. Activate the bell on the stream tomorrow so that whenever we go live, you are notified immediately. Okay. Thank you very much for listening and for attending our day. And I'm looking forward to seeing you all tomorrow as well. Bye.